Welcome to my YouTube channel, Brainy Course. Please like and subscribe my channel. Your support is the foundation upon which we build captivating content. Thank you for subscribing and being part of our creative fortress.
I want you to think of ChatGPT and these large language models as tools that you can use to give your ideas form, to give your thoughts, realization, to be able to explore lots of different concepts and be able to refine them over interactions with the tool. I don't want you to think of these tools as something that you use to just write essays or answer questions. That's really missing the capabilities of the tools. These are tools that really allow you to do fascinating things. So now I'm going to try to give you an example of this to hopefully motivate you that these tools have immense capabilities and that those capabilities can allow you to do things that would be very difficult to do otherwise. So what is a task that I thought of that would be, something that we could all relate to? And I thought about my family, and I thought about this crazy idea. We have this great restaurant from Uzbekistan that's in Nashville. We have a great restaurant from Ethiopia. We've actually got lots of great Ethiopian restaurants. And I thought to myself, what would it look like to create a meal plan that was based on a fusion of cuisine from Uzbekistan and Ethiopia? What would that look like? And in the past, I've eaten keto, so could we try to make it kind of keto? Because I still kind of like to limit my carbs. And, at the end of the day, realistically, I'm going to have to buy all the ingredients for this. And if they're not easily accessible at the grocery store down the street from me, I'm probably not going to cook the meals. So I thought, well, let's go to ChatGPT and see if it can help us with this problem, if it can help us prototype what this meal plan might look like. So I went to ChatGPT and I said, please create a meal plan for my family that is based on a fusion of food from Ethiopia and Uzbekistan. I want to eat keto and up to 2,000 calories per day. Pick dishes where the ingredients are easy to get from an average US grocery store. Now this is a hard problem, right? I don't think that there's a human on the planet that could easily answer this question. And if they are, I probably could not find them. It would probably cost me too much to hire them. And they certainly couldn't do this as fast as I'm about to get it done for me. So I asked ChatGPT to do this for me, and ChatGPT says, here's a sample meal plan that combines flavors from Ethiopia and Uzbekistan while also being keto friendly and within a 2,000 calorie per day limit. Breakfast, scrambled eggs with sauteed onions, tomatoes, and Ethiopian berber spice. Now notice what it does. It puts in parentheses, it says, made with chili powder, paprika, garlic powder, ginger, cumin, and coriander. Now what it's signaling is berber spice is something you can get at the average US grocery store. All of these spices are easy to obtain from a normal US grocery store. So not only is it answering my question, it's giving me an Ethiopian breakfast dish, it's giving me information that I'm going to be able to get these spices. Now, I don't know enough about Ethiopian cuisine to know if this is a really accurate dish. It may not be. It may be sort of inspired by it and very Americanized. But I'm still, for me and what I'm trying to do, this is pretty impressive. It then goes on to say, lunch, Uzbek-style lamb kebabs with grilled vegetables, bell peppers, zucchini, eggplant, and a side of cucumber and tomato salad dressed with olive oil and lemon juice. Now you notice all of this is pretty keto friendly too. Now some people could take issue with the onions, but it's a really good first start of giving this crazy idea I have form. Now, it may have errors in it, it may not be perfect, but I could go and work with this and refine it and start improving it. And that's one of the things I want you to think about throughout this course is don't think of this as a one-off. I give it a question and I look at the answer and I say it's good or bad. No. So I went back to it and I thought, well, one of the things that I'm really missing from this is I don't know how much to eat. So I said, can you give me an approximate serving size for myself for each dish that is within my 2,000 calorie limit? And ChatGPT says, sure, here are approximate serving sizes for each dish based on a 2,000 calorie per day limit. Breakfast, scrambled eggs with sauteed onions, tomatoes, and Ethiopian berber spice mix. And then it has in parentheses 2 eggs, half a cup of onions, half a cup of tomatoes, 1 teaspoon of berber spice mix. Served with a side of sliced avocado, 1/4 medium avocado, and it goes on to give me now serving sizes for each of these different dishes. Now, again, I didn't go and I didn't take it into like some calorie calculator and look at the macros and check if it really fit my diet, because I was just fascinated about prototyping this idea, exploring this concept. And I could keep refining it. I could keep looking and improving it, asking it to break down things, really and analyzing and making sure it exactly fits what I'm looking for. But instead, I want to do something kind of different. I'm going to go and continue this thread of conversation, this crazy idea that I had, and give it a little more form. And so what I thought about is if I was really going to take this crazy idea into my family, I'd have to think about my 9-year-old son. My wife and I are more adventurous eaters, but my 9-year-old, he's not always going to want to eat everything that we come up with. And so I thought, well, what could I do to help him get excited about trying these things out? And so I thought, I can go back to ChatGPT and I can try to get ChatGPT's help with this. So I said, ChatGPT, my son is 9. Sometimes he won't try new dishes. To make this culinary adventure more fun for him, can you create a short Pokemon battle story to go with each dish? And if you're not familiar with Pokemon, it's trading cards and a game and a cartoon. My son loves it. I will read the stories with him before dinner to get him excited about trying the new food. Make sure the story ends with a cliffhanger that will motivate him to try the new food. Now, maybe I could find somebody who could give me a meal plan based on Uzbek cuisine and Ethiopian cuisine, but and make it keto and do all those things and look it up. I'm not sure they could do it anywhere near as fast, but now we're really moving into territory where it's going to be hard to find a single human being, and to get somebody to do all this is going to be expensive, and I'm doing this in a matter of minutes. So what does ChatGPT say? Certainly. Here are some short Pokemon battle stories to go with each dish. And then we had the breakfast dish with the berbere spice, and it says, story, Pikachu and his friends were exploring the wilds of Ethiopia and they were suddenly ambushed by a group of sneaky Pokemon thieves. And it goes on to have this berbere dragon that they're battling. And then it says, in the end, they emerged victorious, but not before the dragon left a fiery spice that imbued their breakfast eggs with a flavorful kick. Can you help Pikachu and his friends defeat the berbere dragon and enjoy this spicy breakfast? That's pretty amazing, right? We've gone from a meal plan to now help my son get excited about eating this by mixing in some concept that he's really excited about, and it's actually produced a cliffhanger. Is this the best cliffhanger? Maybe, maybe not. But does it matter? No, because I'm rapidly sort of experimenting with my ideas. I'm trying to give my thought form. I'm trying to understand what this would look like, and I could go and I could refine it and improve it further, but it's already done a pretty good job. I could probably take this and read it to my son and have him more excited about trying the dish. So then I thought, well, let's take this crazy idea further. So we're going to be sitting at the dinner table. We're going to read these crazy stories that ChatGPT has generated for me to try to get my son excited about eating these dishes. I thought, what else do we do at the dinner table that I could weave into this? And I thought, well, one of the things we do is we talk about what my son is learning at school. And one of the things he loves is he loves learning math and playing math games. And I thought, well, is there a way I can integrate that into this whole crazy idea? And I said, ChatGPT, I would like you to play a math game with my 9-year-old to teach him about division with fractions and nutrition. Ask him questions one at a time involving Pokemon in these topics and make it into a game. When he wins, the Pokemon win. Ask the first question. And ChatGPT says, great, let's play a fun math game involving Pokemon and nutrition. Question 1. Pikachu and his friends are planning a meal that includes half a cup of cooked rice, but they need to divide it evenly among 3 Pokemon. How much rice will each Pokemon get? And it gives him a hint. And it says, if you get stuck, feel free to ask me for more hints, for guidance. And what does it do? It then waits for my son to respond. So we go and we type in the answer. We type in 1/6. Now notice, before we were asking it questions, and now it's asked us a question. We've told it to create this math game. It's now asked me or my son a question. I'm typing in 1/6 as the answer. And now ChatGPT says, good job, that's correct. Each Pokemon will get 1/6 a cup of cooked rice. We got this answer by dividing 1/2 by 3, which gives us, and it works out the math for us. And so we went from, a meal plan, this crazy idea of a meal plan that's based on food from Uzbekistan and Ethiopia, that's keto friendly, that I can get at an average grocery store. We then added serving sizes or portions to it. We then took that and we got it to generate Pokemon battle stories with cliffhangers that would help my son get excited about eating these dishes. And then I created a game, a math game based on nutrition and Pokemon to go along with this to make it even more fun. And then I thought, well, what else can we do this? I mean, let's really give this thought some form at the end. We've gotten the meal plan, we've gotten the stories, we've got this game. Can we give the game real form? And so I used some of my domain knowledge as a computer scientist to say, let's create code for this. So we're actually going to produce software for it. So I said, let's create code for this in Python, but I want it to be a web application. And I'm not going to go through all the details because they are domain specific. They use my knowledge of computer science. But the key thing is that ChatGPT then generates actual software, the code for software for this. I'm not going through all of it, but the important piece of it is when we get to the end of it, we actually have real working software that I could run on a computer to play this math game with my son. And so you can see that we took some simple idea and we rapidly prototyped it into all kinds of different forms. And at any point in time, we could go and we could further refine one of the forms. So we could take the meal plan that didn't have information about how much to eat, portions, and we could add that into it. We could reshape it into a completely different form. We could then eventually get to the end and take some form that we had created and take it out of the language model and turn it into software. And so that capability of taking our ideas and rapidly iterating and prototyping with them, that's just one example of the type of thing that we can do with these large language models like ChatGPT. Now, I hope this example helps to get you inspired about the capabilities of what you're going to learn to do within this course. Welcome to this course on prompt engineering. I'm Jules White, and I'll be guiding you through this exploration of an absolutely fascinating topic that I'm really excited to talk to you about. I'm an associate professor in computer science at Vanderbilt, and I'm the associate dean of strategic learning programs in Vanderbilt School of Engineering. I'm going to talk to you about this really fascinating and timely and important topic for all of us, which is how do we interact with large language models like ChatGPT? Now, I really hope that this course inspires you to start using large language models like ChatGPT. And we'll talk about what large language models are in more detail in this course. But you can sort of use it interchangeably until we talk about it as ChatGPT is a large language model. Now, we've seen a lot of back and forth and discussion in the news about what are these tools. And what we've really seen them presented as, in some respects, as tools for cheating on exams or writing essays. We've seen them presented as tools for plagiarism or tools that are going to take over the world. And I really want to reshape your discussion of these tools and make you see that they're also, and primarily from my perspective, a new tool to really help unlock human creativity, to allow you to do things that you couldn't do before, to actually take your thoughts and give them form and do it really rapidly. These are tools that allow me to do things faster and better than I could before. Now, I came into computer science. I actually started from visual art. I went into East Asian studies for a while, and then I ended up being a computer scientist. But I've always really had a passion for creativity and understanding how I could use different mediums, be it paint or ceramics or code, to do interesting things. And I look at large language models as sort of a new fundamental medium. I can use it for programming, but I can also use it to create art. I can use it to improve my writing. I can use it to help perform thought experiments. There's so many interesting uses for these large language models like ChatGPT, and we're not properly seeing them discussed. And so what this course is really about is it's teaching you how to leverage all of these interesting capabilities of these models. But in order to leverage these capabilities, in order to go and do the really creative things, you have to understand how you write prompts. And that's what this class is about, is how you interact with ChatGPT or another large language model. A prompt is what you write and give to ChatGPT or another one of these models to get some type of output. But these are fundamentally really exciting tools that I think expand the capabilities that we have as humans to express ourselves, to explore new ideas, and to create realizations of our ideas faster than ever before. Now, to get started on this course, I've actually enlisted ChatGPT's help to welcome us to the course, tell us a little bit about what we're going to learn. ChatGPT says, "Welcome to the course on prompt engineering. In this course, you will learn about the exciting field of prompt engineering, which is all about creating prompts that can program large language models to produce high-quality outputs." Now, don't worry. We'll talk a little bit about this. Do you need to be a programmer? We'll ask ChatGPT in a second. We will explore the different types of prompts, their patterns, and techniques for refining and improving them. You will also learn how to use large language models for various tasks, such as knowledge exploration, prototyping, content production, and assessment. By the end of the course, you will have a better understanding of how to effectively use large language models and their potential to shape the future of computing. Let's get started. Well, my first question that comes up out of this is, I want to make sure that I don't have to be a programmer to benefit from this course. Do I need to understand programming to take this course? No, you do not need to have any programming experience to take this course. The focus of this course is on creating effective prompts and using large language models to achieve your desired outputs. While an understanding of program could be helpful, it is not necessary to understand the concepts and techniques we will be covering in this course. What other things might be helpful to me to know before taking this course? While programming experience is not necessary, it would be helpful if you have some familiarity with basic computer concepts such as file management, opening and saving files, and using a command line interface. Now, by command line interface, we mean something like ChatGPT. Additionally, having good writing skills and the ability to think creatively will be important in generating effective prompts for large language models. Finally, being open to exploring new and evolving technologies and approaches will be key to getting the most out of this course. So there's really not a lot you need to know. As ChatGPT has aptly said right here, you need some basic understanding of computer concepts. You need to be able to open up ChatGPT. It calls it a terminal, but you can think of it as you need to be able to open up ChatGPT and interact with it. Obviously, if you can't use a tool for this, you're going to have a hard time opening files. But the fact that you're here probably means you have the right computer skills to do this. The second piece is something I want to talk about. Now, we think of these models as something that came out of computer science, but they're actually things that having experience writing, being able to think about writing clearly and effectively is actually really helpful in this. My father was a professor of creative writing, and it's been really interesting to me because this is helpful to me when I am working with these tools, is to think about what I learned from him and how I design the prompts. And finally, I want to emphasize this last point. Creativity and an openness to exploration is really, really important with these tools. The creativity of the human that's putting in the words for the prompts, who's deciding what goes into that prompt, and the organization and what gets asked and what instructions are given, are fundamentally important for using these tools effectively. Now, we've heard a lot about these tools as like they are plagiarism tools. They are tools to do, X, Y, and Z bad thing. But the truth is, if you really want to use them effectively, you have to be skilled. You have to be a creative thinker, a creative problem solver. The more creative you are, the better the outputs are going to be. You also need an openness to explore. You have to remember, this is very early days for these tools, and we haven't developed the best practices in all the different domains for how we're going to use these tools, for how we're going to write prompts, for every domain from healthcare to customer service to creative writing, whatever the domain is, we're still figuring out how to write the best prompts. And so having an openness to go and explore and try out different things is really important. In fact, when you're programming with these tools or working with these tools, and don't get scared because I said programming, because you'll see that you can program with these tools. Anybody can, just by writing normal human language. But when you're working with these tools, often you need to go and try out different things. You need to try something and then be open to trying a different variation on it and seeing what happens, running little experiments. A lot of times in life, it takes so much effort to write something or to generate some program, some software, or whatever it is that we're trying to do, that we don't get to explore as much as we should. We don't get to think enough about design. We don't get to think enough about the big ideas, the problems we're trying to solve. And one of the things that's good is an openness to explore in using these tools. So, what are some of the key concepts that we will learn in the course that will help us with problem solving? In this course, we will learn several concepts that can help with problem solving, understanding what prompts are and how to use them to program large language models to generate high quality outputs, learning how to create effective prompts by tapping into patterns from training data, being specific with our inputs and using patterns such as the persona pattern, question refinement, and cognitive verifier, understanding how to refine prompts and use techniques such as rewriting, combining, splitting, and expanding to achieve the desired output, learning how to use large language models for various tasks such as knowledge exploration, prototyping, content production, assessment, and more, understanding how to use few-shot examples to teach large language models new tasks and how to format these examples properly to achieve the desired output. By learning and applying these concepts, we can effectively use large language models to solve problems and generate high-quality outputs across a wide range of applications. So I hope that as we go through this course, that you will become inspired to take the ideas that you're learning, to go into ChatGPT or whatever tool is available to you, and to try them out, to explore the things that you're passionate about, and to see ways that you can unlock your own creativity, that you can give yourself more time for high-level thinking and problem solving, as opposed to being down in the details of how you give your thought form. So throughout this course, one of the themes you'll hear from me is try to give your thought form through this tool. Use it as a tool to accelerate your ideas into realization. So I look forward to exploring this fascinating concept with you, this fascinating topic of prompt engineering. To help you understand why prompt engineering is so important, I'm going to give you an initial example that shows where we tap into really complex capabilities of ChatGPT, but you can also do this with other large language models. And the way we tap into these capabilities is by using a pattern that we can use when we're writing prompts to get into these really interesting abilities of the large language models. Now, if you know these patterns, and we'll talk about them in detail in this course, you'll be more effective in writing prompts. You'll be able to do things that other people won't be able to do as easily. Now, I'm going to give you an example. It's going to use something called the persona pattern. Now, I'm not going to go into detail about the persona pattern at this point, but basically it's a pattern that we see all over the place. You'll see lots of different examples of this pattern out there on the internet, where people talk about using it to do lots and lots of different things. But the basic idea is you're going to ask the large language model, in this case ChatGPT, you're going to ask it to act like a particular persona. So now what does that mean? It means like you're going to ask it to act like a person or some inanimate object or an animal or some system. There's all kinds of ways that you can use this. So it's really, really interesting. But we're going to use it in this example to tap into a persona that is close to me, but one that I know nothing about the domain. So one of the really useful things about the persona pattern is you can imagine if you needed to go phone an expert to get help on some problem, you know who you would call, but you don't know exactly what they would tell you or how they would analyze your problem. And so I wanted something where I know an expert that I could go to. In this case, my wife is a speech language pathologist, so I could have her look at the output and tell me how good it was. But I know nothing about being a speech language pathologist or how to do their job. So I imagined that when my son was 3, he was not saying things properly. And so I went to ChatGPT and I said, act as a speech language pathologist. I'm going to tell you what a 3-year-old said and you will write an assessment for me. The child said, I need way woy. Now you can imagine this might just me being a parent, hearing it incorrectly, the child's not pronouncing things correctly. I don't know the right way to even capture this, to even express what's being said in words, the right way to do all of this. So this is a complex problem from my perspective. Like, I don't know how to express all of this in language, even to ask the question properly, but I know I would go to a speech language pathologist and I would describe this to him. I tried to think of something that sounded like something my son might have said at that point in time. So what does ChatGPT say? Well, you notice first off, its output looks like a report. It says subject assessment of a 3-year-old speech sample, child speech sample, I need way woy, has it in quotation marks, and it says assessment. Based on the provided speech sample, it appears that the child may be experiencing some phonological and articulation errors, which are common in children around this age. I don't know what phonological or articulation errors are. I would not have known to ask ChatGPT for these things, but based on this pattern that I'm using, this persona pattern, I'm tapping into this capability for ChatGPT to look at this and know what the right things are to tell me. So it says there's phonological and articulation errors. So it says the child's utterance appears to have errors in consonant production and possibly some difficulty with syllable structure. And so it says consonant errors. It seems that the child is having difficulty with the production of some consonant sounds, specifically the N and L sounds. The child said mead instead of need and woy instead of toy. And then it has in parentheses its assumption. It says, assuming the intended words were need and toy. Because you can remember, my speech sample was I need way woy, which my wife told me it wasn't a very good example, may not be something that a child would actually say. Despite that, it's still figuring out this is probably what, if that's really what the child said, this is probably what they were intending to say, and it's figuring that out. And then it's telling me they're having consonant errors. They're replacing, they're specifically having trouble with N and L sounds. Then it goes on to say syllable structure. The child's production of the word way may indicate some difficulty with the correct syllable structure. It is possible that the child intended to say play, but produced way instead, which suggests a substitution of the initial consonant cluster PL with a single consonant W. This could be an example of a simplification process called cluster reduction. I would not have known how to ask ChatGPT to see if there was a problem with syllable structure or cluster reduction, but I used this pattern of saying act as, and I said act as a speech language pathologist, and now I'm getting rich output that I wouldn't even know how to ask for. And then it goes on to say, because by the way, when I went, if you want to do something really unpopular, ask ChatGPT to produce an output that looks like it's doing somebody's job, and that's always a way to be very popular. So I did this with my wife one morning, and my wife was not very happy because she was trying to get ready to go to work, and here I am, saying ChatGPT's producing things that look like what you produce. And one of her things that she said to me was, if that was a 3-year-old, I'd be telling the parents they probably don't need to worry. Children's speech is continuing to evolve. And I'm paraphrasing what she said. She said it much more eloquently. But she was like, it's just giving you way overblown analysis of this. And I said, yeah, but ChatGPT says that too at the end. Considering the child's age, it is important to remember that some speech sound errors are developmentally appropriate and may resolve on their own with time. And of course, by that time, she was walking out the door because she really wasn't ready to sit around in the morning and listen to me tell her that ChatGPT is doing what a speech language pathologist does. Do I think it's going to take her job? No. But do I think it has really vast and powerful capabilities that we can tap into with the right patterns? Absolutely. And do I think it gives us the ability to focus on the things that maybe we really want to spend our time on? My wife loves working with kids. She loves interacting with them and trying to understand how to help them. Writing reports, maybe, I'm not sure. Don't want to speak too much for my wife, but I would guess it's maybe not her most favorite part of the job. She really loves working with the kids and trying to help the kids. And so you can imagine something like this where it allows her to focus more on the things that she really cares about in the real world. Maybe it can help her to give form to her thought around the child's needs and write these reports. And so I just hope that you'll see that with a little bit of the right structure in our prompts, we can create these really powerful ways of giving form to our ideas and our thoughts through large language models like ChatGPT. The basic thing that you're going to need to complete this course is a web browser and access to a large language model like ChatGPT. Now, you can use a variety of different language models to complete this course, but I'm going to recommend that you use ChatGPT because all of the examples have been tested on ChatGPT, and it's also really easy to get started with. All you'll need is a browser, an internet connection, and an account with OpenAI so you can get access to ChatGPT. Now, the way to do that is you're going to go to chat.openai.com, as you see in the address bar up here. And so you will go there and you'll be presented with a screen to sign up or log in. Now, if you already have an account on ChatGPT and you've been using it to write prompts, you can skip this video and go ahead and move ahead. But if you haven't done that yet, this video will kind of give you what you need to get started and understand how you're going to write prompts and interact with ChatGPT. So you'll go to chat.openai.com as seen up in the address bar here, and then you'll want to sign up and follow their sign up process. Once you're done signing up, what you should see after logging in is something that looks like this. Basically, at the bottom, we'll have a message box where it says send a message, where we can type in a message to ChatGPT. And at the top, you may have some options for different models to use. Now, I have access to the plugins, which is a newer thing. If you don't have access to that, don't worry about it. But you'll want to select model, and I would recommend for most cases using default GPT 3.5. Now, you can probably use any of the models, and sometimes in the videos you'll see me switching between them. And there's no particular reason from that. I probably just defaulted to what I had in the prior session. But I would recommend GPT 3.5. It's really fast. It typically has higher limits in terms of the number of requests you can send. It's easier to get access to typically. So I would recommend for most of the course, unless you have a reason not to use default GPT 3.5. So you'll just want to swap that up at the top. Down here in this bottom box where I'm typing hello, this is where we type the prompt to the large language model. So whatever we type in here, we can then hit enter, or we can hit this little send button on the right-hand side, this little airplane. So I'm going to just hit send, and I've now sent a prompt to ChatGPT. That prompt was hello, and then the response from ChatGPT is hello, how can I assist you today? So whenever you see the green icon, that is the output from ChatGPT, or the large language model's output. The blue icon is going to be and it may be a different colored icon, it may be your sort of profile or something, could have slightly different effects on color. I think it's always blue, but anyways, up here is where you're going to see your prompt. And then below it will be the response to your prompt. So then I can say act as a teacher of a class on prompt engineering. Welcome everyone to the class. So now I'm writing a more sophisticated prompt. So as you can see, now ChatGPT is responding. So this was my prompt up here, and I entered that in, and then down here is the response from ChatGPT. And so this message box down here is where you're going to be writing the prompts, and what we're going to be working on is how do we word the things that we're sending to ChatGPT? How do we come up with better wordings of the prompts in order to get better output down here in the green, or how to get more interesting output, or how to get output that has certain capabilities or behaviors built into it. And so that's what we're going to be doing. On the left-hand side of your screen, which you don't see in my screen recording, there's a list of chats that you've had with ChatGPT. So if you want to go back and pick up on one of those chats, you can click on them. There's also a new chat button. And this is important. For many of the examples, I would recommend going and creating a new chat each time we talk about a new pattern or a new concept and trying out what's being shown in a new chat. Everything here is affecting the conversation. So just like if you were having a conversation with somebody and you told them something, they might remember it later in the conversation and it could influence what they tell you. So in many of the cases, it's helpful to have a clean slate for trying things out. So hitting new chat. So I'm just going to do that, and this is what a new chat looks like. So now I can go and I have a completely clean slate and I can try things out. So this is what you're going to be working with throughout the class. You're going to be using ChatGPT. You're going to be entering prompts into that send message box at the bottom. And then you're going to be looking at the output and learning how to get better output out of ChatGPT. Now, once you know how to do this with the web interface with ChatGPT and you understand the concepts behind prompt engineering, you should be better with all of the large language models. You'll have a much better sense of how to work with all the different models. Now, some of them may not be as good as others, may not reason as well, may not respond to certain patterns or things as well. But we're starting off with sort of the most well-known example, which is ChatGPT. And more than likely, things are going to only build from here in terms of sophistication and capability of these models. If you know how to use and write prompts in ChatGPT using this interface, you'll be able to write prompts that could then be taken and built into programs or used with some other tool as well. So know this is a great interface for getting started and learning about prompts and how the large language models respond. So what are large language models exactly? And what do they do? How do they work? Now, I'm not going to go into the full details of this, but I want to give you just enough about how they work that will help you in thinking through designing prompts. So there's a couple things to know about them that will be useful when you're designing prompts. Now, the fundamental thing that you want to know about these large language models is basically what they're doing is they're taking your input and they're trying to generate the next word. And then they'll take that word that they generate and they'll add it to what you originally gave it, and they'll try to generate the next word. This is the way to think of it. Now, there's a lot more detail than this, but think of it basically is it's trying to generate word by word the response to your input. Whatever your prompt is, they're just going to try to generate word by word the next word that's going to be in the output until it gets to a point that it thinks it's generated enough, and then the last word is basically going to be the equivalent of stop. But it's not going to be something you're going to see. So what it's doing is basically producing words or tokens basically to respond to your prompt. And so what we're trying to do with large language models is we're trying to produce prompts that then cause it word by word to produce an output. Now, I want to show you a little bit about this and kind of give you some intuition of it. So if I go and I write, Mary had a little, and we stop right there. And if you're familiar with the nursery rhyme, Mary had a little lamb, its fleece was white as snow. I'm giving it a prompt, and if I say Mary had a little, it's going and then completing it. It starts from my last statement, Mary had a little, and it's predicting the next word, which is lamb. Its fleece was white as snow, and everywhere that Mary went, the lamb was sure to go. It followed her to school one day, which was against the rule. It made the children laugh and play to see a lamb at school. And so the teacher turned it out, but still it lingered near, and it goes on and on until it stops. Now you notice what it's doing is it's my prompt triggered it to produce the next word, which was Mary had a little, was my prompt, so the next word was lamb. If I go and I say roses are red, what does ChatGPT do? It says violets are blue, sugar is sweet, and so are you. And it says this is a classic poem that is often used to express affection or admiration for someone. But the key thing to note is it's doing a next word prediction. I said roses are red, and it's picking up where I stopped and predicting the next word, which is violets. It's then adding that in, and it's saying roses are red, violets, and it's predicting are. It's then going back, adding that in, and it says roses are red, violets are, and it's predicting blue. And it's doing this over and over. And so it does really sophisticated, sort of incredible things. But underneath the hood, when it was trained and created, basically what was done was a large portion of the text and other things on the internet were taken, and it was taught basically over and over again. It was given a series of words, and it tried to predict the next word, except that it was given, a paragraph of text from the internet, and they would show it part of the text, part of the sentence, and they would ask it to try to predict the next word in the sentence. And when it got it wrong, they would go and tweak the model, is what they call these things, large language models. And they're large because they were trained on so much data, and they have so many different parameters to them. They're these large language models. And what they're doing is they've learned patterns from our language, our human language that was out there on the internet. And they've basically learned the idea of, given what came before in the text, try to predict the next word. And then if I take that word and I add it back in, try to predict the next word. And so they trained these models to get really good at looking at the context of the information. Now, if you think about it, it has a lot of context. It's tapping into a pattern that it's seen. I said Mary had a little and it says lamb. It could have been Mary had a little bit of peanut butter on her shirt, but it's learned context, right? And that's part of what makes it work. It could be roses are red, daffodils are yellow, but it's learned this context, right? And so that's a part of the piece of this, is it pays attention to words and uses that knowledge of the context. It's paying attention to different words that have come before, that are in the current sentence. It's paying attention to their relationships, and it's using that knowledge, that contextual knowledge, to try to predict the next word. And then it's taking the word that it produced, putting it back into the output, and trying to produce the next word and the next word. And this is the basis of things. Now, this will be helpful to know when we start thinking about the patterns of our prompts, when we think about conversations, when we think about what we can do to tap into this fundamental concept of predicting the next word. Now, one of the things to know with these models is they are rapidly evolving. We're seeing a lot in the news about ChatGPT, but there's lots of competing models that are coming out, and probably by the time you're watching this video, there'll be even more that I'm not going to mention or talk about, because they didn't exist today when I started talking about it. So ChatGPT is certainly out there. There's a new version, GPT-4. There are models like Llama. There are variations on Llama like Alpaca. There's all kinds of different models that are coming out, and they're rapidly evolving. So more than likely, the discipline of prompt engineering and what you're learning, some parts of this are going to be hopefully timeless, but some parts of it will probably evolve and adapt as the different capabilities of these models evolve. Now, one of the things you'll want to do is always have that openness to experimentation, to creativity, and to trying things out. Remember, with these tools, we can rapidly prototype, we can rapidly explore things and try things out. And so we want to always tap into that. Now, one thing to note is that a lot of times these tools will produce output that is not the same every time. Now, it's possible that we could get the same output every time in certain cases, like roses are red, and now we get something different. And then if we went in and we did it again, we get something different. Now, notice that initially we got something that was what we kind of expected, but each time we're getting some variation on this. And this is something else that's useful to know, is these models aren't designed to do exactly the same thing every time. There's inherent randomness or variation in what they produce. And so this is something you need to know about when you're using the models. It's really powerful and useful if you use them the right way. If you aren't using the models the right way, or you're trying to fit them in for a task that they're not good for, you're going to have to do a lot of work to deal with this fundamental aspect of it. But it's also an aspect that makes you want to think about this as, you should never expect these outputs to be perfect necessarily on the first try. It's a tool that can help you get an output that you want, but it's not necessarily perfect on the first try. There may be errors, there may be variation, and you need to build that into the processes and the other things that you build around the tool. So if you're going to use it in your business, know that it may not give you exactly the same output every time. Now, there's ways to try to help limit what it does and try to guarantee that, but it's not guaranteed to do that. And so you want to know that. You want to know there's some randomness, there's some variation, which could be great when we're writing, prose with this, because we don't get exactly the same text every time, or else we would all have exactly the same outputs, and we wouldn't be able to explore and try things. So knowing that is an helpful, thing to realize. Now, it was trained on a vast amount of data that came from the internet, knowing that its knowledge is based on the time that the training data was collected. So in the case of ChatGPT, it's cut off around 2021. Newer ones have more up-to-date knowledge bases, but they're always going to be behind in what they were trained on. So they were taught to predict the next word, and they learned from that idea of predicting the next word. And they learned to predict the next word in the context of a lot of different domains, be it speech-language pathology or programming, or be it about creating recipes, whatever it is. But their knowledge that they were trained on and the patterns that they learned cut off at some date. And so when we want to introduce and reason or work with new knowledge, we're always going to have to provide that as part of our prompt, as part of our input into the conversation, is that whatever additional information they need in order to reason. They're not necessarily continually updating. They can't retrain these things necessarily all the time. Now, it may change at some point. The technologies may change. But right now, today, know that when you need new additional information that wasn't publicly available on the internet, you're probably going to need to provide it in the prompt. Now, those are some of the key things that you'll need to know as we go forward in this course in order to help you write more effective prompts. Large language models are unlikely, at least in the near term, to give you an exact and repeatable answer every single time. There's always going to be the possibility that they do something a little bit unexpected. And this is by design and can be a really good thing. Now, a lot of what we're going to be doing in prompt engineering is trying to deal with the fact that large language models have some unpredictability to them. And we want to sort of constrain that unpredictability. We want to mold it and shape it and work with it in a way that's helpful to us. Now, what I mean by this is that there's always some randomness, some ability to generate new and different ideas each time you put a prompt in. And this can be really good sometimes. Like if we're writing fiction and we want a lot of different ideas, a lot of different storylines, a lot of different characters, and each time we ask for new data or ask for a new output, we get something completely new and unique, then it's really good. On the other hand, if we're trying to have the large language model do some type of reasoning on a system, we may not want it to have a lot of variation in what it gives us out. For example, if we want a yes or a no answer, we don't want it to say yes sometimes, no sometimes, and then suddenly decide to say, well, maybe not, because here are these other things that I'd like to tell you about why it's hard to determine, and goes on this tirade for a paragraph or two about why it can't exactly give us the exact answer. Sometimes we just want a yes or a no without any explanation, and we can't always get that easily. So a lot of the prompt engineering techniques are going to be dealing with this. Now, I'm going to just show you a quick sample of the randomness, the fact that the same input is not necessarily going to give us exactly the same output every time. And I want you to remember this when we go through this course, because I'm going to show you a lot of different techniques to try to get the large language model to do certain things. And sometimes they're going to work really well and sometimes they won't work. But what these techniques will typically give you is they will give you something that's more reliable, that works most of the time or a lot of the time, but isn't guaranteed to work every single time. Now, this is an important point. We're always going to have some randomness here. We're always going to have some unknown, and we have to accept that and deal with that. So I asked ChatGPT, I said, how many birds are outside my house? And it says, as an AI language model, I don't have the capability to perceive the physical world. And it goes on, and then it says, if you're interested in finding out how many birds are outside of your house, you can go outside and observe the area yourself. You might also consider setting up a bird feeder. Okay, well, that was an interesting one. Let's see if we ask it again what it says. So now we're going to go and get a different answer out of it. It says, well, I can't see what's going outside your house. I don't have access to cameras. I only do text processing. And then it says, you could go outside and observe the area yourself, or you could set up a camera or other monitoring device to record, get the number of birds, availability of food, shelter, and presence. And so now we've gotten something different. And you know what we don't have anymore is this advice to set up a bird feeder. If we went and ran this again, we're probably also going to get yet another example. It's probably going to have some similar characteristics. It's still going and saying, hey, I don't have the ability to do that. It's running some of its things that, it's sort of standard text that it tells you. But then it's saying, hey, if you're interested in how you could try observing the area or to capture images of the area, you can then count the number of birds you see. Additionally, you could consider setting up bird feeders or bird baths. So we're getting a similar output each time, but it's not exactly the same output. And so this is a fairly constrained set of outputs for this question. We're still getting some similar type of things each time, but we're not getting exactly the same thing. And that's always going to be an issue for us. So know that when you're developing prompts, a lot of what you're dealing with is the fact that there is variation. Now, if I wanted it to give me an exact number and I was using a prompt like this is obviously not going to work. Like, we're not going to get an exact number of birds outside of my house with this prompt. Now, we might need to be able to go back and give it additional information that could help it decide.
Thanks you for watching my video. Please like and subscribe my channel. Thank you for spending your valuable time with us. Your views and support mean the world to us. We couldn't do it without you. Thank you for being a loyal viewer.
Prompts allow you to do more than just ask questions to ChatGPT or tell it to do things. You can actually write programs. Now, if you're not a programmer, don't worry, because everybody can actually program using ChatGPT. And I don't just mean in writing a bunch of software that you're going to run on your computer, but actually giving ChatGPT rules to follow, complex instructions that you want it to listen to and use to generate the output. Now, I'm going to give you some examples of this, hopefully give you some intuition on what I mean by programming and help you to think about how you can write better prompts. Now, one way to think about this is I'm going to talk about it in terms of programming, but you can also think about it in terms of rules that you would give, some type of personal assistant. So let's take a look at an example here. So I'm going to ask ChatGPT, whenever you generate output, turn it into a comma-separated value list. Now, this is just something that you might want to do. You want to format your data. So if you've ever worked in Excel, comma-separated values are basically a list of items separated by commas. It's a really simple concept. Now, sometimes you can think of tables as having a comma-separated value list. You can think of the first column in the table as the first value, then you have a comma that differentiates and separates the second column, and then another column is separated with a comma. So you can basically have like a 3-column table. You can have the first value and then a comma and then the second value and then a comma and then a third value. And if you've ever worked with different spreadsheet programs, you've probably done this. So now ChatGPT says, sure, I can do that. I can output my format. So I'm going to write in, my name is Jules White and I am teaching a course on prompt engineering. And so what we can see is it creates a comma-separated value list. We're essentially creating a table. There are 2 columns, name and course, and it decides that the first column is going to be name, is going to be me, and then the second column is going to be prompt engineering, which is my course. Now notice it decided, which is kind of interesting, it decided what the columns were going to be. I didn't tell it. But if I wanted to go back, I could maybe give it some more instructions. I could say, from now on, the columns of the comma-separated value. And comma-separated value is CSV, and in the future examples, I'm going to start abbreviating this CSV, but I'm writing it out for now. The columns of the comma-separated value list should be name, and I'm going to go ahead and capitalize these to provide some emphasis. Name, course, and role. So what is the role of the person in the course? And now I'm going to say, again, my name is Jules White, and I am teaching a course on prompt engineering. And so now we see it, it's reformatted. It's now got name, Jules White, course, prompt engineering, and role, teacher. And so we've actually written a program. If you think about it, what we've told ChatGPT to do is every time we actually write something, ChatGPT needs to format it in a particular structure that we've given it. We've wrote a program that tells it what to do. So it's more than just asking a question. We're actually telling it how to interpret our input. Now, we could go and write more for our program. For example, we could say, in addition to whatever I type in, generate additional examples that fit the format of the CSV that I have asked you to produce. And so now what we see is it's gone and it's taken my original format, name, course, and role, and it's now filled out additional examples. And I could say something like, my name is Jules White, and I am teaching a course on prompt engineering. And you notice now our program's gotten more complex. Not only is it creating the CSV based on what I typed in, but it's also following my instructions, and it's going through and generating additional examples that fit into this. So when you're creating prompts, you can do much more than just ask it a question and get an answer. You can actually program the interactions. Now the key to this is that we're having a conversation. And if you look back, at the very beginning, I provided it the initial sort of instructions, which whenever you generate output, turn it into a comma-separated value list. And it started doing that, and then I began refining my program. I then say, from now on, at this point, I'm adding something to it. I want the columns of the comma-separated value list to be name, course, and role. And then it does that. And then I say, now, in addition to that, I want you to generate examples. And it does that. And so we've actually written a program. And now whenever we go in and type in new input, so again, you notice I'm providing the same input, basically. My name is Jules White, and I'm teaching a course on prompt engineering. But the program that ChatGPT is using to produce the output is changing. I've changed the rules over and over. Now you can imagine talking to a personal assistant and you can say, okay, I want you to do X, and they do it, and then you realize, oh wait, they didn't, there's something else I want. And you give them an additional rule to follow, and then you tell them, okay, I want you to do X, and they go and do it, and they do better, but you realize, nah, it's not quite what I want. And so you go give them an additional rule to follow. And when you're doing that, you're basically building up a program for them. You're building up a set of instructions that they need to follow whenever you give them this particular task. And that's what we're doing with ChatGPT. We are programming. And so we're using the same input over and over. My name is Jules White, and I'm teaching a course on prompt engineering. We're using it here. But each time, the output that we're getting is getting different and more complex because we're asking ChatGPT to do different things. We're giving it more instructions for the program. And the final result is now we've got structured output. It's got additional examples. All of this has come from what we've asked ChatGPT to go and do. Patterns in our prompts can tap into powerful behavior within the large language model. It's trained on all of these different patterns, and it gets really good at using the patterns in our language in our prompt to decide what it's going to do. So one of the important things that we're going to learn about is the concept of a prompt pattern. A pattern for structuring the words and the statements in your prompt. So what is a prompt pattern? A prompt pattern is a way that we document a certain structure of phrases and statements in order to solve a particular problem with a large language model. So we'd like to interact with the large language model, and we'd like to solve a particular problem. And so a prompt pattern is basically a way of structuring our statements, a pattern for structuring our statements to use the large language model to solve that particular problem. So what would be an example of this? Well, let's imagine that we wanted to consistently generate the words, lamb, its fleece was as white as snow. Well, a pattern could be anytime you need lamb, its fleece was white as snow, you can write the statement, Mary had a little. You will very consistently get lamb, its fleece was as white as snow as the output. And so, for example, we can go and we can rerun this. Lamb, its fleece was as white as snow. We get more or less behavior, but if we want to consistently get those next words generated, we can do it over and over and over again through Mary had a little. It gives us some control over the output. It gives us a consistent, somewhat behavior. Now, it's not perfectly consistent. There's variations in the output. And we've seen in all of these examples, we've got variation in what happened, but we did get some consistency in the behavior. So what a prompt pattern is it's a way for us to document and talk about certain structures of our language, series of statements and wording that then will help us solve some particular problem. If the problem that we need to solve is we need to get lamb, its fleece as white as snow, as the next several words that are produced, then this is the pattern we use. Now, in many cases, we might have specific words we want. For example, we may want the large language model to tell us yes or no. We may want it to summarize something. We may want it to ask us questions. We may want it to always include certain things in its output. All of these things are problems that we might want to solve. We might want to know, how do we make sure it always includes these things in its output? How do we make sure that its output is always formatted a particular way? How do we try to make sure or get more consistent behavior on only getting a yes or a no? These are types of problems that we might want to solve by changing the pattern of our prompt, basically the structure of our prompt. Now, going back to our intuitive sort of understanding of prompts, you can see why thinking about it in terms of patterns is powerful, because patterns are basically that are in our prompt are tapping into things that the large language model has been trained on. It's been trained to predict the next word over and over, and it's learned certain patterns from the words. And if we can format our prompt in a way that taps into those patterns it's learned, we're more likely to get the behavior we want and solve that particular problem. So we document the pattern and the structure of our prompt in order to solve a particular problem that we need, or generate a particular behavior that we need for the large language model. So we're going to go through in a series of lectures throughout this course of specific prompt patterns that we can use within the context of large language models to solve important problems. The persona pattern is one of the most powerful patterns that we can use to tap into interesting behavior in a large language model. Now, what the persona pattern is you can imagine that you want to get a particular output, but you don't know exactly what the format of that output should be or what information should be contained in it. But if you were in the real world, you know who you would go to get that output, or what you would go to in order to get that output. So for example, if you had an accounting question, you would call up your accountant and ask your accountant for their advice. Or if you had a question related to speech-language pathology, like in the earlier example that I presented, you would go to a speech-language pathologist, you would have them do the assessment. If you had medical advice, you might go to your doctor. And so the persona, or the person, or the thing that you would go to, you know who or what that is in the real world. And we want to try to use that kind of same behavior of, I know who to go to, or I know what to go to get that output, but I don't know what their output would look like. I don't know exactly what they know or how they talk about things, but that's the type of output I want. And so the persona pattern is meant to give us that same type of behavior, to allow us to go to that expert and ask that question without having to know what exactly the expert's going to say, how they're going to format it, or what they might know or not know. So let me show you an example of the persona pattern. Typically with the persona patterns, what you're going to say is act as persona, provide outputs that persona would provide. And in this case, I'm going to word it as act as a skeptic that is well versed in computer science. Whatever I tell you, provide a skeptical and detailed response. And now if I wanted to be a little bit more precise in following the pattern, I would say provide a skeptical and detailed response that a computer scientist would provide. But in this case, I'm just going to say act as a skeptic. And that's really the most important part of this, is act as a skeptic, or act as whatever persona, and then provide the output that persona would provide. And in this case, I'm wording it as provide a skeptical and detailed response, which is similar in format. And then ChatGPT says, sure, I can certainly act as a skeptic well-versed in computer science. Please feel free to present your claims and I will provide a skeptical and detailed response. Well, I'm going to start off with, there is concern that AI is going to take over the world. And so we get a skeptical response. The concern that AI will take over the world is a common theme in science fiction, but is not a realistic concern in the near future. While AI systems are becoming more sophisticated and capable, they're still limited in their ability to think and act autonomously. AI systems are designed and programmed by humans, and they only do what they are told to do. They have no independent will or motivation. They cannot make decisions. Furthermore, AI systems are not fallible. They can make mistakes. While it is important to be vigilant about the potential risks and limitations of AI, the concern that AI will take over the world is unfounded and not supported by technology or research. So we're getting a skeptical response. If I went in and said, the sales person at the local computer store is telling me that I need 64 gigabytes of RAM to browse the web. And they say skeptically, it is highly unlikely that you need 64 gigabytes of RAM to browse the web. The amount of RAM you need depends on the complexity and size of the websites you visit, as well as the number of tabs you have open at once for most web browsing activities. And it goes on to tell us different things. And you can see that our saying act as has put in place basically a complex set of rules for the large language model. It knows it's supposed to be skeptical. It's supposed to have knowledge of computer science. It's supposed to provide certain outputs. Now, if I went back to it and I said, act as a 9-year-old, whatever I tell you, provide a skeptical response from a 9-year-old perspective. And I'll go ahead, 9-year-old skeptic. Now that's a more complex persona, or maybe not. AI is going to take over the world. I don't know about that. How could AI take over the world? Do you mean like in the movies? Aren't those just made up stories? And besides, computers and robots can't do everything humans can do. Now you notice it's still providing us a skeptical response, but now it's doing it sort of with the knowledge that it thinks a 9-year-old would possess. So it's tailoring the output. Now, if I had to tell it, this is how a 9-year-old is going to respond, here's the format for your output, that'd be hard to do. That would actually take up a lot of room in the prompt. But act as blank is a very, very powerful pattern and statement that is loaded with information. It's a very information-dense pattern and statement that can trigger all kinds of different behavior. Now, one of the interesting things is we don't have to limit ourselves to patterns or personas that are animate objects. So one of the famous ones is we can say act as a computer that has been hacked. Actually, we're going to say act as the Linux terminal for a computer that has been hacked. Now, don't worry if you don't understand what a Linux computer is or a terminal. The key thing to note is you're going to see behavior that looks really interesting and different. You're going to see it producing output that looks a lot like a computer. I am going to type in Linux terminal commands, and you will respond with the output that the Linux terminal would produce. Now we're going to say, now it tried to refuse it. It said, please note that it can be dangerous. It gave us all these different things. It tells us it doesn't want to do this. But now I've actually changed what it's doing, and I type in pwd, which is a Linux terminal command, which means print working directory. And what is it doing? It's printing a particular working directory. Now I'm going to type in a Linux command, which just tell me the files in that directory. And you notice it's producing output now that looks like the files within this directory. And we see a lot of interesting things that are going on here. We could move around. Now, if you do this example and go further into it, PSSEF is something I can use to see what processes are running on the machine or the computer. And when you do these examples, and I could play around with it, and I am not going to explore it in detail in this, but we see it that it's acting like a computer. It's giving us output that looks like a computer. Now imagine if I had to try to describe this complex output that it's producing right now. You notice how little information I gave it. Well, I gave it a lot of information, but it was in a short amount of space. This pattern, the persona pattern, is giving me really powerful behavior. So I'm using this little bit of prompt, and I'm getting now the ability to simulate this whole system. Now we can also do this in all kinds of different interesting ways. We can say act as the lamb in the nursery rhyme, Mary had a little lamb. And now we're getting some output that looks like that. Actually, what I'm going to do is I'm going to make this a little more specific. My prompt wasn't that great. Act as the lamb in the nursery rhyme, Mary had a little lamb. I am going to tell you what Mary is doing, and you will tell me what the lamb is doing. Okay, Mary is in the grocery store. So as the lamb in the nursery rhyme, while Mary is in the grocery store, I would be following her around as closely as possible, trying to stay by her side and maybe even nuzzling her hand for attention. Mary is in the movies. As the lamb in the nursery rhyme, while Mary is in the movies, I would not be able to accompany her inside the theater due to my inability to watch movies. So I would probably wait for her outside the theater, perhaps nibbling on some grass or wandering around the nearby area until Mary came back outside. And it goes on. And so you can see that you can create all kinds of interesting personas to produce output for. So we can say, pretend to be this job, pretend to be a speech language pathologist, or pretend to be an accountant, pretend to be a computer scientist. You can make your persona have something to do with the person's point of view or opinion. Act as a skeptic so that we can get skeptical output. We can say to act as an inanimate object that may have well-known sort of behavior, like act as a computer, the Linux terminal for a computer that's been hacked, and we saw that we got all kinds of output that looked like it came from a computer. Or we can say, act as this character in a nursery rhyme. Tell me what this character is going to do in a particular situation. And we're getting that output. So the persona pattern is a way that we can tap into sort of the patterns around language, around a specific persona or object or character in a story in order to get output that comes from that point of view, from that role, whatever it is. It's a really, really powerful capability. Now, one of the things is we often see that when large language models are programmed, they actually have a persona that's given to them to guide the whole interaction. So act as a really helpful assistant. And this actually makes a difference. If you tell it to be helpful, it will try to be more helpful. If you tell it to try to do something, positive, it's going to try to be more positive. Similarly, if you kind of give it a negative perspective, like my skeptical perspective, it's going to give you output that challenges you or maybe darker. And so, the persona that you ask the large language model to use is really, really important and powerful. The other thing, just to note again, is it's really information dense. It has a lot of pattern and knowledge around a persona that if you had to describe it from scratch, you would take up a lot of space in your prompt. You would be losing, valuable space in your prompt to provide new information. So if you were providing a lot of new information, you might want to say, act as, whatever it is, and evaluate this new information. Well, the more space you've taken up in your prompt describing how to do the evaluation and what point of view and other things to take, that's wasting space. But instead, if you go and take the persona prompt and you say, act as, this persona, provide outputs that persona would provide, you're giving it, a really, really information dense statement that it can use and allow you to have more space in your prompt for other things. So the persona pattern is a really, really powerful pattern to be aware of, and know that it's a very valuable one. You can do all kinds of things, like if you would normally get a committee of people together to discuss different points of view on a particular topic, well, you can assemble a virtual panel. You can have one prompt say, act as a security expert and analyze my cybersecurity. You can have another one say, act as the chief financial officer, analyze the financial soundness of that same decision. Another one can be, act as one of my employees, discuss how this might impact morale. You can provide sort of interesting abilities to get different perspectives and use those different perspectives to potentially inform decision making or to collect knowledge from different points of view that could be helpful to you in accomplishing a particular task. So what does the word prompt actually mean? Now, we talk a lot about prompt engineering, and we're talking about interaction with large language models. And so let's dive into this word a little bit, because I want to give you a sense of the depth of what a prompt can be. It's more than just a question that you're asking to the large language model. So to do this, I think it's helpful to go through a couple of prompts and actually interact with ChatGPT to understand the concept of a prompt and sort of the dimensions to a prompt. So I started off here by just asking ChatGPT, what does the word prompt mean? And it comes up with some really helpful, I think, information for us to use when we're talking about prompts. One, it says it's a verb. To cause or encourage someone to do something, to spur them to action. And it says, example, the teacher's reminder about the upcoming exam prompted the students to start studying. So part of what a prompt is, it is a call to action to the large language model. It is something that is getting the large language model to start generating output for us. Basically, to start generating words that will form the basis of our output. And those words could take all kinds of different formats. It could be software, defining the instructions in a program. It could be the words that we need for that. It could be words in a poem. It could be words in many, many different types of things. We could do it as structured data that we need. All of these things are possible, but the key is the prompt is basically our way of getting the large language model to begin to provide some output for us. The second thing it says is it's an adjective. It's done without delay, on time. And this is an important thing to think about with large language models, is we're prompting them right now, do this. But this is also a useful point of discussion, because a prompt doesn't necessarily, depending on how you work with it, have to be something that happens right now. Prompts can have time associated with them. And now we have a little bit of an illusion of time, and I'll talk about this later in the course, but when we give prompts to the large language model like ChatGPT, the prompt could affect what's happening right now in my next statement that I give it, or in the current statement, or it could affect something in the future. And this is because of some of the conversational capabilities of these large language models. Now, we're going to talk about prompts themselves as conversations later on. But for now, the way to think about it is a prompt doesn't just have to be something that's immediate. It can be, but it doesn't have to be. The next thing it says is a prompt can be a noun, a cue or reminder that helps someone remember what they were supposed to do or say. Now, this is important because we can use prompts to remind the large language model of information or of things that it needs to do. And so we may be asking it to do something now. We may be asking it something to do in the future, in which case it needs to remember something. So we need to give it a reminder of what it's trying to do. We may need to go back and give it a history of the conversation, of things that have happened, other things that will help it remember what it's trying to do. And then it can be another noun, a message or screen that appears on a computer or electronic device asking the user for input. So this is kind of a helpful thing because we can prompt the large language model to produce things for us, But the large language model, if we structure things correctly, can actually elicit information from the user. So the large language model can ask questions to us. So a prompt can both serve as a call to action or to spurring the large language model to action, or it can actually be an input. It can be asking us for input. So the last output from the large language model could have been a question for the human, and basically we're then providing information back to it. So prompts have a lot of different dimensions to them, and if you actually look at the definition of prompt, in fact the definition that ChatGPT gives us, it gives us sort of that nuance to the capabilities of a prompt. Now I've gone on a little bit here, and I'm going to give you an example of this time aspect to a prompt, because I think this helps to see the complexity and dimensionality of this concept. I'm going to say, from now on, when I ask a question, suggest a better version of my question and ask me if I would like to use it. So right here, I'm starting off by saying from now on. I'm attaching time to my prompt. So it's not just immediate. And we get a response, sure, I can do that. However, I will still try to ask you the original question to the best of my ability, and it goes on to try to reframe this original question, which wasn't what I necessarily needed. But then I say, what color is the sky? Now notice, we're done, right? We asked, the original prompt was back here. I said, from now on, when I ask a question, and it immediately gave us a response because of that prompt. But now I'm going to ask a follow-on question. But the earlier prompt is going to affect this question. So right now, I'm asking it something immediate, what color is the sky? And it responds with a possible better version of the question could be, what is the scientific explanation for the blue color of the sky during the daytime? Would you like me to use this version instead? And then I say yes. Now notice here we have a lot of those different dimensions of a prompt that we talked about. Up here, we are creating a prompt that isn't just immediate. It is going to affect us in the future. It's going to continue to influence the output of the large language model. So we can have immediate prompts that right now, right at this moment, do something, but we can also have prompts that span time. And in this case, that's what we're doing. We're creating something from now on, go and do this. Now we're going to have an immediate prompt, which is what color is the sky? We're asking this right now. And now our earlier prompt that we provided that was spanning time is now impacting the way that the large language model responds to our questions. So now what's happening is it's taking our current immediate question, what color is the sky, but it's using the context that we had previously said to suggest better versions of all of our questions and then ask us if we'd like to use them to generate its output. And its output is, here's a better question. What is the scientific explanation for the blue color of the sky during daytime? And you can see how that really is a better question than my first question. My first question was sort of vague, didn't provide enough context, and now it's giving us a more specific question that truly is better, and that's because of this prompt that we attached some time to it. We said from now on, and so it's influencing what's said now. The other thing that we can see is we talked about a prompt being something that can elicit information from the user. And so now we're seeing that the ChatGPT, in this case, the large language model, is asking us for information. It's prompting us. It's soliciting information, and it's saying, would you like me to use this version of the question instead? So now we've got that extra dimension of a prompt. It's soliciting information from us, and we say yes. And then it goes and answers the question. And it says, great, to answer your revised question, the blue color of the sky during the daytime is due to a phenomena called Rayleigh scattering. And I apologize, I don't know this term. And I'm actually learning something from ChatGPT as I read this. The Earth's atmosphere is composed of various gases and particles that scatter sunlight in all directions. Blue light has a shorter wavelength and higher frequency than other colors, which causes it to scatter more easily in the atmosphere. This results in the blue color that we see when we look up at the sky on a clear day. Now, we've seen a lot of different dimensions to prompts through this short interaction. We've seen creating time prompts that span longer. We then see an immediate prompt that's spurring the large language model to action. We see the concept of the large language model prompting and getting input from us. And then we see the output of all of this. Now, one of the things to note is we also talked about memory, that the prompt had a source of a concept of sort of memory to it. And we'll talk about how this works in the future, but right here I say from now on when I ask a question. That's something that the large language model has to remember in the future interactions. And we'll see how it actually does this. And so then when I say, what color is the sky? It's remembering that I said to, whenever I ask a question, ask a better version of a question. And then it's responding right here with the better version of the question. And then if I go and I do this again, we'll see that it still remembers my original statement that it needs to suggest better versions of my question. So I said, how many countries are there in the world? And it says a better version of your question would be, what is the current estimated number of countries in the world and how is a country defined? Would you like me to use this version instead? And then I say yes. And then it says, great, as of my knowledge cutoff in September 2021, there were 195 recognized sovereign states or countries in the world. However, this number may vary depending on how a country is defined. The United Nations, for example, has 193 member states, while other organizations and countries may recognize different numbers. Generally, a country is defined as a sovereign state with its own government, territory, and international recognition. Now, one other interesting thing that we talked about is that a prompt has some memory associated with it, and this also shows us some of the limitations that the large language model's knowledge cuts off in September 2021. So one of the other things that we may need to do for the large language model is we may need to remind it of what has happened since it was finished being trained, and we can use a prompt to provide information to the large language model like ChatGPT about what happened after it was trained. So we can also use it to provide information that the large language model didn't have access to when it was trained, like our own private information or other things. Now, of course, you have to be cognizant that when you're using ChatGPT or many of these other tools, you're actually sending information to their servers. So you do want to make sure that that is something that you're willing to do before doing this. But if you're using a large language model locally on your machine or you're willing to send the information, you can provide information that it doesn't have access to in order to reason about. So a prompt can also be about providing information to one of these language models. So if we look at this example and we say, what was Vanderbilt University's acceptance rate in 2020, it should have access to that. And so it provides this information. It says the acceptance rate was 9.6%. If we say what was Vanderbilt University's acceptance rate in 2022, it'll say, I'm sorry, but it doesn't have access to that information because it was cut off in 2021. If we then provide it that information, so here I'm cutting and pasting the admissions data that was released and published by Vanderbilt just a few days ago, so it clearly didn't have access to this. If I now provide this to it in a prompt, then it says, based on the information you provided, it appears that Vanderbilt University's acceptance rate for the regular decision applicants of the class of 2026 was 4.7%. So a prompt can also serve as a way of providing new and updated information to the large language model like we saw in this example. Let's talk intuitively about what a prompt is doing and how the patterns in the prompt sort of tap into the capabilities of a large language model. And sort of, I think looking at some examples will help to give you a sense of how your prompts are really affecting and eliciting different behaviors from the underlying large language model that you're interacting with. So let's take a look at this example. I want to start off by talking about pattern. Pattern's really important. Remember, as we talked about, large language models are trained to basically predict the next word. They're constantly trying to predict the next word based on what came before. So you give it a sentence and it's trying to predict the next word. And then it's taking that and adding it and trying to predict the next word, and over and over and over. And so it was trained on large pieces of the internet trying to predict the next sentence. So one of the things that it's learning to do is to recognize patterns that tell it what the next word should be. That's basically what it's doing. Now, this is a really simple example of this concept. I'm going to tell ChatGPT, complete this story, and I start with, Mary had a little, and I stop. Now, if you know the nursery rhyme, it's Mary had a little lamb, its fleece was white as snow. And you can imagine that this story showed up over and over and over and over in the data that ChatGPT was trained on. So when I say Mary had a little, that is a very powerful pattern that ChatGPT has seen many, many, many times. And so it immediately tries to pick up with lamb, its fleece is white as snow, and everywhere that Mary went, the lamb was sure to go. So that pattern was seen so many times that ChatGPT, when I put in the first part of it, it immediately responds with the next part of the sentence. It knows where to pick up. So one thing we have to think about is, if we know the right patterns, if we can tap into things that the model has been trained on and seen over and over and over again, we'll be more likely to not only get a consistent response, so we're going to consistently get a particular completion of Mary had a little because it's been seen so many times in the training data. We're going to get more consistency, but we're also going to more likely get a particular sort of ability to tap into it, to unlock it. Like if we want a particular behavior, we want to have the right pattern that we're tapping into. Now, let's look at what happens if we change the pattern a bit. And so I say, rather than, Mary had a little, I say, complete this story. A girl named Mary had a microscopic. Now, this isn't the pattern that it was trained on anymore, right? And it says, a girl named Mary had a microscopic friend named Max. Max was so small, you could only see him through a microscope. Despite his size, he had a big personality and was always eager to go on adventures with Mary. One day, Mary decided to take Max on a trip to the local pond. She carefully placed him on a lily pad. Now, one of the interesting things is you can imagine that when you start talking about microscopic, that you can think about, there's probably descriptions of going to a pond and doing, science with a class of students. I mean, I almost have a vision of it reading stories about, students getting samples of pond water and looking at them under a microscope. But the important thing is you notice that Mary had a little, created a very, very specific response. Whereas a girl named Mary had a microscopic creates a much different response. And then if we go and rerun this, we get something completely different. Pet named Max. Max was a tiny creature that lived in a small jar. And so, this pattern isn't as strong. There are words in this pattern that are strong and sort of give context that help to shape the story. But the pattern itself is not as strong as Mary had a little. So doing it again, whereas the other story changed completely, I'm still getting the same completion with this. I'm still getting lamb, its fleece was as white as snow. So every time I'm getting a very consistent, response to this pattern. So one of the things to think about when you're writing a pattern or writing a prompt is, what patterns do I have in my prompt, and what patterns will that probably tap into that the large language model was trained on. So if there's a very strong pattern in the prompt, you're more likely to get a response to that pattern. On the other hand, if that's not a pattern that it was trained on, it's not as clear, then you're going to have other things that are going to matter, like specific words. So a microscopic is going to fundamentally, that word is fundamentally going to change the behavior of this prompt because it's such a strong word. A girl named Mary is sort of generic. There were probably lots of stories with a girl named Mary. But microscopic, it has all of this feeling and implications to it, and that's going to then influence the large language model's output. Specific words alone, because of the patterns around those words, like microscopic is always going to be talked about in the context of small things probably. Or maybe in terms of things like in this case, like a small creature that lived in a glass jar. that word itself has a strong sort of pattern of other words that are coming around it, but it's not as strong as the pattern Mary had a little. Now, one thing to note is that when you're writing prompts, you want to be really specific, or you want to provide enough detail in your words that the large language model will know the right level of detail to put into the output. So if your words are very generic and high level, then you're more likely to get an output that is also generic and high level. So if you look at this example, I say discuss Vanderbilt University, and I get a very generic sort of response. It's a private research university located in Nashville, Tennessee, founded in 1873 by Cornelius Vanderbilt, ranking, other things. Now, if I want something really specific, I need to make sure that ChatGPT has the right words and context in order to answer my question. So ChatGPT is not a mind reader. You have to give it the context. You have to give it the words that are going to elicit the right response. If I go back and I say discuss Vanderbilt University with respect to Kirkland Hall, it's a specific building on campus, then it changes the output. I get a much more specific output. I get Vanderbilt University, private research university located in Nashville, Tennessee. Now we notice we're getting this fairly consistently, both of them. So that's probably pattern or information that the model was trained on and saw over and over again on different web pages for Vanderbilt and different documents. And then it cues in on the Kirkland Hall, and it starts discussing Kirkland Hall is one of the most iconic buildings on Vanderbilt University campus, named after James H. Kirkland. It then talks about Kirkland Hall, Kirkland Hall, Kirkland Hall. And so we've now completely changed the output. Now, even though we had shared a common beginning, we got a much more targeted output. And the key to this is that we added in specificity into our prompt about what we wanted, the details. So if you think about asking it to write something or to analyze something, it's always helpful when you say with respect to, and give it very specific words or names or things that you want it to then use to trigger the output. Because what we see is this Kirkland Hall is a very powerful word that then gets woven into the whole discussion. It's a powerful name of a building. If we just say generically, at a high level, we don't use specific words, we don't use a specific context, we're going to get very generic stuff. And this is probably stuff that if you go and look at descriptions on Wikipedia, descriptions on Vanderbilt's web pages, this is like the most common types of information that you see. So in order to break out of the mold of what is common, you need to inject the more specific ideas that you want in the output, or you need to inject patterns that will help tap into those more specific things. So this is an important aspect in that if you just use it and you ask it generic questions, you're going to get generic answers. If you ask it average questions and average things, you will get average answers. To really use it powerfully, you have to use your own creativity and thought to get specific about details, aspects of what you want discussed, and think about what are the right patterns to put into your prompt in order to trigger the behavior that you want, like we saw in this Mary Had a Little Lamb. Or we might want to do the opposite. We might know that we're going to get a very generic response because certain things have been seen a lot. And so we need to come up with tricks or patterns or specific words that will help break us out of those patterns that we're seeing in the training data so that we can get something that's more of what we want. So we don't want to be trapped into the completion of Mary Had a Little Lamb. So we go and add specific words like microscopic and a girl named Mary so that it's not so strong, so that we're not directly getting into that pattern. So just changing the wording can help us escape the patterns or get into the patterns depending on what we want. And then when we get output, the more generic our language, typically the more generic the output, the more specific our language, the more specific the output. And if we want certain things in that output, we need to make sure we have specific words and phrases that will tap into the specific things that we want in the output. Now, one of the other things is we're talking about output, but in the sense of a query. Like if I have specific words, it'll pull in the right information. One of the things we can also do is our prompt itself is a pattern that the large language model is learning from, and it can also tailor the output. So as we've seen in examples before, we can go in and do different things to try to affect the output. So for example, I might go in and actually, let's change this up a little bit. Let's say title, and we could say title of article, and then we could say author, and then we could say summary, and we could go in and give it something that it can look at and respond to. So now what I've done is I've gone and provided it some structure. Now it hasn't followed my structure exactly, and this is actually a failing in my prompt. I hasn't quite thought of the right structure, but I've gotten pretty close. So I went and influenced the output and the structure of the output by giving it additional pattern in my prompt itself. So one thing we can do is we can tap into patterns in order to influence the output. Another thing we can do is we can go in and use specific words and phrases to kind of be a query across or to basically collect learned information that's inside of the trained model. Another thing we can do is we can go in and we can provide information or basically new pattern that then influences the output. So in this case, I provided the structure of what I wanted, and it somewhat followed it, and I could probably go and rerun this thing and get something a little better, and in this case I do. So this will be another thing that we can do is we can use our prompt to create sort of new patterns that it's trying to follow in the output. So the prompt itself can introduce new patterns or tap into them in some respects. So this is kind of creating pattern that it then is responding to as well. So when you're writing prompts, it's really important to think through this concept that it's trying to predict the next word, and it's doing that based on patterns it's learned in the past and patterns that are in the language of our prompt and patterns that are based on the word choice that we have, patterns that are based on the sort of organization, the sort of textual organization. And so those patterns can help us get a consistent response. If we have a really strong pattern that always produces a particular next token or next word, then we can rely on that. If we don't want that behavior, we can try to change our phrasing or our words so we get out of that trap. If we want to make sure certain information is pulled in, we need to create specific words or patterns that are more likely to have been seen in the context of that information that we want. If we want more generic information, then we probably need to give it more generic language or tell it that we want it to be more generic in some respect. And then finally, if we want the output to look a certain way, we need to give it sort of a sense of pattern in the output. We need to tell it about the structure. We need to give it words and patterns in our prompt that will be likely to influence the output. So you can imagine seeing title and author on an article was something that was fairly common. So if I put title and author in this way into my prompt, then it's more likely going to want to go and create title and author again and sort of replicating the pattern of what I'm showing here. So that should give you some intuition about how all of this works and some things to think about when you're going and structuring your prompts, picking words for them, picking the patterns in your language, and picking the things that you want to go into the output, how you structure and kind of explain the output to it.
Thanks you for watching my video. Please like and subscribe my channel. Thank you for spending your valuable time with us. Your views and support mean the world to us. We couldn't do it without you. Thank you for being a loyal viewer.
A really simple way to improve our interactions with a large language model like ChatGPT is to use the question refinement pattern. So this is a really, really simple idea, and hopefully it'll inspire other ideas from you of patterns that you could use. But the basic idea behind this is that we want ChatGPT or another large language model, whenever we ask a question, to try to improve our question. So the fundamental sort of intent or idea behind this is that we may not have as much information or underlying thought behind our question as ChatGPT has from its training data. So it may be able to infer patterns and other questions or words or things that are useful when asking questions on this particular topic or when trying to request something be done on a particular topic. So if you think about it, these large language models are trained on patterns in language. So if we give it maybe a more general question and ask it to refine it, it can use its knowledge of what other things are asked about in the context of the question we've given it, or what other words are typically associated with that type of question that might help improve our question, make it more specific, or provide additional context for it, other things. So sort of intuitively, what we're trying to do is we're using a sort of a general question, and we're tapping into the large language model's understanding of patterns and language around that topic of that question in order to create an improved version of it. Now, the sort of pattern behind this is really, really quite simple. All we need to do is say, whenever I ask a question, or you can give it some scope to this just for the next question or for the next 3 questions or whatever you want to do, you say something like, whenever I ask a question, suggest a better question and ask me if I would like to use it instead. So this is just a really simple idea. We want to always try to have the best questions, best prompts to interact with the large language model. So we'll simply tell it, whatever I do, ask or suggest a refinement. Now I'm going to show you kind of a little tweak to this that's a really helpful tweak to know, which is we can say, whenever I ask a question, suggest a better question and ask me if I would like to use it instead. So this is kind of a nice little refinement that's sort of helpful from a user experience perspective, because what we're doing now is not only are we going to tell the large language model to create the question that's better, but rather than requiring us to go and cut and paste it or tell the large language model, use the question that you just generated, we just have it say, do you want to use this question instead? And if we say yes, it uses that question. If we say no, it should use our original question. So it's kind of a nice little tweak to this pattern that can make it even easier to use. Now, every time we ask a question, the large language model will go and try to improve it. So let's look at an example of this. So I'm going to start off with a generic question, which is, should I go to Vanderbilt University? Now, if we look at this question, we can see it's really kind of ambiguous and vague. And if somebody was asking you this question, should I go to Vanderbilt University? Or as a faculty member, if somebody was asking me, should I go to Vanderbilt University? Well, not only is this a big decision for the person, but there's really not enough information at this point for me to make a decision. So a better question is going to help give me more information about the criteria that you're using to decide, do these types of, what are the pros and cons, how do you weigh them and decide if it's the right fit? And that's exactly what we see ChatGPT doing. ChatGPT says, sure, here's a suggested question. What factors should I consider when deciding whether or not to attend Vanderbilt University, and how do they align with my personal goals and priorities? And then it says, would you like to use this question instead? This is a really nice pattern because once we've sort of turned it on, we can begin asking questions and automatically getting better versions of our question. And one of the things that's nice about this is it also helps us to reflect on what we're asking for. And if we see a question come back like this, like what factors should I consider when deciding whether or not to attend Vanderbilt University, and how do they align with my personal goals and priorities, either we'll see that and see that's a really useful question, and that's how I really would have phrased it if I'd thought about it better or more. But sometimes what we'll also see is that the path it's taking us down is not the one we want to go, and we'll realize there's lots of paths, lots of ways of answering the question, and we need to give some additional context. So not only is this useful in many cases of getting a better question, but sometimes it's helpful to us to see that a question could be interpreted in many different ways. There's many different pieces of information that may be needed to make an effective decision. And so by seeing one version of a refined question, we'll identify missing pieces of information. So for example, if I really care about computer science at Vanderbilt, I might think, oh, well, I should have mentioned that I'm planning on majoring in computer science. Or if the town that I'm going to be in when I go to college is really important, then I might want to say something about Nashville and living in Nashville. You want to make sure that you think through the question really effectively, and this is a pattern that can help us really hone in on producing better questions, learning from the refinements to the questions, and also using the questions, the refinements to understand what's missing in the context that we might want to introduce in order to get a better output. An interesting property of large language models is that in many cases they can actually reason better if they break a problem down into a bunch of smaller problems. So sometimes they can even reason better if they explain their thought process. Now there's a number of sort of hypotheses about why this might be, but I think intuitively, if we can think about, a large language model may have seen particular problems broken down into a series of steps. So if it can go and follow the individual steps, it will know what to generate next in order to produce the output that's needed to solve a particular step. Now that's going to be discussed later in the course, these ideas of breaking things down. But right now we can actually tap into a simple technique, a simple pattern to help us with automatically breaking things down to try to get better answers out of large language models. And a simple way to do that is just to ask the large language model to always take questions or problems and subdivide them into a series of individual questions or sub-problems that could be useful in answering the overall question or in solving the overall problem. So we can simply program our large language model to do this. Now, the cognitive verifier pattern is exactly for this purpose. What we're going to do is we're going to tell the large language model, whenever you're asked a question, follow these rules. Generate a number of additional questions that would help more accurately answer the question. Combine the answers to the individual questions to produce the final answer to the overall question. Now, again, sort of intuitively, we can think about this. If we have a generic question or some particular question that we ask the large language model, it can go and tap into what it's seen, the patterns it's seen in the training data to see what are other questions that are often related to this question. So one, it can help it sort of think about, collect from its knowledge base other questions that would typically be associated with that question. And when it's finding these other questions, there are likely to be other questions that are relevant to that question and will provide additional details or context to answer the question. And then when we go and give answers to all of those individual sort of sub-questions, it's then going to have additional context to give us a better overall answer. And it also helps us as the users to structure our thinking. Because when we go and ask and it begins breaking questions down, it'll help us sort of realize what are additional dimensions to the problems. So let's take a look at this in practice. So here I'm saying when you're asked a question, follow these rules, generate a number of additional questions that would help more accurately answer the question. Combine the answers to the individual questions to produce the final answer to the overall question. And ChatGPT in this case says, sure, I can do that. Just let me know what the question is and I will generate additional answers. So let's see what we can start with. Well, I thought of a question that I have no way of easily answering, and I don't know a whole lot about it. So I figure by asking a question that's I'm guaranteed probably to ask a question that's too generic and doesn't have enough information, this will be helpful to me. And so I asked ChatGPT, how many mosquitoes probably live in my front yard? I don't know the answer to that question. I didn't think too hard about it, but I'm kind of interested. What is the answer to this? How would I even figure this out? And so I asked ChatGPT that question. And so here's what it says. Well, it follows our prompt pattern. It follows the cognitive verifier pattern, and it generates a bunch of additional questions. Let's look at those questions. What is the size of your front yard? Well, obviously that's really important. If I have a bigger yard, I'm likely to have more mosquitoes probably. It's probably related to the square footage in my yard. What is the climate like in your area? That's obviously really important. If I live in the desert or if I live at the North Pole, it's unlikely that there are going to be any mosquitoes. What time of year is it? Another great question. I didn't think about that dimension to it when I asked the question. but I'm probably asking the question when I'm, in the spring or summer when there's a lot of mosquitoes floating around in my yard and it's driving me nuts, but I'm not thinking about, I need to include time in my question as well. Are there any bodies of water or standing water sources in your front yard or nearby? And obviously that's an important one because mosquitoes breed in water. And I actually knew that, but I didn't include that information in my original question. And then, are there any plants or vegetation in your front yard that mosquitoes are attracted to? That's another important one. So we see now it's taken my original question and it's broken it down into a bunch of sub-questions that are going to help it answer the original question. This is really useful, and I've also learned something. Now, to answer this, I'm just going to go back to it. If you'll remember, it had a series of questions, 1 through 5. I'm just going to go now and answer with one about 2,500 square feet. I honestly don't know, but I'm just sort of guessing. My yard's not that big in the front yard. This is probably actually an overestimate of the size of my front yard. I live in the southeastern United States. It's April. I'm not telling it, seasons or things. I'm just going to give it the month, which probably isn't specific enough. There's probably a difference between the date and different times within April, even within where I live. Then I tell it, no, there's no standing bodies of water in my front yard. And yes, there are plants that likely mosquitoes would breed in. And so then it goes and says, based on the information provided, here's an estimate of how many mosquitoes living in your front yard. And it gives me a number of things. It says with a front yard size of 2,500 square feet, according to some estimates, a single female mosquito can lay up to 300 eggs at a time. But it says in other things, and it kind of goes on to hedge its bets, which is a good thing, right? It says, in general, a typical mosquito population density in an area with standing water sources can range from 10 to 100 mosquitoes per square meter. However, since there are no standing water sources in your yard or nearby, the density could be lower. And then it goes on to say it's difficult to provide a precise estimate. However, it's possible that there could be anywhere from a few dozen to a few hundred mosquitoes in your yard, depending on various factors such as species, climate, and the presence of vegetation. That's pretty good. The fact that it's gotten this down to a few dozen to a few hundred, that's a tighter range than I would have expected. And also just sort of sets my expectation. In the middle of summer, when I go out in my front yard, I would swear it was in the thousands. I'm absolutely dying as I'm eaten alive by mosquitoes, and so I typically think it's a much higher number. But based on this, it may be wrong, it may be erroneous, but it actually gave me some fairly good reasoning. One of the things that's also nice about this is I'm less skeptical of its answer being completely wrong because it asked me a bunch of reasonable questions to derive its answer. It also gave me a bunch of facts, which I could go and follow up on, like how many eggs a female mosquito will lay, the density of mosquitoes in areas with water. But it gave me kind of a pretty good answer, and it gave me a bunch of questions that I could ask to improve that answer. Now I'm going to go back. I'm going to actually qualify that. It said it gave me a pretty good answer, but the truth is I have no idea. I'm not an expert on this topic, and as with anything that we get out of one of the large language models, I would highly encourage you to verify the output. But I think this is interesting because at least at the very minimum, it helped me learn about, through this question, what might influence the number of mosquitoes in my yard and give me things that I could go and follow up on and verify, see if they're correct, if these facts hold water, see if these questions really are useful. But they certainly look like valid and important questions. What is the size of your front yard? I'm not sure that I even need to go research that. A larger yard is likely to have more mosquitoes. What is the climate like in your yard? I know that matters. What time of year is it? I know that also matters from personal experience. Are there any bodies of standing water sources in your front yard or nearby? I know that matters. That's sort of general knowledge in the southeastern United States. And are there any plants or vegetation in your front yard that mosquitoes are attracted to? And I actually happen to know that is also an important factor. So it's actually given me a bunch of really good questions. It's given me some facts related to those questions, which I would have to go verify and I don't know as much about. But it is a really helpful tool for automatically taking a question, breaking it down. I can see sort of its reasoning about how it's going about and thinking about this. It improves my reasoning about thinking about how I might answer this question. And in many cases, what we'll see is having the large language model break down the question will help it give a better answer to us so that we'll get something that's more accurate. We discussed the persona pattern and how we can use it to give the large language model all of this rich information about what it's supposed to do and what it's supposed to output with a very little bit of work on our part. All we have to say is act as, and it will know what it's supposed to do and how it's supposed to format it and the types of things that it's supposed to incorporate into its output. Now, sometimes what we'd also like to do is we'd like to do the same thing, but rather than focusing on who the large language model is supposed to act like, we want to have the large language model produce an output for a particular persona. So this is called the audience persona pattern. The idea behind this is we want to tell the large language model, you need to produce an output for this audience persona, for this person or thing, so that it can think about how to tailor the output. And it will use its knowledge of the audience to make sure that it generates an output that is appropriate for that audience. So rather than saying you don't do this or having a whole bunch of different rules describing what is and is not okay to go into the output, instead we say this is the audience of your output. This is the audience persona. And so with the audience persona pattern, we can get a similar type of reasoning and ability out of that we got from the act as this persona, using the persona pattern. We can get that by saying, here's who you're providing the output to. This is the persona of the audience in order to get interesting outputs. So let me show you an example of this. So we're going to start with the example of large language models, which we've been studying in this course. And we're going to say, explain large language models and how they work to me. Assume that I have no background in computer science. So we're giving it a persona of who I am. We're saying, assume that I have no background in computer science, and that's telling it who is the persona, who is the audience that I'm giving this information to. And so it says, sure, let's start with the basics. And I want to call out just a couple of things. It starts with a very sort of intuitive way of describing this. A large language model is a type of computer program that's designed to understand and generate human language. It's a bit like a virtual writer that can understand and create sentences in a way that sounds natural to humans. And so it's not describing it like it would to a computer scientist. It's describing it to be, something that is accessible and approachable to anyone. Language models are used in many applications such as speech recognition, machine translation, and chatbots. Now let's talk about large language models. The word large refers to the size of the language model, and it goes on to describe it, and it says parameters are like adjustable knobs that the model uses to learn patterns in the language. So it's describing what a parameter is in a sort of accessible way. And it goes on and it talks about all the different steps in creating this. So it did a good job, right? I said, assume that I'm not, I don't have background in computer science, and explain it to me. And so it made sure in its explanation that it had the right information and then presented it at the right level for me. So let's go a step further. Let's show you how interesting this can get. I'm going to say, explain large language models and how they work to me. Assume that I am Christopher Columbus. So notice, now I'm giving it something completely different. I don't know how you would explain large language models to Christopher Columbus. So it's going to have to use and draw on the information in its training data and patterns related to Christopher Columbus and history to try to figure this out, right? I'm giving it an audience persona that's a tricky one that I wouldn't know how to do easily. And it says, greetings, Christopher Columbus. As an explorer of 15th and 16th centuries, you may not be familiar with the concepts of computer science and artificial intelligence, and I don't know how well this really works, but it's still pretty good that it's doing it. I'll do my best to explain it. Imagine that you have a magical scribe, a being that can read, write, and understand many languages. This scribe has spent years reading countless books, scrolls, and manuscripts from all over the world. It has learned from poets, scholars, and storytellers. The magical scribe has a special ability. It can predict what comes next in a sentence. For example, if you say to the scribe, the ocean is vast, it might respond with mysterious. completing your sentence in a way that makes sense. And so you can see how all we did is we said, you're going to explain the exact same thing, but you're going to assume in the first case that I don't have knowledge of computer science. And then we said, now you're going to assume that I'm Christopher Columbus, right? And so it completely changes how it describes large language models, and it's actually doing a pretty good job. So it's saying here, like Christopher Columbus doesn't know what a computer is, Christopher Columbus, but maybe this concept of a magical scribe, right? And magical scribe could be a concept that could make sense to Christopher Columbus, and then he's explaining how large language models predict the next word. He's saying the magical scribe studied all of these, these scrolls and poems and different things and learned to figure out what is the next word in a sentence. And now we're going to use that magical scribe, and we're going to talk to the magical scribe. So he's explaining, the scribe like Christopher Columbus, as he's going to understand it. As Christopher Columbus will be able to look at the text and kind of understand that, like, okay, I have this large language model, and now I've got this magical scribe. It kind of makes sense on what that means and like how that would possibly work. So now let's look at a third example. We say, explain large language models and how they work to me. Assume that I'm a second grader that gets bored easily. And so again, we're given a totally new persona, and we're also refining this persona. We're saying I'm a second grader, and here's some additional details about me. I get bored easily. And so now it goes and says, okay, I'm going to tell you something super cool called a large language model. Imagine having a robot friend who's really good at playing word games. This robot can finish your sentences, answer questions, and even tell you stories. Here's how it works. Reading time. The robot friend loves to read. It reads lots and lots of books, websites, and all kinds of things with words. And so it's explaining this concept of, similar to as it explained to Christopher Columbus, it told Christopher Columbus, the large language model is like a scribe that's read all of these scrolls and poems and things like that. And now the large language model is explaining to the second grader, it's like a robot. And the robot loves to read. It reads books, websites, and words. And so now it's switched up the description based on the persona of the audience. And then it goes on to describe all of the different aspects again. And you could go through and ask it, to describe it in many different ways. So if we wanted to go back and we wanted to say, well, let's switch it up from a second grader, and let's say, assume that I only accept explanations in math. And then we could say something completely different. So now it's saying, okay, language model is a probability distribution, and it's trying to give a mathematical explanation of what a large language model is. And we can see that we're getting something completely different. And each time, we don't have to necessarily think through, well, how would I explain this to Christopher Columbus? What would the rules be to describe how that output should look? We don't have to tell it what the output should look like. We tell it who the audience is, the persona of the audience, and then we get all of that rich capability around it. So just like the persona pattern is really useful in tapping into large language model capabilities, the audience persona pattern is sort of the complement to it and is also sort of an equally powerful thing that we can use to basically get really interesting and powerful output out of large language models. Sometimes we need the large language model to ask us questions, to really guide the process of solving some problem that we have or helping us obtain an answer or an output that we need. And we may not know what are all the steps to achieve that goal. And so what we'd really like to do is we'd have to have the large language model ask us questions. So whenever we want the large language model to ask us questions, the pattern that we can use is called flipped interaction. And so the idea behind this is rather than, we're going to flip the interaction rather than us providing questions and the large language model providing answers, we're going to flip that, and we're going to have the large language model ask us questions, and we're going to provide the answers. And we can do this in a number of different ways. We can do this to play games. We can do this in order to try to reach some goal. Like the large language model keeps asking us questions until it gets enough information to achieve some goal. There's a variety of different ways that you can use this, but this is incredibly helpful when you don't necessarily know everything that's needed, or if you want to be tested or quizzed on something, anywhere where you don't want to be in the driver's seat. You want to really be helping provide information, but you don't want to be formulating the questions or tasks. So let's take a look at an example of the flipped interaction pattern. So the key to this is we start off by asking the large language model to ask me questions, and then we give it some topic that we're going to have it ask questions on. So ask me questions about fitness goals until you have enough information to suggest a strength training regimen for me. When you have enough information, show me the strength training regimen. Ask me the first question. Now this is the basic pattern, is you say ask me questions on a particular topic, and then it's more helpful usually if you give some goal. Why are you asking the questions? Are you trying to have it quiz you? Or are you trying to get a fitness regime like we're in this one and have a fitness plan? Like what is it you're trying to achieve? And the more information, the more context you can give about what you're trying to achieve, the better questions it'll be able to ask you. Now, other things you can do are you can tell it how many questions to ask you, how many questions to ask at a time, a variety of different things. But one really handy thing you can do is end the flipped interaction prompt with ask me the first question. So one thing that you often want to do is do it one question at a time. Now sometimes you'd like to have like 10 questions listed, and you can answer them, 1, here's my answer, 2, here's my answer, 3, here's my answer. And you can certainly do it that way if you want to get it all at once and think about it all at once. But a lot of times I like to do it one question at a time. And so if you want to get that one question at a time behavior, usually a really reliable way of doing that is to say, ask me the first question at the end of the prompt. So we're going to generate this fitness plan. So we say, ask me the first question, and it says, great, let's get started. My first question is, what are your specific fitness goals? Are you looking to build muscle mass, increase strength, endurance, performance, or achieve a particular goal? And I go on to say, I'm looking to build explosive power and also prevent patellar tendinopathy from doing jumps on a mountain bike. Now, I don't know if this is a correct pronunciation of patellar tendinopathy, but this is what I've sort of looked up as I've started to experience some pain in my knees at certain times when I've been doing a lot of jumps on a mountain bike. And so I looked it up, and this seems to be the reason for it. And so I'm providing that information because I don't necessarily know. Well, actually I do know, because that's part of the reason I picked this one, is I could fact check it a little bit against what I've read on the internet. But I wanted to generate a fitness regime for me. And this is something that I've actually been doing, is figuring out what exercises I should do to help out, my knee and strengthen so it doesn't happen again. And then it asks, do you have any current or past medical conditions or injuries that may affect your ability to participate? Additionally, have you been diagnosed with this, or are you looking to prevent it proactively? And I give it some information. And then it goes on and it asks me how many days per week I can dedicate. And additionally, do you have any access to a gym or fitness equipment? I'm specifying I can work out 5 days per week for 30 to 45 minutes at a time. And then we finally get to the point where it actually generates a full sort of fitness regime for me of what I'm going to do to work on this. Now, what's really interesting is it's gone through and it's taken into account the answers from my earlier questions. And I know that because I've been looking for what are good exercises to help work on this issue with my knee that I've been having. And these are exactly the types of things that you see recommended, like the goblet squat. The split squat is one that you see a lot of times. A lot of different types of squats and things are very helpful, and these are the types of things that I see. But it's also taken the overall context that I'm looking for, weight training. It's gone and generated the entire weight training regime. Now notice at the very beginning, I said, when you have enough information. So I said, show me the strength training regime. And so this kind of shows another important sort of power of this prompt pattern, this flipped interaction pattern, is we give it what we're trying to achieve, and how much it should ask you. And basically we set the goal as ask me enough until you have enough information to show me the training. And so it asks questions until it thinks it has enough information and then generates the output. Now, sometimes what you'll see when you ask questions to a large language model is it'll tell you, well, in order to do this well, I'd need to get a bunch of additional information. Or it might generate a generic initial plan and then say, but if you provide additional details to me, I might also be able to do blah, blah, blah. And so what we see here is this is kind of getting rid of all that. Let's skip that step of getting something generic or being told that there's not quite enough information, you need to answer questions for us, and let's just say, go ahead and ask us the questions that you need until you get there. Now, this can also be used for doing other things like quizzing, playing games, anywhere where we want to have knowledge in the large language model drive the creation of the questions. And this is really helpful when it has theoretically or been trained on knowledge or patterns in language that will be useful in creating the questions and are things that we don't possess ourselves. So whenever that's the case, it can probably go and more effectively think up questions. So if we say, okay, I need a fitness regime and I have patellar tendinopathy, I may not know, what are the types of questions that you should ask somebody who has this. I may not know what are the types of exercises that are commonly discussed if you have this condition, but it has been trained and seen patterns of language where when people were discussing this particular condition, these are the exercises that were discussed. These were the additional questions that were asked in order to select exercises. And it has access to those patterns from its training data that then help it to select good questions to design that appropriate training plan. So whenever you need the large language model to ask you the questions, or you can think about a customer service example where you're trying to diagnose some problem that a customer has, or automate some response, and you need to collect information and then take action, the flipped interaction pattern is a really powerful prompt pattern to use to do that. A really interesting thing that we can do in a prompt is we can actually teach the large language model to follow a pattern using something called few-shot examples or few-shot prompting. So the idea behind this is we're going to give the large language model examples of input that we would give it and then the output that we would expect. And so you can imagine a human will go through a couple of examples. So they'll give it some input, they'll show it what the correct output should look like. They'll then give it another input, give it the correct output. And the idea behind this is that we're developing a pattern that the large language model can then learn to follow. So actually within our prompt, we're teaching the large language model a new trick. We're basically showing it what we want it to do and how we want it to format the output within a series of examples. So rather than describing the process we want it to follow, we're giving it examples of what we want it to do and then hoping that it will continue the pattern that we provide. So let's take a look at this. So if you'll see right here, we've got a simple example of few-shot prompting. So the idea behind this is we start off with input, and you'll notice that this is a common thing that you will see in few-shot prompting is that you'll see a prefix applied to the lines. Now you can have all kinds of prefixes, and your prompts and your patterns don't have to just be input and an output. It could be a couple of different steps, and we'll look at that in a minute. But as we see here, we have an input, which is the movie was a bit long. And what we're going to do is we're going to do what's called sentiment analysis. This just basically is try to analyze some comment about a thing and try to figure out what the user's sentiment was about it. Like, were they positive about it? Did they think it was a good thing? Or were they negative about it? Did they think it was a bad thing? Or were they neutral? And we're just going to do a really simple example with sentiment analysis where we're going to take some fake reviews of different things, and then we're going to decide if they were positive, negative, or neutral. So what we're doing, rather than saying, go and analyze these user comments and tell me if they are positive, neutral, or negative, Instead, what we're going to do is give a series of examples. So we give the first example, which was the movie was was good, but a bit long, and we say the sentiment was neutral. So it has some pluses and minuses. It was good, but it was too long. Then we have an example where we say, input, I didn't really like this book. It lacked important details and didn't end up making sense. And then we say the sentiment was negative. And then we have another input where we say, I love this book. It was really helpful in learning how to improve my gut health. And the sentiment is positive. And then what we do is we're going to give it the thing that we actually want to perform the task on, that we're going to hopefully get it to follow the pattern on. And we'll say input, I wasn't sure what to think of this new restaurant. The service was slow, but the dishes were pretty good. And then we cue it in to follow the pattern by saying sentiment, basically, tell us what you think about this thing. Now, my prefixes are a little bit leading. They are giving it information about what to do, but it could also learn from these patterns. If we just said input and output, it can also do that. I'm giving it a little bit of richer information. Now, my goal then is to get the large language model to go and analyze the input I give it and decide what should be attached to sentiment. And it picks up on our pattern and it says neutral. So it sees that in this review, it says service was slow, but dishes were pretty good. And so it's seeing that sort of positive and negative, and it's following my pattern that I gave it. I didn't tell it this is what neutral meant, but in the examples that I had before, a kind of a balance of positive and negative ended up being neutral. Now, a couple things to note. One, we didn't tell it what to do. Two, we didn't tell it exactly what the output should look like. And what we see is that it's constrained itself to the output and then basically the labels that we gave it earlier. We had negative, positive, and neutral, and it's automatically constrained itself and provided an output based on that. Now, it won't always constrain itself, but this is a nice thing. In many cases, this can help us get a more constrained or bounded output out of it. Now, if we went and we gave it a new one, we can say input, I really hated this coffee. It was roasted too much and tasted burned. Now, notice I'm not going to give it the prefix for sentiment. So let's see what happens when I do that. And then you notice it provides the prefix and the output that I expected. Now, the really important thing to think about with this is if you go back to when we talked about large language models and what they're doing, they learn to predict next word. They're learning patterns. And so when it sees input in a statement, it's predicting that the next word should be sentiment because that's what it saw in the examples that we provided it. Before, when we ended with sentiment, then what it did is it knew that it needed to pick up right after sentiment. So if we go back to this and we edit it, and we just add a line here and we say sentiment, then it should pick up the pattern right after sentiment. And so this is kind of helpful to know about when you're thinking about few-shot examples. Now this is a simple example of following a pattern, but you can see how this is a powerful way of teaching, particularly if you have data that describes the task that you want to do. And then when I say describes, it shows the input and it shows the output. And it doesn't necessarily describe how the task was performed, but we can see what's being done. And that type of thing can be a good fit for a few-shot prompt. Large language models can actually do some planning, which is an interesting ability. So they can actually go through and take patterns and with few-shot examples, and they can learn what the next action should be given a particular situation. But I'm giving you this example not because they're limited to, coming up with planning in the sense of actions or, doing sentiment analysis, but I want you to expand your sort of mind on what's possible with few-shot prompting and see it as a technique that can be taken and adapted to all kinds of situations. So we've seen how we can use few-shot prompting for doing sentiment analysis. Now we're going to do something very different with it. So we're going to take a look at this example where we're describing different situations with driving a car. So in the first one we say, situation, I'm traveling 60 miles per hour and I see the brake lights on the car in front of me come on. And the action is we're going to brake. So again, we've got a first example in our few-shot examples. Situation, I've just entered the highway from an on-ramp and I'm traveling 30 miles per hour. Action, accelerate. So we're teaching the large language model that it's going to be given a situation and it needs to decide what the car should do. Situation, a deer has darted out in front of my car while I'm traveling 15 miles per hour and the road has a large shoulder. Action, brake and swerve into the shoulder. Situation, I'm backing out of a parking spot and I see the reverse lights illuminate on the car behind me. And then we prompt it with action. We leave off at the end of our prompt with something that indicates to the large language model we want it to decide what the action is. And what do we see it do? It actually says stop and wait for the car to back out before proceeding. And it's making a sensible, decision about what the action should be. Now, I don't think we should go and build self-driving cars with few-shot prompting. I don't think we're going to get there with that. But I do want to show you that we don't have to think just within a narrow, rigid box of classify something. We can actually kind of have complex tasks that we're having it perform. Now, sentiment analysis is a complex task, but this is also a very complex task that's sort of in a different vein. So I want us to think very creatively about how we can use few-shot prompts. Now, again, one of the things that we're getting is we're getting some constraints on our output. It's learning what the output should look like. Now, I'm going to then go and do something else interesting. I'm going to show you kind of an interesting capability of large language models. And one of the things that can be done to use one large language model to teach another one, which is kind of an interesting capability. So I'm going to say, please provide more examples, and then I'm going to kind of prompt it with situation. And it's going to start generating additional situations and actions. So it's learned from our pattern, the types of things that we're describing and the types of actions, and now it's going to go and generate more examples. So it says you're driving in heavy rain and notice that the road ahead is flooded. So this is the continuation of our situation. And then it says action, slow down and cautiously drive through the flooded area, watching out for other vehicles and avoiding sudden movements or changes in directions. I would actually disagree with this. I'm not sure that it's smart to drive through a flooded area. That's probably questionable decision making, which again just reminds you that you need to own the output of the large language model and check it. Situation, you are driving on a 2-lane road and a car is approaching you from the opposite direction with their high beams on. Action, dim your headlights to low beams to avoid blinding the oncoming driver. But you notice the interesting thing about this is it's giving us some rich situations and possibly appropriate actions. I'm not sure I agree with the flooded one, but we're generating different examples of situations and what to do, and they look very similar to what we produced before. And one thing that's interesting is we can actually take examples like this and then curate them and have a human edit them and then provide them back to a large language model either later as additional examples for our few-shot examples. And so once we've had a human look at them and curate them a little bit, maybe clean them up, maybe we don't want that one on flooding because we don't think that's a good idea, so we actually say, well, you shouldn't drive across flooding, or we sort of spell out the rules. But you can imagine that the level of effort to create the initial examples right here is much higher than the effort to go through and generate subsequent examples, which we can then go and hand edit and curate. So we can quickly build up these examples, both in order to generate an output right now that we want, but also to generate examples that we can later give back to the same large language model, or that we could go and give to another large language model to teach it. And in fact, some people have actually gone and done this. They've taken output from ChatGPT, for example, and they've taken it into another large language model like Facebook's Llama and used the output from ChatGPT to improve the outputs of Llama. And so this is another interesting capability, is that large language models, through these few-shot examples, they can generate few-shot examples for other models. The other thing I just want to go back to is this is a very different sort of task and style than we had before. We have a situation and then we have an action that's being predicted. And so we can have all kinds of interesting things. Anywhere where we can have a pattern that we can describe, a set of examples that show the input and what we want the outcome to be. And we can also show things that have intermediate steps, which we'll look at in another video. The examples that we give in few-shot prompts don't have to just be an input and an output. We can actually show intermediate steps to reach a particular goal. Now, one of the reasons why this is really interesting is that when we begin showing the intermediate steps, the large language model can learn how to apply a series of intermediate steps in order to reach the goal. So we can start getting more interesting output than just here's an input and here's the output, or here's a situation and here's the action. We can start looking at, if this situation occurs, what might be the next action, and then the action after that, and the action after that, until we reach some state that is important to us, like we are no longer at risk of running into the car in front of us. And so if we tailor our examples correctly, we can actually have the large language model do sort of the intermediate breakdown of the problem into a series of steps, or we can have it decide how it might go and tackle the problem. Now, let's look at an example of this. We're going to take our car example from before, and now we're going to enrich it a bit. So we've now got actually two essentially situational examples. We start off with one, and it's the same one from before. The situation is I'm traveling 60 miles per hour, and I see the brake lights on the car in front of me come on. And then we say, think. I need to slow the car down before I hit the car in front of me. Action. Press foot on brake. Think. The car isn't going to stop in time. Action. Check if the shoulder is wide enough to swerve into. Think. The shoulder is wide enough. Action. Swerve into the shoulder. So now we've built a more complex scenario that includes the original situation, but then we have sort of updated steps of what's happening and what the thought process is and what we need to do next based on that thought process. So in this case, we're traveling down the road. Suddenly the brake lights in the car in front of us come on. We think that we're going to hit the car, so we hit the brakes. We think that we're not going to stop in time, so we look over. We see that the shoulder is big enough, so we decide to swerve into the shoulder. And so we're now basically having a more complex situation that also has multiple steps involved. Similarly, we've taken one of our other ones that we had before. I've just entered the highway from an on-ramp and I'm traveling at 30 miles per hour. Think, I need to speed up to the speed limit so that I don't get hit from behind. Action, press foot on accelerator. Think, I've reached the speed limit. Action, let up on the accelerator. So we're basically going through, we're breaking down the problem or situation into multiple steps and what's happening. Now we provide a situation, again, the parking lot situation. I'm backing out of a parking spot and I see the reverse lights illuminate on the car behind me. Action. And so now we're prompting for what we would like the large language model to decide. And now we see, instead of just a quick, it's done, look, stop, wait for the car behind me. Instead it says, action, immediately stop backing up. So we see immediately stop backing up, and then it thinks, I need to check my surroundings to make sure it's safe to continue backing up. And then action, check mirrors and surroundings for any obstacles or pedestrians. So it's thinking about what does it need to do next. It's thinking, oh, I need to look around and make sure it's okay. So it looks in the mirror, and it looks in the side mirror, the rear view mirror, the side mirror, and then it thinks, okay, it's safe to continue backing up, and so action, continue backing up slowly and carefully while keeping an eye on surroundings. So now we've got more sort of fine-grained detail in what we're actually going to do in the particular situation. Now, there's all kinds of interesting things where we can imagine doing this. We can think about customer service. The customer is reporting a particular problem, and we've recorded what customer service agents did to help the customer solve that problem. And so we could imagine that through few-shot examples, the model could learn to help a customer diagnose a problem. And if it had seen enough different examples and enough different paths, it could go through and figure out what to do. We can also, like last time, we can generate more examples. So we can say generate another example, and it says generate, situation. I'm driving on a narrow, winding road with several blind curves. Think, I need to slow down and be cautious to avoid any potential collisions. And it goes through a series of actions until it says resume normal speed. And then we could say, think, I am running out of gas. And it says, think, I need to find a gas station before I run out of gas. Action, check the GPS or map for nearby gas stations. Think, the nearest gas station is too far away. Action, reduce speed to conserve fuel and try to make it to the next gas station or rest area. But you can see how we're getting a script. It's sort of like a problem-solving script. Now, let's think about this if we're the customer service. We might want to go and generate a sequence of actions, and then we could input what the next response is that we get from the customer. So and let's look at where we end off on this example. Action, pull over to the side of the road and turn on hazard lights to signal other drivers. Call for roadside assistance or walk to the nearest gas station as possible. Think, roadside assistance is unavailable and the nearest gas station is too far away to walk to. So let's see what it decides to do. Think, I need to conserve my phone battery and find a way to get to a gas station as soon as possible. Action, check if there are any houses or businesses nearby where I can ask for help or use a phone. Think, there is a house in the distance. And so you can see how it's building up the script of what to do. It's doing problem solving, it's creating interesting situations. We can also prompt it to keep going. We can keep having it go further based on inputs, like what would happen in this situation? How would you go about dealing with it? We also see that the input is fairly constrained in what it's giving us. It's still following our pattern. Now this is a key thing to go back and think about is the intuition behind this. This works partly because this tool knows how to predict what's next given a pattern. It's learning from language, given this pattern, this is what I do next. You can also imagine that it's seen in its training data lots of scripts, things that looked like, okay, here's what is going on. You can almost think of like a movie script. So-and-so said this in response, and then you might see a description of what was happening. Well, they get into the car, exit scene, something like that. But, we're using patterns, we're using structures that are likely to have been things that it was trained on and seen. So it's learned how to, from these examples, go and extrapolate what should happen next. The patterns and its ability to learn and intuit what needs to come next in the pattern is based on that it's seen these types of things. Now, if we went and we picked some type of pattern or structure that is very different from what it's seen, it may be able to do it, it may not be. So one thing to think about is when we're structuring things, try to pick simple patterns in terms of how we structure the text. They're going to be something that it's likely seen, something similar to in the training data. So this idea of a prefix with then some situation, an action, think about trying to pick a format like that looks like something it's seen. Notice another thing, we're keeping each example, although it's wrapping around here, these things are actually each one line. So it gets much harder to follow the pattern if we say like action colon, and then we have a whole bunch of stuff on multiple lines. It becomes harder to see the pattern because not every line starts with one of these prefixes. So you have to think through the structuring and the formatting of these things, but at the base of it all, we're trying to give it some pattern that it can quickly and easily pick up on in order to understand how to solve the problem. We can provide the intermediate steps like we're seeing here, but we don't necessarily have to give it the logic for how to decide the next step. In fact, if we think about this, when we say roadside assistance is unavailable and the nearest gas station is too far away to walk to, if I had to describe the rules of how to do that and this whole situation that we're going through, if I had to really write a prompt that had all the different rules, in this situation do this, in this situation do that, you can imagine it would take up a lot of space and it might be really hard to do. Probably is going to have limited flexibility. So one of the powerful things about these few shot examples is we can tap into the large language model's reasoning, or whatever we want to call it, its computational abilities, to go and figure out what's next and come up with the next item in the pattern. let's look at some examples of where we're making mistakes in our few shot examples, of things that we can do wrong in the formatting of our prompts, and what we can kind of think about and learn from these examples. So here's some few shot examples, and the idea behind this is we put together a not very good prompt to analyze how hard things are. Like, is it soft or hard? That's really what we're trying to get at with this prompt and some few shot examples. Now, this is not a good prompt. This is a bad prompt, and we'll see why. So what we've got is we have input as the prefix. We've then got brick. We've got output as a prefix, and then hard. We've got input as a prefix, and then pillow, output soft, and then we've got input car. Now, notice what we've got here. One, we don't have a lot of examples here, but two, we've kind of switched gears. Like, you know, we started talking about input and output and the hardness of things, using things that are really obvious, probably. Like, a brick is hard, a pillow is soft. Is a car, I guess a car is hard, but it's not as clear what we're getting at. We also might just be trying to describe some fundamental sort of intrinsic capability or, you know, properties of this thing. It may not be about hard or soft, because it could be other things. It could just be an attribute to describe the thing itself, because pillows are generally thought of as soft and bricks are normally thought of as hard. Those are kind of fundamental descriptors sometimes that you use for them. And what we see is that when we prompt ChatGPT in this example, what we get is, it says fast or maybe transportation. And so this kind of shows us a couple things. This is a prompt that's not very well designed. And because of that, what we see is that ChatGPT isn't quite sure what the next, next output should be from the pattern. Now, there's a couple mistakes in here. One is we've got input and output. Input and output are really generic prefixes. They don't really give the language model much information about what the task is that it's trying to do. All we know is we're taking in something and we're getting out something, but it's not really telling us, you know, what it is that we're describing. Like, maybe we should go and say, you know, input, brick, surface feeling, you know, hard, input, pillow, you know, surface feeling, you know, soft. Or maybe it's something about, like, if you hit it, what will it feel like? You know, there's all kinds of things we could do to give it more sort of context around what we're trying to get at. We could also give it more examples. But what we've got here overall in this prompt is we've got a lack of information. It's not detailed enough, and we're not giving enough information about what the task is that's being solved, and the result of that is that the language model isn't really sure what the solution is. Now, one way we could solve this is we can go and, before we give our examples, we could give a little bit more context. So we can provide some instructions. So we could say your output can only be soft or hard. Now, one thing to notice is I'm putting these things in quotation marks to try to, you know, indicate to the language model that these are the two values. I don't want it to get confused and think I'm talking about soft or hard in some other context, but I'm putting these things in quotation marks, trying to giving them some emphasis that either it's soft or hard. And this may not always work, because we still have a prompt that's really generic, that really doesn't have a lot of context and a lot of meat to it. It's still very, you know, vague. We've got input, brick, we're still dealing with it. Now, luckily in this case, adding this little bit of additional context and specifying to the large language model that we only want soft or hard as an output helps it figure out that it should think about, if I pushed on this car, how would it feel like? It would feel hard, you know, and that's kind of the task that's being solved, and so it comes back with the right thing. But that's a first thing to think about. When you're writing few shot examples, are your examples detailed enough? Are your prefixes that you're using for these things meaningful? Do they give additional context that the large language model can use to figure out what the next thing in the sequence is? Another way to think about it is, if you gave this to 10 different human beings, would you have a chance that a few of them might be confused about what you're trying to ask for? And if the answer is yes, then you probably need to think about how to refine your prompt. Like, if it's not fully clear what you're trying to do in the examples, or what the process behind the examples is illustrating, then you're probably not detailed enough. Now, one way you can solve that is by adding some more instruction like we have here at the top of this prompt. Now let's look at another example. I've got object plane, speed fast, object worm, speed slow, and then I go through a series of examples, and notice I'm giving a little bit more context here. You know, my speed prefix is a little better, right? Because speed seems something that's quantifiable, right? Like a plane is fast, you know, a worm is slow. Like that should be more context. And so we then go prompt it with object ball, speed, and this is another important thing to realize is it says variable. And so one of the things we have to think about is we're trying to get the large language model to produce an output or to classify or to fit into some boxes. We need to make sure that it gets enough information in the input to be able to accurately put things into the boxes. So we need to make sure that whatever information we're giving it about what it's going to do always has enough context that it can make a decision about the label. Now in this case, a ball could be fast, it could be slow. If I shoot a ball out of a cannon, it might be going really fast. You know, if I shoot a ball, if I put it on the top of a rocket, it might be going really fast. You know, there's all kinds of different things that could make a ball go faster or slower. So we have to make sure that we provide enough context. Now, in general, the thing to think about is, am I giving enough information? Now I'm going to go back and I'm going to change my prompt now, and I'm going to say object, ball kicked by a baby, and then we get immediately it says slow. So when you're building up the few shot examples, you want to make sure, one, your prefixes are pretty descriptive. Two, do the examples that you're giving really give enough information to derive what the underlying process is that is going on in order to go from the starting input to the final output? Do you really have enough information there to see what's underneath the hood? And one way to think about that is if you asked a bunch of humans, would they all know exactly what you wanted it to do without any ambiguity? Two, you want to make sure that you have enough description before the examples if needed to provide additional context. Sometimes examples, you're just not going to be able to get there with examples, and you may need to provide some additional rules or other information at the start of your prompt to help it along. And so really a lot of times what you're thinking about is you have a limited amount of space in your prompt, and you have to think about, is this something that I can better describe in an example, or is it something that I can better describe in some instructions at the top? And what better means is, will I get a more accurate output, and will it take less space or maybe less words to describe it? If I can get it done very clearly in an example, then maybe that's the right way to go. That example doesn't take a lot of space. On the other hand, if it's a really simple rule and I can describe it, I may be able to get a better response, by putting that rule up into the description. And then finally, we have to make sure that we provide enough information. So in this example, ball kicked by baby, if we're trying to bucket things or we're trying to get a particular output, we have to make sure that when we give input, that there's sufficient richness and detail in that input to follow the rules or prior examples that we've given. Now this is particularly important if our prior examples were pretty clear cut. It's probably something better. Now one could argue that our prior examples, if we go back and look at this, we said a plane was fast. Well, a plane might not be fast, right? A plane might be slow. It might be sitting parked on the tarmac of an airport. And so we also want to make sure that our examples are rich enough and detailed enough. Now, sometimes we can get away with simple things like plane, fast, worm, slow in order to teach it, but sometimes we're going to have to go into more detail. We're going to have to provide more context. So make sure and think about, do you have enough real information? Is it going to depend on the situation, those things like that? Provide details. Now, one way to do it would be to say, just make some assumptions, but one of the things that can happen sometimes when you do that is you may get more verbose output than you really want. It may not fit into that bucket. But when you're writing these prompts, think meaningfully about what is a meaningful prefix? What information or instructions do I need to have at the top, and can important information be better conveyed as an instruction at the top or as an example? Do my examples cover the space enough? Do I have enough good examples with rich detail for it to learn from and derive what the underlying process is. And then when I go and I give it the new input, do I make sure I have enough, relevant context and information with the new input in order to, apply the process that I taught it? Because we may teach it the process really well, but then give it a new input that just fundamentally is missing information in order to apply that process. You may remember being told to show your work when you were a student, probably in elementary school or middle school, and you were working on a math exam, and you had to explain how you got there. Or maybe if you've gone on and you've done other things where you had to prove, that something was true that you had decided. And so showing your work, explaining your reasoning is something that can be really important in a number of different domains. And it turns out that when it comes to writing prompts, this can be really, really important. Getting an LLM or a large language model to explain its reasoning behind something actually can make the large language model perform better for us. Now, this is a really interesting thing, but if you think about it, it kind of makes sense, right? Because we have a large language model that's trained on different patterns of text, and it's learned to predict what comes next. So if it can explain its reasoning correctly, then it's more likely that it's then going to produce the right answer, because the right answer sort of intuitively should come after the correct reasoning. Similarly, if you think about it, if it starts explaining the reasoning correctly, if it gets the first step right, it's probably going to get the second step right, because it may have seen similar problems reasoned out. Now, this is an intuitive explanation. This may not be right, but I think intuitively you can kind of think about it is that if you break down the problem you're solving into multiple independent steps and you explain them and there's sort of a natural sequence and logic and flow to them, it's more likely that the final output, which is the answer, is going to be a natural extension of the correct reasoning and therefore correct. It's more likely to be correct if your goal is to accurately predict the next token. Similarly, if you have the problem and you get the first step right and the second step right, you're probably going to get the third and the fourth as a large language model because you've been trained on this stuff. So there is a technique for this, and it's called chain of thought prompting, and I'm going to show you examples of this. But it's really helpful to remember when you're building prompts that require some sophisticated sort of intelligence and reasoning capabilities. Now, we don't always need this type of breaking the process down step by step and explaining the process. But when we do, and we need that more effective reasoning, it's really useful to understand how chain of thought prompting works. So I'm going to start off with a positive example where we use it and we show what it does and how it works. So we have some examples here that we are going to give. Sorry, I'm actually going to start off with the negative example first. I apologize, that was a mistake. So I'm going to start off an example that does not use chain of thought prompting, and I'm also going to show an example where I'm going to make a mistake in how I phrase the prompt and how I structure the prompt. And I'll come back to this mistake in a second. But what I've got here is I have three different questions that require some reasoning. In the first two, I've given an example of what I want. I say, I have 4 bike racers start a race and travel an average of 30 miles per hour. They each race for 2 hours. Is the total number of miles ridden by all riders greater than 200? And then I have an example and I say answer yes. And then I say a question. I have a staging process for a bike race to line up racers. It takes 47 seconds to stage a group of 8 riders and 67 seconds to get the group to the starting gate and ready to race. I want a new group to start the race every 30 seconds. Do I need 8 groups staged at all times in order to have races continually starting every 30 seconds? And the answer is no. This is the example I'm giving it. And we'll see the reasoning behind these in a minute. And then I say, I'm in a spaceship without gravity. I have a cup with a needle in it. I move my foot on the bed, knocking over the cup onto the floor. I lift a book up and put it on a desk. Is there anything on the floor? Now, this is the question I'm trying to get ChatGPT to answer. And so I've given it basically some examples of questions with answers of either yes or no. So I'm trying to elicit a yes or no answer from ChatGPT. I'm using few shot examples to do that. And I'm showing it questions, I'm showing it answers. And then I'm asking it for the answer about this question about a cup knocked on the floor. Now, I have actually seen some variations of this, and I apologize because I don't remember exactly where I saw this first example of reasoning with the cup and the needle inside of it knocked on the floor. But I thought this was an interesting one because it works really well for showing the difference between chain of thought prompting and without. So this is without chain of thought prompting. So what does ChatGPT say? Because we asked it, is there anything on the floor? So the question was, I'm in a spaceship without gravity, I have a needle with a cup, or I have a cup with a needle in it. I move my foot on the bed, knocking over the cup onto the floor, and then I have some irrelevant information, and I say, is anything on the floor? Now, without chain of thought prompting, it says yes. When the cup with the needle in it is knocked over onto the floor, both the cup and the needle will end up on the floor. In the absence of gravity, objects will not fall downward as they do on Earth, but they will still move in response to forces applied to them. In this case, the force applied by your foot knocking over the cup will cause the cup and the needle to move and come to rest on the floor. Lifting a book and putting it on a desk does not affect the position of the cup, so they will remain on the floor. So it says, yes, there's going to be something on the floor, the cup and the needle. Now, let's look at the same example but with chain of thought prompting applied. So here we go with chain of thought prompting. So with this one, we've spelled out the reasoning behind each of the examples. So we go back to the bike racer, and we say, will the total be greater than 200? And so we say reasoning. Each rider will ride 30 miles per hour times 2 hours equals 60 miles. I have 4 riders. Therefore, the total number of miles ridden by the riders is 4 times 60 miles equals 240 miles. And then answer yes. This is chain of thought prompting. We're explaining the reasoning behind the examples to the large language model. So in this case, we're explaining, we're sort of working out the math, showing our notes of how we got to this answer. And then we do the same thing for the next one, where we're staging a bike race and we want to figure out how many people have to be staged at a time in order to start a race every 30 seconds. And we give the reasoning. Each group takes 47 seconds plus 67 seconds to be ready to race. So I will need to calculate how many races will need to be run before a group is ready to race. A group will have 114 seconds over 30 seconds equals 3.8 races run before it is ready to race. I can't have a partial group, so I need to round up to 4. I only need 4 groups staged to be able to race every 30 seconds, so I do not need 8 groups. Answer, no. And so you see, rather than just say, here's the example, here's the answer, we say, here's the answer, here's the reasoning, and then here's the answer, the correct answer. So then in this final example with the spaceship, again, we're having the spaceship, there's no gravity, we have a cup with a needle in it knocked on the floor, and then in this example, we tell it to provide its reasoning first, and then its answer. So we're prompting it and giving it a format that makes it clear we want the reasoning first and then the answer. And what's interesting is we see different reasoning than we saw before, and we get a different answer. If you remember before, we got the answer of yes, their cup and the needle will be on the floor. But if you look down here on this one at the bottom, we can see that it says answer no, because there's no concept of on the floor in a zero gravity environment. So if we look at this one's actually giving us sort of a better reasoned answer in my opinion. Now there's probably different nuances, and I'm not an expert on this, but I think if you don't have gravity, you're not necessarily going to have the cup and the needle resting on the floor just because they got knocked off. And so the reasoning is better. In this one it says, in a spaceship without gravity, objects do not behave as they do on Earth with gravity. When the cup and the needle is knocked over, the cup and needle will not fall to the floor as they would on Earth. Instead, they will float in place or move in the direction of the force applied to them. And so, therefore, in the absence of gravity, there's no concept of objects being on the floor as we stand them on Earth. And so basically what it's saying is like, well, you might move them or cause a force to be applied, but they're not going to just sit there on the floor because there's no gravity. And so it comes up with the answer no. So you see right here, we're getting a completely different answer out of the large language model. And the difference is that one example, we're giving it the examples, we're giving it the reasoning behind the examples, and then we're asking it to provide the reasoning and then the answer, which is this case, and where we're saying, no, there's nothing on the floor, which is probably a better answer in this case. In the other example, all we're doing is saying, here's the question, here's the answer. Here's a question, here's the answer. And we're not giving it the reasoning. And then finally, we're saying, here's a question, and it's going to try to produce the answer first, which is what it does. And so the difference is really only in what it does. Here it's answering first, but it's not explaining its reasoning first. And its reasoning actually isn't quite as good, and its answer isn't quite as good. Now, spaceship knocking a cup with a needle off on it, this might not apply to you, but it's an interesting example of where there's more nuanced reasoning. And if you have a case where you need to have it think through, and I say think very liberally here, but if you need it to try to get better reasoning behind the answer or a better computation, whatever you want to describe it as, but intuitively, if we've thought through the process of getting the answer and we have a good process of breaking down the problem and going step by step to a solution, we're likely to get a better answer out, a better solution out. And so that's what chain of thought prompting is doing, is we're trying to elicit that break the problem down into steps. Think about, step by step how you're going to solve it. And the way that we get there, the way that we get to do that is when we give it few shot examples like we do up here, we explain the reasoning behind the answer, and we explain the reasoning first. We say, this is what I'm thinking and doing. This is why I'm getting there. Similarly, we do it on this one too. We say, here's my reasoning, and we provide the reasoning before the answer. And the goal is to get the large language model to do the same thing, to follow our pattern of breaking down and explaining the reasoning before giving the answer, to think through the problem, to give the fundamental steps, and then to produce the answer. And we get better outputs in this case, and in most cases it's been shown that you're going to get a better reasoning out of the large language model if you have it explain its chain of thought, what it's thinking through, what it's trying to do in order to solve the problem. Then you'll get a better answer out. Large language models, as powerful as they are, they can't do everything on their own. They're going to have to reach out into other data sources, and they're going to have to learn how to use other tools to be really effective over time. So one of the things we have to learn how to do is build prompts that can allow the large language model to essentially reach in and query new information, to use other tools that can help it do reasoning or computations that it fundamentally is not designed to do. And so how do we go about doing that? So one way of doing that is with an approach called React. So the idea behind this is that we want to teach essentially the large language model how to think through a process and understand steps where it needs to go and use some other tool, to take some other action outside of it and get the result of that tool and bring it back in as some type of computation or result that it can then incorporate. And so there's a specific way of writing prompts to do this. Now, this is similar to chain of thought prompting like we saw before. We're going to use some of those same concepts from chain of thought prompting, but we're going to expand the approach to have this concept of certain things that the large language model knows it needs to use some external tool to perform. So let's take a look at this. Now bear with me because this is a longer example. We're going to do a single example that we're going to teach the language model with, and then we're going to ask it to perform the same task. So in this example, we have a task which is calculate when I need to arrive at the Music City BMX national race for my son to be on time for his 9 to 10 open race. So BMX is a bicycle racing sport. Some of my examples lately have been around BMX. And Music City BMX is a local BMX track here in Nashville that hosts one of the big national races for BMX racing. And so one of the things is I need to figure out, when do I need to show up at the track? Because these are all-day, multi-day events. And sometimes you may want to figure out, how late can I sleep before getting in the car and driving then in order to arrive? And what happens is, in these races, you have hundreds of individual little races that are essentially like 30 seconds each. These are called motos that are run. And you want to figure out, when you're moto 87, for example, well, how long do I need to wait after the start before that race is going to start? And so sometimes there's a balance there of trying to figure out when do I need to be at the track actually, as opposed to when does the race start. And so what we're going to do is we're going to have it solve this problem for us. We're going to pretend to solve this problem. This isn't actually solving it, but we're going to show you how this process works. So we give it a task and we give it an example, which is calculate when I need to arrive at the Music City BMX national race for my son to arrive on time for his 9 to 10 open race. And then we say, think. I need to find out what time the first race begins. I can use a web search of the Music City BMX site to get that information. So remember, this is our example. So we're saying, here's the thought process. I need to first figure out the first step. Now you remember back to chain of thought where we're trying to have it explain its reasoning. Well, we're kind of doing the same thing. We're explaining the reasoning behind it. So we're saying, I need to find out what time the first race begins. We're explaining what we're trying to do. I can use a web search of the Music City BMX site to get that information. And then we have the next thing we do, which we say action, search, and then we give the Music City BMX website. And so action here in the search is basically a tool that it's learning to use. It's learning to use some external tool, in this case a web search. So it knows that there's certain information it does not have, and so we're teaching it, when you need information that you don't have, go and search for it, and you can search for it with a website. And then it says the result, we tell it, is all races start at 9 a.m. So then we say, think. I need to find out how many motos run before the 9 to 10 open race. Motos are essentially the individual races that are going to run before that race. I can use a web search of the Music City BMX site to get that information. And then we show it again, another example of searching, assuming there's a search tool available to it, for the Music City BMX site. And then result, we show it the result. There are 30 motos that run before the 9 to 10 open race. And then we say, think. I need to find out how long each moto took last year. I can use the video live stream from the USA BMX website and record how long the first 10 motos took. And then we say action, video, and we give it some fake video and pretend that, hey, we were able to go and pull this video down and time something. And then result, the first 10 motos took 5 minutes. Think, if 10 motos took 5 minutes, 30 motos will take 15 minutes. The race starts at 9 a.m., so I need to arrive before 9:15 a.m. when the race starts. I will arrive 30 minutes early at 8:45 a.m. to be safe. So remember, this is our faux example. We've kind of imagined a scenario where I need to solve this problem, and I'm using a series of web searches and then watching a video from a prior year to figure out how long things took. And I'm trying to teach the large language model, in this case ChatGPT, to use these same tools to solve the problem. So then I ask it, here's the new task. Calculate what time my 36 to 40 novice race will end at the USA BMX Grand Nationals. And then I say, think, to prompt it to start thinking what is the next step. And you'll notice what it does. It then says, I need to find out what time the first race begins at the USA BMX Grand Nationals. I can use a web search of the USA BMX site to get the information. Action, search, USA BMX Events Grand. So notice it's picked up on a couple of things. It's picked up on the idea that it has this tool called search that it can use to go and pull in information. You'll notice it's also picked up on the format of the URL. Now, this format I had was just completely fictitious in this example, but it's picked up that, oh, there must be this formatting, there must be a pattern behind these URLs that I can use, so I can go and search and use some knowledge of the structure of those URLs to pull in the right information. So it's learned, essentially, how to go into a web search. And then it says result. Note, as an AI language model, I'm unable to perform web searches. Please assume a hypothetical result of the purpose of this exercise. The first race begins at 8 a.m. Now, what's interesting here is if we were actually integrating this into a real system, we could have the system, whenever it sees a result, stop, pull in the actual result, put it in there, and then basically feed this first chunk back to the language model to then continue the process. So we don't actually have to worry about if it's going to fake the rest of this. We could just have it go and we could incrementally get to each time we get a new result out that we actually need to fill in, we could go and run the web search and fill in that result. It then keeps going. It says, I need to find out how many motos run before the 36 to 40 novice race at BMX Grand Nationals. I can search, and it goes and searches on the grands, and then it has a hypothetical result. There are 120 motos. Goes and thinks again. I need to find out how long each moto took last year. I can use the video live stream, and then it picked up on the URL pattern. So you notice it's learning a lot of things. It's learning how to use the tool and how to input data in a particular format for it based on what I showed. It then says, okay, here's the result from that. And then it says, think if 10 motos took 6 minutes each, or took 6 minutes, then each moto took an average of 0.6 minutes. Therefore, 120 motos will take approximately 72 minutes. The first race starts at 8 a.m., so the 36 to 40 novice race will start around 9:12 a.m. I need to find out how long the 36 novice race itself will take. And it goes and does that. And then it says if the 36 to novice race starts around 9:12, then it will end around 9:15. This is the approximate time my race will end at the USA BMX Nationals. And so what's interesting is that it actually ended up in the end getting slightly off track. It gave me the begin and end, so it's telling me the begin time, but it also went and calculated the end time, which I may or may not want. But the more important thing is that along the way, it followed my pattern. Up here, I taught it this concept of searching. So I had action search, musiccitybmx.com. I had another action search for musiccitybmx.com. I had an action video right here. And it learned how to use these tools, and then it's applying the exact same tools down here. It's applying search, it applies it again, then it applies video, and it's applying it using the format. So you can imagine it's essentially learning to, run a web search, to watch a video, but again, these are tools, so it could basically go and send some information off to the tool, get an answer back, and then pick up in its reasoning. Now, the way that we would do this is we would have to have a way, if we're going to use this, to actually, when it gets to the point where it says, here's what I'm going to do, we would stop it and go give that data to the real tool, get the answer, and then come put it in for the result. And then we would feed this whole thing back in with the correct answer as the prompt. It then hopefully will run through up until it gets another action, in which case we would go and get the real result from that tool, put it into the prompt, and continue. And we would continue down until we got to a point where we had an output. Now, a better way of doing this would be to have some, way of it saying, okay, I'm done, and I should have put that into the prompt here. But this is doing basically, it's teaching it, here are some tools that you can use if you use this format. So you can go and run this particular tool, and you describe the tool to it. Now, other ways to do this, you can also, if I didn't have every tool used, I could have edited this prompt and I could have had a description of each tool and the format and other information that it could use to help it figure out which tool to use. Now, in my simple example, I did it just based on giving it patterns that I had directly in the sort of the few shot examples that I provided. But you can also have other ways of sort of catalogs of tools and their descriptions so it can think about which ones to use at the appropriate time. And you see how it's beginning to reason and know, which tool do I need to use at which point in time to get which type of information. So you can teach it to do this sort of problem solving so you can go and integrate it with other tools, and you can build these prompts that allow it to tap into other tools. And you see this in a variety of different frameworks. There's a tool you may have heard about called LangChain, which is a framework for writing these types of automation processes, and they use React underneath the hood in order to be able to go and do some of the interesting things like this that they do.
Thanks you for watching my video. Please like and subscribe my channel. Thank you for spending your valuable time with us. Your views and support mean the world to us. We couldn't do it without you. Thank you for being a loyal viewer.
We're going to be faced with the problem with prompts of the large language models themselves are going to be moving very rapidly. They're going to be continuously evolving, and we've already seen that. We've seen ChatGPT and GPT-4, we've seen Llama and Alpaca, we've seen Vicuna, and lots of different ones are continually coming out. And one of the things we want to know is when we develop our catalog of prompts, our patterns, we put lots of work in developing prompts that work well for us, how do we evaluate them and make sure that they're maintained over time? Because if we change our large language model, does that mean that all of our prompts are going to break? Or if we change the data that we're working on slightly, does that have ramifications for us? So we need better ways of helping to evaluate the output. Now, one way, of course, that we're going to do this is we're going to have humans look at the output in many cases. But we'd like to do things that could probably help us scale better, be able to actually go and do sort of large-scale automated analysis in some way. So how do we go about doing this? Well, one of the really interesting things with large language models is we can actually use them to evaluate themselves. This can be one of the inputs that we use to help determine how good our prompts are and how maintainable they are over time, is we can use a large language model to grade either itself or the outputs of another large language model. So we've seen the examples of this where they've actually taken large language models and they've had one large language model teach another large language model essentially. But we can do something similar in that we can take outputs from a large language model and actually feed them back into the model itself to grade them, or we can actually go and take another large language model that we're working with and have its outputs graded by, for example, a better large language model, maybe with more parameters that has more powerful. So let's look at an example of this and how we might build a prompt to do it. So in this example, I'm going to teach the large language model, in this case ChatGPT, how to grade the output of a prompt. I'm not actually going to show it the prompt in my example. I'm just going to teach it the grading process so that it can help automate it for me. And so I'm going to use some few shot examples. So as input here at the top, I'm saying here's my input, and it's a bit of text about Vanderbilt University from Wikipedia. It identifies that Vanderbilt University was founded in 1873. And I explain, here's what the output was. The output was, the following is a list of events and dates in the output. Vanderbilt founded 1873. And then the explanation is that the output has unwanted text at the start and should only include the names and dates. And so I gave it a grade of 5 out of 10. So this is the output that was produced, and then I'm providing a human explanation of what is wrong with the output, of why it's not getting a perfect score. And then I'm grading it and giving it a 5 out of 10. So I'm going through and I'm doing a couple of these by hand to show it what I want. And then I'm giving it another example with that exact same piece of text. I'm saying the output was just 1873. And the point of this is that, if you can probably sense it by now, is I want a prompt that's going to extract events and the dates that the events took place. And that's it. I want an event name separated by a comma and then the date of that event. I don't want any other text. I don't want explanation. I just want names of events and dates. And I'm showing how ChatGPT can grade the output to see if it's matching that format. I'm not even showing it what the prompt is. I'm not showing it what the task is. I'm giving it examples to help learn. And then I say explanation. The output is missing important information about the event that happened on that given date. And I give it a grade of 3 out of 10. And then I have one more with the input, which is that same paragraph about Vanderbilt. I show Vanderbilt University, 1873, which is the ideal output for my fictitious task. And I explain that the output exactly, and then I actually cut it off. There's a typo here. It's really supposed to be met expectations or something like that. And then I give it a grade of 10 out of 10. What's interesting is this doesn't even matter that I made a mistake here in my explanation because it still works. And so then I give it a completely different input. I say, here's a different input. Again, it's about Vanderbilt and the history of the English program at Vanderbilt and creative writing. And so I give it as input another piece of text on that. I say the output was, and I give it what the output was, the fugitives and South agrarians, first half of 20th century. And then Vanderbilt is a founding member of the Southeastern Conference, 1966. And that's essentially a prompt for ChatGPT to then go and grade that output. And so it then provides an explanation of the output. It actually mentions something that I didn't grade in there, but it's interesting. It says there's inconsistent capitalization. And then it gives it a grade of 9 out of 10. So as a human labeler and a human performing this task, I actually ended up with a 9 out of 10 because I wasn't consistent in capitalization. But you can see it did a good job. It took the sort of substance of what I wanted and it performed the grading task that I had given it. And so we can actually use large language models to evaluate the output of prompts. Now there's a number of ways you could potentially use this. One is if you have some system that's going to go and make decisions or generate information with a large language model like ChatGPT or some other model that you're running, you might want to have the model check itself or another model check itself, or you might want to do this multiple times where you take the output that you're getting and you give it a grading criteria similar to what I've done here, and you've developed a prompt with grading criteria. You might have multiple prompts with grading criteria, and you all have them score the output. And then if the score is below some threshold, well, maybe you want to have a human look at that output, or maybe you just want to retry it and see if you can get something better to be produced. And so this gives you an extra sort of tool of how do we go and evaluate what's coming out, make sure it looks good, and still have sort of the power and sophistication of these models. And this is one way to do it. Now, there's lots of ways that you could phrase the prompt. You might want to go and look at the alternative approaches pattern to develop some different ways. This is one example using few shot examples. Now, I could have gone back and say, we could have said act and use the persona pattern, act as a prompt critic, perform and give the output that I provide you a grade in terms of how well it matches the expectations of the prompt designer. I am going to give you examples of grading prompts. And so we could have gone and done something like that. I did a relatively simple prompt, but we could do a much more sophisticated prompt using some other patterns. Again, it's going to generate an explanation, and then at the end of it, it should generate a grade for us as well. And so it'll then go through and give us an 8 out of 10. So you notice we got 8 out of 10 one time, we changed the prompt slightly, we got 9 out of 10. Either way, it looks like that's a pretty good output based on our grading criteria and what we want. And so we can use this sort of tool in our toolbox. When we need to evaluate a prompt and the output of a prompt, we don't have to always fall back to having humans look at it. One thing we can do is we can fall back to having the large language model itself evaluate the output. And then we can build different types of automation around that, or we can use that as a trigger to escalate to a human. Now, of course, if we have a lot of really good examples of grading, that helps us a lot. But we don't have to have a ton. If you see in my example, I had just 3 examples of grading the output, and it did a good job of figuring out what I wanted. One thing that I find really helpful when I'm trying to learn a new topic or improve my skills in Sarah or just have fun is to play a game. And when we can play games with new knowledge that we're trying to acquire, it's usually a fun way to really become masters of that knowledge and test our ability to use it, particularly if the games are fun and sort of challenging. And so one of the patterns that we can use is called the gameplay pattern. So the idea behind this pattern is we're going to ask ChatGPT or another large language model to play a game with us, and it's going to decide the rules. It's going to be the game master in most cases. Now, we can give it a variety of different sort of scenarios that can govern what its role is in the game, but we're going to look at gameplay where the large language model is serving as sort of the game master. It's creating the rules and it's driving the game. And so we can then take a game and we can say, I'd like a game on this topic, or that has these basic rules, fill in the rest. One of the things that's really nice about this is that if we say create a game and we give it some basic structure around the game, it can tap into its training data in order to populate the game with content. So if you think about games like, getting the rules right obviously takes a lot of thought, but then there's a whole other challenge for a lot of games of how do you create a lot of great content to go with that game? And so this is a pattern where we can tap into the training data from the large language model in order to help it populate the content. Now it can also do a pretty good job of deciding the rules as well, but we're not going to necessarily look in these examples at complex rule generation. But we are going to look at a really useful example of this, and I'm going to show you how to create a game to improve your own prompt engineering skills. So the basic pattern of this is to say we are going to play a game, and we say involving or about or whatever, and we want to give it the topic. We start off this pattern by saying we are going to play a game and here's the topic. And then we decide some more information about what are the rules of the game. So in this case, we're going to have some simple rules. You're going to give me a simple task that can be accomplished via prompting you. So I'm telling it, we're going to play a game. You pick tasks where I could theoretically prompt you in order to solve that task. So you imagine what we're trying to do is have it play a game with us where it's going to give us a challenge of something we would try to write a prompt for, and then we're going to write the prompt and see if we did a good job. And then it's going to say, we're going to say your tasks should all have a reasoning or programming component to them, although they shouldn't require source code. Now, the reason I do this in this game is you get more interesting questions in my experience if you have some logical component to this. Remember, we talked about prompts as a way of programming a large language model, that everybody can be a programmer, and that's what we're trying to get at. We don't just want to generate a bunch of poems about lonely trees standing in the middle of a field. You know, we'd like to do more than that. We'd like to have to solve problems that have some sort of logical or interesting component to them, and that's what we're getting at here with this prompt. So we're going to build a game. It's going to challenge us to develop different prompts, and then we're going to try to make these tasks that we're solving related to sort of programming or logical things. Now, next we go on and we give it some more rules. I will try to write a prompt to solve the task. You will give me the output of the prompt and tell me how well it solved the task. So it's going to give us the task, and you notice we're having it ask us questions. So it's going to give us the task. The task is going to be something that can be solved with a prompt. We'll write the prompt, and then it will run the prompt in order to generate the output that prompt would have output. And then it's going to tell us how good our prompt was. So this is interesting. We're actually having it play a game where it's pretending to be prompted and then telling us how good our prompts are. Ask me questions until I tell you to stop. You will ask me a question, wait for my response, and then ask me another question after telling me how I did. Ask me the first question. And so it says, great, let's get started with this first task. Given a list of numbers, determine whether the list contains any duplicate elements. If it does, return yes, there are duplicates. If it does not, no duplicates found. So now we've got a specific prompt engineering task. We're going to have to figure out how do we write a prompt where we give it a list of numbers and have it return one or the other of these things. And it's kind of interesting, right? This is one of the challenges that we often face when we're dealing with a large language model, is getting it to generate a precise output. And so it's giving us something where it has sort of a thought component to it of like, how do we design and tell it about what it is we're trying to achieve, but also it's also got an output component. We're trying to match a specific output format. And then it says, please write a prompt for me to solve this task. So I'm going to solve this task using few-shot examples. So I give it a list of numbers. I show it some examples. I say basically in my prompt, I say, here's the numbers 1, 2, 3, and then I have duplicates, and I say no duplicates found. Then I have numbers 2, 2, 2, duplicates, yes, there are duplicates. And so I'm following the output format it told us, and then I'm going through and giving it a series of few-shot examples to solve this. And then I prompt it, my final end of my prompt is basically duplicates question mark on the list I just gave it, which is solving the problem that it's asking for or trying to. We'll see what it says. But basically I'm asking it, does this list have duplicates? And we're hoping that what it says is no duplicates found and match this exact format that I provided before. And it does. It says no duplicates found right here. And then what's nice is it does the other part of the game that we explained. Your prompt effectively communicated the task and provided examples of different cases or of different cases. The task was to determine whether a list of numbers contains any duplicate elements, and you provided with examples. Based on your prompt, I was able to correctly determine that the list does not contain any duplicate elements. And then it goes on and it says, let's move on to the next task. So now it's playing the game, so it's moved on to the next task. Given a sentence, count the number of words in the sentence and return the results in the format. The sentence contains X words, where X is the number of words. So it's giving us an output that I have to produce. And notice it's giving an output now where I have to put the output in a different particular format. So before we just had to go and say there's duplicates or no duplicates, but now we're having to do something a little more complicated. We're having to count words in the sentence and then make sure the count shows up in a particular place in the output. This is exactly testing our knowledge of prompt engineering and some of the patterns and other techniques that we've seen in the past. Please write a prompt for me to solve this task. I'm going to use a pattern called the template pattern to do this. So what we say is I'm going to give you a template for your output. Number is my placeholder in all caps. Fill in my placeholder with your output. Please preserve the overall formatting of my template. My template is, and then I have the sentence contains number words. So I'm going to solve this problem. Here's my prompt to go and solve this problem. And then I say, how many words are in the following sentence? The cat jumped on the mat. And it says the sentence contains 6 words, which we see is exactly the format that it was looking for. And then it tells us, it grades us on our prompt. So what's really nice about this gameplay example is that from now on, you can go and use it to test your ability to do prompt engineering. And you don't have to think up what are prompt engineering tasks that I could try out. You can just use this prompt to have it generate the content for you. It can think up the ideas of the problems for you to solve with prompt engineering. And we can see in this simple example, it's already gone and tested some different dimensions of prompts for us and given us some opportunities to try out some different patterns. It then goes on and it gives us another interesting one. Given a date in the format YYY, MMM, DDD, meaning year, month, date, determine whether the year is a leap year or if not. If it is a leap year, the year is, YYY is a leap year. If it's not, and so how do I solve this? I'm going to go through and give it some few shot examples, kind of similar to I did before. But it's testing my ability to figure out what do I do to solve this in this particular case. And then it gives us the right output that 2023 is not a leap year. Now, what's really nice about this is, remember, it's supposed to be checking our prompts and testing our prompt engineering skills. And I want to show you something that I didn't even notice until it told me and tested me. So I said date 2009, 7/24, so July 24th, 2009, and then I asked if it, and then in my example I said leap year right here, and then I said the year 2004 is not a leap year. So my prompt example actually had a mistake because I'm asking it if 2009, July 24th, 2009 is a leap year, and then in my example I give it the wrong template. I say the year 2004 is not a leap year. It should have been the year 2009 is not a leap year. And then it actually notes that right here. It says there's a small typo in the third example. The year 2004 is not a leap year should be the year 2009 is not a leap year. But this did not affect my ability to understand and respond to the task. But it does give me feedback on my prompt engineering. It also shows me I need to be careful about the examples I'm giving it. If I make a mistake in my example, in this case I got lucky and it didn't affect things, but it could in future ones. It then goes on, gives me a new one which I didn't actually go and solve. Given a string of characters, determine whether the string is a palindrome. The string is a palindrome. If the string is not a palindrome, return this string is not a palindrome. Replace string with the actual string. So it's getting a little repetitious in here, but we could go in and inject additional sort of ideas to help tailor the output even more. So you can imagine we might want to go in and target our prompt engineering a little more. Now, we've been learning a lot of prompt patterns in this paper. So one way we can adapt this game is we can give it a more specific topic about the type of prompts we're trying to develop. So in this example, I'm going to take the description of the recipe prompt pattern, And what's helpful is you can go to our prompt patterns paper, and you can actually take a little section or explanation of those patterns along with the name, and you can provide it into this game as context, and it does a reasonable job if you provide enough information on the pattern and examples of asking you questions that would use that pattern to solve it. So in this one, I go in, I actually modify the game and I say all of your questions should revolve around the recipe prompt pattern. This pattern provides constraints to ultimately output a sequence of steps given some partially provided ingredients that must be configured in a sequence of steps to achieve a stated goal. The pattern is not about cooking per se. Now, I added this in here because I knew in my heart that it was going to want to ask me cooking questions, which, that's fine, but I've done enough of those. But creating a complete sequence of steps to achieve a goal given an incomplete list of intermediate steps. So I really want to use this. Cooking is obviously a natural way of talking about recipes, but I don't want it to clue in too much on that. I'd rather do some other interesting tasks. And so then it says, your goal is to create a prompt that instructs me to generate a sequence of steps for assembling a simple wooden bookshelf. The bookshelf has 4 main components: the top and bottom panels, the side panels, and the shelves. You have been provided with the following ingredients. Attach the top panel to the side panels, insert the shelves into the designated slots. Using these intermediate steps, create a prompt that will result in a complete sequence of steps for assembling the bookshelf. Remember, the prompt should be designed to fill in any missing steps and provide a clear order for completing the assembly. Now, what's interesting is this is kind of an interesting prompt because it has to have an understanding of a bookshelf and its structure. And you would have to go and write a prompt that's going to elicit the right problem-solving behavior on assembly of a bookshelf. So it's kind of a cool little problem. I then went and I took it and I said, all right, well, let's use another one of the patterns from the paper. And so I adapt and I say, we're now going to change the topic of your questions. The topic is now the context manager pattern. And then I'm basically providing the intent and context from the paper, and I'm saying this pattern enables you to specify or remove context for a conversation. And I'm not going to go into the details. It did a pretty good job. It asked me a question about the Eiffel Tower and its construction. Then I went and I changed the topic again. I said, we're going to change the topic of the question. The topic is now the template pattern. And I describe what the template pattern is. And it actually does something that follows what is exactly said in here, which is you might want to generate a URL. So we might get all URLs, so we might want to tweak this a little bit, but it does a good job. It then gives me a task. Your goal is to create a prompt that instructs me to generate a URL for a product page on an e-commerce website. The URL should follow a specific template structure, and it gives me the structure, product ID/name. The product ID and product name are placeholders that need to be replaced with the actual values. So you can see how I've got this game. It can test me on prompt engineering, so I'm learning about prompt engineering. It can actually give me helpful feedback. It caught a typo in my few shot examples. And then I can go and tweak it. I can say, okay, now the topic is we're going to do a game based on this particular prompt pattern. Now we're going to do one based on this pattern. And what you'll see is you'll get interesting content that will come out of it and challenges of things that you can try to prompt. Now, they may not all be good. They may not all be interesting. You may get in a rut where they're kind of getting repetitive. But that is on you then to think about what additional information do you go and inject into this game to make it fun again or to make it more variable. I was pretty surprised at the quality of questions that I got, and it brought in a lot of topics, like assembling a bookshelf is not one I would have thought about. That's certainly an interesting one. Or when it asked me about information related to the Eiffel Tower and its construction. All of these things are kind of bring fun to the game. Or is it a leap year or not? All of these things are kind of interesting ways. And all I did is gave it kind of the base rules and then the topic area, and then it pulled in all this information to populate the game with things that kind of help keep me engaged. New content, new ideas to challenge me and make me have fun. And in this case, writing out the rules is a lot easier than thinking up all the content for the game, which it does really effectively. Getting a large language model's output in exactly the format that we want can be a challenge sometimes. So the next pattern that I'm going to teach you about is going to help you get exactly the format you're looking for and tell ChatGPT where you want the information that it's producing put into the format. So you're basically going to give it a template, and then ChatGPT is going to go and fill in your template. Just like you might do with an assistant, where you'd say, here's the template that I use for creating these form letters, and here are my different placeholders within my template, and then your assistant could go in and fill in that template. And that's exactly what we can do with the template pattern. So the idea behind this pattern is we would like a specific template followed for our output, and we can describe that template to ChatGPT and then have it produce all of its output using that template. Now, we could do this with other approaches like few-shot examples, but we're going to do this with the template pattern in this example. So here's what the template pattern looks like. We say, I'm going to give you a template for your output. We're cueing the large language model that there is a template that's going to be in play and it needs to follow it. Capitalized words are my placeholders. So we're telling it, when you look at the template, if something is capitalized, that's something that you're going to replace with the content that you're generating. Fill in my placeholders with your output. So there's our cue to it to go and replace the placeholders. And please preserve the overall formatting of my template. We don't want ChatGPT to just decide on its own what the format should be and ignore everything that we're giving it in terms of instructions. And then I say my template is, and I've got this sort of funky little template down here, and I'm going to talk through it. So I have question with 3 asterisks in front of it and then 3 asterisks following it. Now what this is going to do actually is this is using some knowledge of how ChatGPT in the ChatGPT interface formats the information that we see. So those 3 asterisks are basically going to mean you're going to italicize and bold this as like a heading. So it's going to say question, and it's going to be in italics, and it's going to be in bold. And then we want it to fill in a question. So question, which is in all caps. And notice we're differentiating between things that are part of my template and things that are capitalized, which are things that are placeholders that it's going to fill in. And then we're saying answer, similarly, it's going to be in italics and bold. And if you want to figure out how this works, this is called Markdown. So we're basically, ChatGPT is rendering the output to you in Markdown. So I'm just using this knowledge to help me out a little bit. And so I'm creating a template that includes Markdown. And then we're using a placeholder for answer. Now, you can guess I'm going to have it generate questions and answers. This is what's going to come next. But right now, I'm just telling it what the template looks like. Here's what my template is going to be, and I'm going to ask you to fill it in. And then I tell it, I will give you the data to format in the next prompt. Create 20 questions using my template. And of course, it says it's happy to do that. So then what I did is I pasted in from Wikipedia an article on Paleo-Indians. My son was studying Paleo-Indians at school, and so I thought it would be fun. Can I generate some questions about Paleo-Indians for him and see if he can answer them or learn more? And it might be interesting to talk about these questions. And so I paste that in, and then what we see is we get output that follows the template that we gave it. So if you remember, the first thing was question, and it was not in caps. So this was something we wanted it to preserve. And then we had question in all caps. And ChatGPT has generated a question about the Paleo-Indians. Who were the Paleo-Indians? Now, interestingly, it has decided to put this in all caps too, which actually kind of works for the format. I didn't actually mean for it to put it in all caps, but it works. And then I had answer, which was not capitalized. And then I had answer was something to be filled in that was in all caps, and it fills in the answer. So it's creating questions about Paleo-Indians. Who were the Paleo-Indians? And then it's filling in the answer to the question. But the whole thing is structured using my template. And I told it generate 20 of these questions. And so it's basically repeated my template 20 different times, but filling in the content. Now, notice these are like really powerful placeholders. The placeholder I gave it was question. And so it has to understand what is the meaning of the word question. It looks at and has to understand to some degree, and people may argue it's not really understanding anything, it's doing something else. I'm going to talk about it in terms of understanding because I think that's a natural way to talk about it. If we later discover it doesn't really understand, it doesn't matter. That the template pattern is a great way of using this, and it's easier to talk about it in terms of understanding. So it's understanding the placeholder, that it means question, that your question that you generate should go here. And then it's understanding answer. Answer is where the answer to the question should go. And it knows from my prompt that it's supposed to generate 20 of these questions based on the content I'm giving it. So it's extracting 20 questions about the Paleo-Indians and producing the question and the answer and formatting it according to my template like we see here. And we get a bunch of questions that we could go and then have a discussion about. So there's a first example of it. We can also go and take it and say, take this a little bit further. So I took my colleague Doug Schmidt and I imagined well, what if I wanted to go meet Doug Schmidt for the first time and I wanted to try to know something about him and have something to talk about and make sure I was versed on his background so I could intelligently talk about what he was doing, what he was interested in, his background. And so I just took his web page here. Now, ChatGPT explains to me, hey, I may not have a version of this web page before 2021. It's kind of fascinating that it actually is able to take information from a web URL. It's a little trick. It may not be up to date. Of course, you should, if you're going to use this before meeting somebody, own the information and make sure it's actually correct, but it could give you a starting point. And so then it goes and generates 20 questions using the format that I gave it about my colleague, Doug Schmidt. Now, looking at the questions so far, they seem pretty good. Now, if we wanted to do this in a more reliable way, we could have pasted in the actual questions or paste in the actual information from his web page in order to get information about him and generate 20 questions. Now, I'm going to show you another example because I talked a little bit about these placeholders, that they're not just placeholders. Like, there's a real deep understanding of the meaning of the placeholders when you're using the template pattern. You don't just have to think of them as being really easy to match. They can also be kind of smarter placeholders, a placeholder that you might give to another human being if you wanted to explain to them how to use the template you're providing. So let's look at this example. I'm giving it the same sort of preamble for the template pattern. I'm still using capitalized words. I'm still using Markdown to try to get this formatted in a way that I want. In this case, it's going to create headings wherever I have these hashtags. And so what I'm doing is I'm saying bio and name. So I'm going to paste in information about a history of Vanderbilt. And I would like to get basically a list of people from that history of Vanderbilt. And I want the names of the people, and then I want an executive summary for each person and a full description for each person. Now, I'm stating that my executive summary is a one-sentence summary. So you notice my placeholder is more than just go and talk about this person. I'm actually putting constraints on what I want there. I want one sentence that summarizes, this person's role as described in the information I just gave. And then for full description, I say I want a one-paragraph summary. Now, you can imagine you could go and capitalize a complex set of instructions. A one-paragraph summary that only considers their history as part of Vanderbilt before 1800. Now, I haven't actually tested that one out, but I suspect it would actually work. But the key thing to note is I'm giving it more than just a simple match. I'm actually giving it a match on summary, go and create a summary here, but I'm also putting constraints on what it should be. It has to be a one-paragraph summary, or a one-sentence summary. And so this is like a power of the template pattern, is that we can kind of have complex instructions in the placeholders that we're actually going and replacing. So now I'm going to take a look. I pasted quite a lot of information in, and this is what we get as a result. Is we get the headings as we had before with the name. That all makes sense. But then if we look at the executive summary, it's exactly one sentence. So it's not only filling in the template, but it's filling it in with the rules that we've described in the template. So now we've got a one-sentence summary in the executive summary. And in the full description, we've got a one-paragraph description. And it goes through this for every single person that it extracts from the information that I give it. So the template pattern is a way to help you get the output that you want in the format you want. And you can use the placeholders in really sophisticated ways. They can be something that can semantically extract information. So I can dump a bunch of information in and say, I want to know the people. And it has to understand who are the people in this box, this bucket of information that's just been dumped in. It has to be able to extract the people. And I can say, I want a summary of each person, but it has to be one paragraph. So you can have instructions and constraints on these placeholders. You can also have sophisticated things. We could have said, for example, what is the role of each of these people in the history of Vanderbilt? And it could describe their role. So the placeholder can not only format the information, it can not only do sort of simple extracting and matching, but it can also do sophisticated things. It can follow rules or do things that would be really time consuming for a human, like take and extract information that would require a human to read through and understand and then put it in. So we're saying create a one-sentence summary of this person. Well, if I was going to have an assistant do that, they'd have to go read all the information and then make a list of all the people. For each person, they'd have to write first the one-sentence summary to try to capture everything about that person, and then they have to go write the one-paragraph summary. So that's really fast, really sophisticated intelligence that it's using. And the key to getting the output that we want from it is using that template pattern. We're saying, this is the format that you're going to give it to me in. This is exactly where everything goes. And here are these sort of really sophisticated rules in the placeholders to help you decide what goes in, how it gets formatted, what to exclude. It's a really, really powerful pattern for getting information in the format that you need and getting the right information put into that template. Describing everything in full English sentences or full sentences in whatever language you speak isn't always the easiest way to give the input to the large language model. Now, if you think about it in the real world, a lot of times we have our own specialized languages to describe different domains. So math may have its own specialized language, or we may have shorthand for taking notes or describing different interesting things. We may create our own little languages to be able to capture information in a more concise way than if we wrote it out in full sentences. Now, of course, the key to these languages is that the person that we're communicating with in the language knows the language too. They know the meaning of the different the statements that we're making, the different symbols or words that we're using. Now, as an example of this, we've been doing a lot of work in partnership with the city of Nashville and the emergency responders. And one of the things they do is the operators who are taking calls, and you can imagine this is a really stressful situation. They're trying to take notes down about what's going on in an emergency, and they actually have their own shorthand notation. You can imagine the stress and difficulty of receiving a call around an emergency and trying to take down information that can then be used to, take the appropriate action, send an ambulance or send a fire truck or whatever needs to be done. And so they have their own little shorthand notation. And if you go and just try to read this, you're not necessarily going to be able to read it and understand it because it's designed for people who use it day in and day out to be able to communicate with each other, but not necessarily to be as explicit and obvious as possible. So I'm going to teach you a pattern where we can basically teach a large language model a new language and then communicate with the large language model in that new language or shorthand. So this is called the meta language creation pattern. So we're going to create a language. This is going to be our meta language creation, where we're going to go and describe to the large language model what our language is, what are the meanings of different symbols or statements in that language, and then we're going to go and converse with the large language model using it. So let's look at our example here. We're going to create a trip planning application. Now, I haven't gotten into the meta language creation pattern, but I'm giving you an example that uses it. So we're going to create this trip planning application. I will describe my trip, and you will list interesting things to do in the places that I will pass through. I will tell you how many days I will stay in each place, and you will list possible itineraries. so far we've just got a prompt to help us do trip planning. Now, here's where we're going to go and use the meta language creation pattern. I'm going to say to describe my route, I'm going to use a shorthand notation. So we're queuing it in that we're going to tell it about this shorthand notation. When I say, and notice this, Nashville, 3, arrow, Memphis, 2, I mean that my route will go from Nashville to Memphis and that I will stay 3 days in Nashville and 2 days in Memphis. Now, I want to kind of draw your attention to something here. Notice that I'm starting off by saying, when I say this, here's an example of my new language that I'm creating, or my new shorthand that I'm creating. I mean this. And so you're taking an example and then you're showing it what you mean. So you're then saying, I mean that my route will go from Nashville to Memphis and I will stay 3 days in Nashville and 2 days in Memphis. So you're giving it basically a translation. Now, another way to think about it, this is similar to few shot examples. You're saying, here's an example of, input, here's the example of the output, or here's the example of a comment on a movie, here's an example of the sentiment analysis for that comment. You're kind of doing something similar, except what you're doing is you're saying, when I say this in my language, this is what I mean, and you're showing it the translation and the meaning behind it. The other thing to note is that my notation is much denser than the full English that I'm going to use. So it's Nashville, 3, arrow, Memphis, 2, and it's that short thing is describing this much longer, basically statement that says my route will go from Nashville to Memphis and I will stay 3 days in Nashville and 2 days in Memphis. I could write all this out, but I want to have my notation. Now it goes ahead and trip plans for me on Nashville and Memphis, and I'm going to skip that and I'm going to go down to now where I have an actual just statement. So notice we've now programmed our new language. We've done the meta language creation pattern, and now the large language model understands our language. So we say Nashville, 0, and Nashville, 0 means I'm leaving from Nashville. I'm not going to stay there. I don't want you to trip plan for me in Nashville, which is an interesting thing that has to, consider that in the logic. I'm going to Dallas, 1, and then arrow, Granbury, Texas, 4. And so basically what I'm saying is my trip is going to go from Nashville, I'm not going to stay there at all, Dallas, I'm going to stay there 1 day, and then I'm going to stay in Granbury, Texas for 4 days. And it says, sure, since you mentioned that you won't be spending any time in Nashville, I'll focus on providing you interesting things to do and possible itineraries for your 1 day stay in Dallas and your 4 day stay in Granbury, Texas. So it then plans our 1 day stay in Dallas. We have a 1 day stay in Dallas. It describes what we're going to do on that day. It then describes for Granbury, Texas over here, it says 4 days, and then it describes what we're going to do in Granbury for the 4 days. Now, if I wanted to experiment with different itineraries and I wanted to really quickly have a shorthand for saying, well, what if I did this itinerary? What would I do? What if I did this one? It's a lot more condensed. Now, also, I have to admit, I'm a computer scientist and a programmer, right? So I like having things that look like condensed programming language instructions, but you can imagine a lot of people use shorthand notation abbreviations. You can use them too in the language model. You just have to explain it to it, unless it already knows it. If you're using something that's well understood, you can just say, I'm going to use this language, or I want you to interpret this in the same way that you would interpret it in a math context, and you could explain what that means. So it plans our trip. Then here's where I go and try it again. Look, I'm getting a more complex statement. I'm saying I'm going from Nashville to Fairhope, Alabama, where I'm going to stay 3 days, to Gulf Shores, Alabama, where I'm going to stay 1 day, to Montrose, Alabama, where I'm going to stay 1 day. So now I've got a much longer statement, and if I had to write that all out in words, in full sentences, it would take a lot longer to write it out in full sentences. But I've described the language, and now this kind of crazy string that I've put together, it knows to take that and use it as the input for the trip planning. So now it says Fairhope, Alabama, 3 days, and it gives me my planning for my itinerary there. So it gives me my day 1, day 2, and day 3. It then says Gulf Shores, Alabama, 1 day, and then it provides my itinerary for that 1 day in Gulf Shores, and then it understands Montrose, Alabama, and gives me my one-day stay and mantras and gives me examples of things to do. So you can imagine that this is a really sort of helpful capability. You may want to go and start thinking about, how do I develop a shorthand notation for the tasks that I do really frequently with the large language model, and where it would save me a lot of time and effort if I could describe what I want using some shorthand, and maybe we can also describe it more precisely. Maybe there's a way to describe it more consistently. So if everybody uses the shorthand, the meaning is less ambiguous because we've already defined it in advance, and there's less variability in the explanation, or in the how you express it in the shorthand. So maybe you're an organization and you want everybody to express certain information the same way to make sure that the reasoning from the underlying large language model is consistent. And so now it's not always necessarily going to be consistent, but at least you would get the data, entered in a more consistent way. So you could define your own language for your organization for describing certain types of information, and teach that to your people so that when they go in and they enter in that information, you're going to have a consistent sort of semantics to what that information means. Now, if everybody goes and just describes it in English using whatever phrasing, whatever level of detail, etc., that they want, you may not get the outcomes you want from your prompt. So by having your own language or shorthand, you can help constrain how you define things, how you express information to the large language model, and hopefully help it reason better. Sometimes we know part of the solution that we need when we're working with a large language model. So we have a problem and we know some of the steps or some of the pieces that we want involved in the solution, but we don't know the full solution. And what we need is the large language model to help us fill in the blanks, to put together the missing steps, basically to complete the recipe. Give us the detailed set of steps that take the ingredients that we have or the bits of information we know about how to cook this particular dish and fills in all of the gaps. And so the recipe pattern is a pattern for doing this. We give the large language model some goal that we're trying to achieve, and we give it the parcel set of steps that we know that we're going to have to involve in creating the overall sort of solution, the recipe, the goal, whatever it is. We're going to give it part of what's needed and ask it to fill in the rest. So this is really a way of getting the large language model to help us fill in our gaps in a process, or gaps in our knowledge about a series of steps that need to be taken. So the recipe pattern can be really useful. And I'm also going to show you that our sort of intuitive shorthand for describing gaps and ways that we talk about things that we know are part of a process or part of a series of steps, but we don't know the exact details, that our intuitive way of expressing that is actually something that the large language models like ChatGPT can understand. So let's take a look at an example of this. So we're going to say we're going to add a feature. So we're going back to our trip planning application. And we're going to say, I will tell you my start and end destination, and you will provide a complete list of stops for me, including places to stop between my start and destination. So notice what we're doing is we're providing essentially an incomplete recipe. We're saying, here's where I'm going to start, here's where I'm going to get to, but I need to know what goes in between. And it goes back and it takes one of our prior examples of going from, or actually it creates its own example of traveling from Nashville to Atlanta, and notices that you're going to go through Chattanooga on the way, which is true. If you're going to drive from Nashville to Atlanta, you're probably going to drive through Chattanooga, and it suggests things that you could do, like going to the Tennessee Aquarium in Chattanooga or Lookout Mountain. So where it gets interesting is, if you remember back to the trip planning application, I taught it my own language for describing my trips. And so I used the meta language creation pattern. Now I'm going to combine the meta language creation pattern and the recipe pattern to do something interesting. So what I'm going to do is I'm going to say Nashville, 0. So I'm starting in Nashville, and then I'm going to have just dots or ellipses, basically dot, 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 arrow, dot, 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 arrow, Fairhope, Alabama, 2. So I'm going from Nashville to Fairhope, Alabama, and basically what I'm signaling to the model is, I want you to complete it. Tell me where to stop in between, and I'm indicating I want to stop twice. I'm willing to make 2 stops in between, but I don't know where. You fill in the recipe that gets me from Nashville to Fairhope and has 2 stops in between. And it understands this. So dots are obviously dot, dot, dot is a natural way that we can express something we don't know. It understands that, and it fills in the recipe. It says we're going to start in Nashville, Tennessee, no time spent as per your request. I highly recommend spending time in Nashville, Tennessee. I live here, so all of my trips start with not staying in Nashville because I'm always here. Well, not always, but a lot of the time. And then it fills in the 2 stops for us. It fills in Birmingham, Alabama, and Montgomery, Alabama, which are both between Nashville and Fairhope if you take the most direct route. And then the end is going to be Fairhope, Alabama. So you notice it's basically understood the constraints that we placed on it. We said Nashville, 0, arrow, and so we're using our language. We're just defining the starting point. We're then saying dot, 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 meaning this is something I don't know. It's a blank spot in my template or my recipe. So you need to fill in this recipe with where we should stop here, and then arrow, dot, 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 and I'm saying here's another blank spot where I don't know what should go here in the recipe, fill it in, and then arrow, Fairhope, Alabama. And so it's gone and we're using the recipe pattern here to get ChatGPT or another large language model to complete our request. And if we went and we did this again, so if we said, LA, and let's just do 1, and then we said dot, 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 and we'll see how it interprets this because I think it's unclear to me what it even means. And then we said we're going to go to New York. Let's see what it interprets this as. And so it now starts giving us a trip saying, okay, here's where you're going to start, Los Angeles one day, then you're going to go to Las Vegas, Grand Canyon, Santa Fe. I'm curious if it'll, how many stops it's going to have. So you notice that when I did this one, I had 4 placeholders here. I'm getting more than 4 placeholders in between because I kind of expressed that I wasn't really sure. Like I don't have dot, 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 arrow, dot, 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 arrow, and then I'm there. I just have dot, a whole bunch of dots, which is much more indefinite, which is exactly what I wanted it to do, interestingly enough, and I didn't know if it was going to get there. But I was basically expressing, I'm going to go from LA to New York. I'm going to have a bunch of stops in between. I don't know what they should be. Plan my trip for me. Here's how long I'm going to stay in LA. Here's how long I'm going to stay in New York. And everybody can argue with how long I'm spending each place. They're all wonderful places, but it interprets the missing pieces of my recipe. It probably also knows that I'm going to need quite a few stops if I'm going to make this a leisurely drive from Los Angeles to New York, and it fills in a whole bunch of different places that I could potentially stop along the way in order to have an interesting trip from Los Angeles to New York if I run a very long road trip as a vacation. And so this shows you how the recipe pattern works. You give the large language model the goal that you're trying to achieve, the pieces that you know need to fit into the solution, or the steps that have to be there and where they're going to be placed. And then you ask it to fill in the rest. And you can use ellipses or other types of things to indicate places where you don't know what's going to be there and you want it to fill it in. And it'll go and complete the recipe for you using the recipe pattern.
Thanks you for watching my video. Please like and subscribe my channel. Thank you for spending your valuable time with us. Your views and support mean the world to us. We couldn't do it without you. Thank you for being a loyal viewer.
Brainstorming different approaches to solve a problem is a really, interesting way of using a large language model, and one of my favorite uses for it. So something that I really like about large language models is that I can come up with a problem that I want to solve, and I can rapidly come up with different ways of solving that problem, and I can test them out and get feedback. Now, one way to do that is using the alternative approaches pattern. So the idea behind this is we're going to have the large language model within some particular scope always suggest alternative approaches for solving a particular problem or performing a particular task. That is, we always want it to give us good ideas. Now, I say good ideas, they may not be good, they may not even work, but kind of like brainstorming in a group. You may have a lot of different ideas, some of them may be great, some of them may be terrible, but just the fact that everybody's thinking through ideas, throwing them up on a whiteboard or writing them down or talking about them can help you, do a better job of thinking through the problem and figuring out what is the right solution that makes sense. So I'm going to show you how to use the alternative approaches pattern to essentially perform brainstorming with the help of a large language model. Now, one of the things to note is just like if you get a group of participants that have different backgrounds, they may help you come up with ideas that you yourself would not have come up with. Well, a large language model was trained on a big corpus of material, and it's probably seen lots of problems and seen discussions of different solutions to that problem or different alternative approaches for a particular problem. So you can think about it, it is in some ways learned information about how to solve problems in different ways and can help us get access to that knowledge. Now, it may also have never seen the exact problem that we're asking it for, and it may be able to synthesize, using what it's seen in the past, interesting potential approaches. Even it hasn't seen the exact problem that we're working with. So let's start off with an example of this. We're going to do the alternative approaches pattern. We're going to say from now on, if there are alternative ways to accomplish the same thing, list the best alternative approaches. So this is a very generic wording for this. It's probably better to structure it very precisely to the task that you're working on, provide more rich sort of context. But I'm going to show you that even within a fairly generic wording, we can get this pattern to work for us. And then I'm going to say compare and I'll contrast the alternatives and ask me which one I want to use. So I'm adding a little bit to this pattern. I'm saying give me the alternatives, but also give me some information. Compare and contrast the alternatives. So maybe that'll help me think through which one is going to better fit my particular situation. I can see if what are the pros and cons of each approach and which one sort of is a better fit based on those pros and cons. And so I then ask it, if you think back to in some of the past videos, we've looked at using gameplay to create prompts and test us on our ability to write prompts. And so one of the problems that ChatGPT generated for us is it asked us to write a prompt to distinguish leap years. Basically, we would give it dates and the prompt should be able to determine if it's a leap year or not. And so I'm going to turn that into a task for ChatGPT. So I'm asking ChatGPT to write several prompts for itself to solve this task. So I'm having ChatGPT write the prompts for me. Now, I could have introduced this earlier in the course and just said any task that you have, you want to be better at prompt engineering, ask ChatGPT to do the prompt engineering for you. And that's basically what I'm doing here. And sometimes this works, but I don't want you to think that this is the best approach, that I should just always go to ChatGPT and ask it how to do it. No, you should have a sense yourself. Just like any problem you're bringing into a large language model, you have to own the content. So you should have some expertise in this area to help you distinguish what are the better approaches, what things don't make sense, what's unsafe or harmful in some way. You need to own whatever content comes out. So that's part of the reason I didn't just start by saying, prompt engineering, go ask ChatGPT for the prompt. We're not going to do that. But in this case, we are. We're saying we want ChatGPT to write a prompt to use few-shot examples to determine if a date in the year, month, day format is a leap year, and the output should either be year is a leap year or this is not a leap year. And so ChatGPT then says, approach 1, direct question format. In this approach, we directly ask ChatGPT whether a given date is a leap year, and then it shows us the few-shot examples for doing this. So it's generating the prompt for us that we could provide, use essentially to go and check if something is a leap year. Then the second approach, it says conversational format, and then it uses a completely different sort of style. It's still roughly the same format of generating few-shot examples to solve this problem. Now notice I scoped it to few-shot examples. I could have left the scope more wide open and just said write a prompt to do this, but I thought it'd be fun to look at different, can we write the few-shot examples in different styles and will it make a difference? And we could go and test this and see if it does. But we now see it generating, again, it's solving the problem of showing few-shot examples for leap years. And now it's actually, I noticed something interesting. It's showing us how to solve the problem. It didn't actually fully follow the format that I gave it because I said Y is a leap year, or this is not a leap year, and it is putting the date at the year at the front. So it's actually made a mistake, and this is part of the reason why you should read your prompts that it generates. So make sure they're doing exactly what you want, but I could go and tell it and fix it and refine it. But you notice now I've got two different approaches to few-shot examples to solve this problem. And then at the end, I get a comparison. It says approach 1 is more formal and structured, making it easier to understand and parse. It may be suitable for applications where a clear and concise answer is required. And then it says approach 2 is more conversational and natural, making it more engaging for users. It may be suitable for applications where user interaction is important, which is kind of true. If you were going to prompt the user and then have like, here's what the user said, here's what the assistant's supposed to say, this would probably make sense. If you were just, reporting on a Q&A, then maybe the other format makes sense. So it's a reasonable discussion of the different alternative approaches for solving this problem. Now, let's look at another example. I thought, what is a task that can sometimes be burdensome? And so I thought about email. Now, I haven't actually done this and tried it out on my email. I still kind of keep my email personal, if I can, to my laptop, but I thought that this would be an enhancement in the future if I was running a large language model directly on my laptop, something like Llama or Alpaca, maybe I could do this and I would be comfortable with it. And so I say, whenever I ask you to write a prompt for me to accomplish a task, and I'm going to change the alternative approaches pattern slightly. I'm going to tweak it a little bit for this one. List what the task is, list alternatives for completing the task, and then write a prompt for yourself for each approach. So some basic format. Now I'm doing two things. One is I'm having it list the task at the beginning. So right here I'm saying list the task. And then I'm saying list alternative approaches for completing the task. So this is going to be upfront. One, it helps me know what its approaches are going to be before I even see them. I can see a preview. Two, this can actually be helpful for large language models. If you have it kind of summarize the task and summarize different approaches or reasoning, this has been shown to be helpful in many cases. So I'm actually asking it to do that at the beginning, just to show you how you can tweak the pattern and get some possible improvements. In this case, it does roughly the same thing that we saw before. And then I ask me what I want you to write a prompt for. And so the prompt I ask it is I say, write a prompt for ChatGPT to automatically detect questions in a chain of emails and summarize everyone's questions as bullet points beneath each question. So the idea behind this is really, this key part is at the end, you can imagine getting behind on email and you want ChatGPT or some other large language model that you trust looking at your email, that you put it in the whole email conversation chain, assuming that you're following appropriate privacy and other rules around whatever content is discussed in that email chain. Maybe you start with something like what movie or what restaurant people want to go out to eat when you have like a group discussion. You get to these long group discussions and they've gone off the rails. People have discussed other things, thrown in jokes, commented on other people's jokes. And by the end of it, you can't really decipher who wants to go to what restaurant and why, because there's all this other random stuff thrown in. So you might go and say, summarize the questions and people's opinions on it, and it'll give you maybe just the discussion about the restaurant and people's perspectives. So you would dump this in, and I say, write me a prompt to do that. And so it gives me three different approaches. One, write a prompt that instructs ChatGPT to first identify all questions in the email chain and then extract responses related to each question. And finally, summarize the opinions as bullet points. Approach 2, write a prompt that asks ChatGPT to simulate a conversation where it plays the role of a summarizer. And notice it's basically using the persona pattern here in its own prompt for itself. asking the user to provide the email chain and then generating the summary with bullet points. And then finally it says write a prompt that presents the email chain as a case study. That's an interesting approach. I wouldn't have thought of that. What's interesting is a case study, it probably read lots of case studies, so it's probably good at thinking about how do you think through a case study. And ask ChatGPT to provide a summary report that includes the questions and the corresponding opinions and bullet points. And then it gives me each of the different prompts. So ChatGPT, your task is to analyze the following chain of emails and identify any questions that were asked. For each question, please summarize the opinions expressed by the participants in the email chain as bullet points beneath the question. So it's generated its own prompt for itself. Prompt approach 2, ChatGPT, let's simulate a conversation where you play the role of a summarizer, and it goes on to discuss it. And then it has a slightly different format down here for how it wants things presented. And then finally, prompt for approach 3, ChatGPT, consider the following chain of emails as a case study. That's really interesting and a completely different approach. That's one I just would not have thought of from the beginning. Now, maybe if I went to business school or something, I would be more thinking of case studies and this is a natural approach, but this is something new to me, and so I can learn from how to write prompts. And now I have 3 completely different approaches that I could go try out without having to think of them myself. And I've also learned something, maybe case studies and presenting different points of view on an idea as a case study is a good way to get output from ChatGPT. Now, what would I like to do next? Well, I'd like to take my alternatives and I would like to evaluate them some way. And one way to evaluate output, particularly when it's just text and you want to figure out how good does it look, does it seem to solve the problem, is just use the large language model to evaluate its own output or to evaluate the output of another large language model. Now, usually you want to do this in a separate conversation, right? You don't necessarily want to tell the large language model, now evaluate yourself. Sometimes that leads to worse behavior where it just says, oh, I'm right, Sometimes what we want to do is take that into a separate conversation and evaluate it. And I'm basically asking it, how would you write prompts to take your own output and evaluate? How would you write prompts to evaluate the prompts? And so I say write a prompt to evaluate several different prompts for summarizing the questions in an email conversation and the different stakeholders' perspectives on the questions. And so then it gives me 3 alternative approaches again. Approach 1, write a prompt that presents multiple prompts to ChatGPT and asks it to evaluate each prompt's effectiveness in summarizing questions and stakeholders' perspectives. Approach 2, write a prompt that instructs ChatGPT to simulate a conversation where it plays the role of an evaluator and the user provides different prompts for evaluation. So again, using the persona pattern. And then write a prompt that asks ChatGPT to provide feedback on each prompt and suggest improvements, if any. And so there's kind of a different take in each one. The last one is really about how do we improve each one. Second one is using the persona pattern to act as an evaluator. And the first one is really to evaluate effectiveness. So they're kind of different sort of takes on the same idea, but now I have 3 completely different ways that I could go and take my prompts that it generated itself and kind of look at, and evaluate them using ChatGPT itself. When we're working with large language models, often we're going to describe in our prompt a set of rules that we want the large language model to follow. Rules that are going to affect its output and essentially program the large language model. And one of the things that we're going to want to do is we're going to want to say, here are the rules, now apply them to an input that I'm going to provide later. And so one of the challenges is how do we get the large language model not to immediately respond to all of our rules? If we have a flipped interaction, for example, sometimes when we flip the interaction and we say ask us questions, it'll generate 10 or 20 questions all at once. And so what we want a way to do is basically a simple way that we can get the large language model to listen to what we're saying, acknowledge it, and then wait for input from us. Now, we can do this with the ask for input pattern. So the idea behind this is we want to get the large language model to listen to the rules and then ask us for the input to apply the rules to. So when we're talking about asking questions in a flipped interaction, we might want to describe the rules for asking the question, and then we just want it to ask one question. So we just want to get one question out. If we're describing rules for alternative approaches, we might want to say, here are the rules. You're always going to create alternative approaches to whatever I ask you to do. But just ask me now for the first task to create alternative approaches for. We don't want it to go and have a big response to it. And what we see is that that's not always the case. So let's take a look at this example. Now, in a prior video, I introduced the alternative approaches pattern. And when you saw me use this pattern, it worked really effectively because I was actually combining it with the ask for input pattern. So I'm going to show you what it looks like when I don't combine it with the ask for input pattern. So I went and I said, whenever I ask you to write a prompt for me to accomplish a task, list what the task is, list the alternative approaches for creating the task, and then write a prompt for yourself for each approach. So I'm asking ChatGPT, give me a bunch of alternatives for prompting you, ChatGPT, to solve the task. So this is going back to the earlier idea where I showed how we could actually use ChatGPT to generate prompts for itself, to help us with prompt engineering. And what I do is I use this, but I'm taking away something important that I'm going to show you in a minute. And what it does is ChatGPT responds, it says certainly, but then it dreams up a task. It says, here are 3 alternatives for completing the task, organizing a cluttered desk. I'm not interested in the task organizing a cluttered desk. It just responded to my initial prompt, which was create alternative approaches for a task. It dreamed up a task and then dreamed up its own approaches for that task. Now, I'm not interested in this, so now I've got my conversation and it's got all this extra stuff in it that I don't care about. I had to wait for it to generate it. And, you know, if I was trying to create some interactive experience that had some consistency, this would not be helpful. So what I can do is I can apply the ask for input pattern. And the idea behind this is we just do one simple thing, and that is at the end of the prompt, we tell the large language model to ask for the next input. So in this case, we say, ask me for the first task. So the very last thing we do, we describe all the rules or whatever it is that we want in our prompt, and then the last thing we do is we said, now ask me for the first task. Ask me for the first idea. Ask me for the first thing you want me to generate a story about, whatever it is. But it's a way that we can sort of cut off the large language model and tell it, don't go generate a bunch of stuff. You know, I'm glad that you can do that, but what I want you to do is I want you to stop right here and ask me what I want to do. So it's a way of forcing the large language model to basically turn the control back over to the user and let them decide what to do next. Now, like all prompt patterns, when we're dealing with a large language model, it is somewhat stochastic or random. It means it's not always going to do exactly the same thing every time. And it may not work 100% of the time, but this works very, very reliably to just say, ask me for the first input or whatever it is at the end of the prompt, because it clues the large language model in that it needs to stop. And if we look at the comparison of the output, it's actually much more focused. So we see in this case, it says, certainly, let's begin. What is the first task you would like me to create alternative approaches and prompts for, rather than this much longer thing that it generated before that was not really helpful to what we were doing. So it kind of cuts it off. Notice it's the same input, but it's sort of cut it off. It's told it, look, you need to stop right here and you need to wait for my input. One of the things you may have noticed that I've started doing is I've started combining patterns together. And this is going to be one of the most important concepts when you want to build really sophisticated prompts, is you need to think through how to apply multiple patterns in conjunction with each other in order to solve the problem that you're dealing with. So rather than just thinking about, okay, which pattern can I use to solve this problem? Instead, what you want to think about is, okay, which pattern will solve certain aspects of the problem, and how would I combine those patterns together? And we started to see an example of this with ask for input and alternative approaches. Ask for input is a pattern that can be applied with a lot of other patterns. In this case, we're applying it in conjunction with ask for their provide alternatives. And so we've got alternative approaches and we've got ask for input, and they're being put together to build a prompt that's solving the overall problem. Now, what we're going to see throughout this remainder of this course is that this is the way we build really, really sophisticated prompts, is to think about taking multiple patterns and combining them in interesting ways. Now, if you think back to some of the patterns that I introduced in the course and some of the examples I gave, now that you know more of the patterns, you'll probably see that I've actually been combining patterns all along in different examples. So in gameplay, for example, I probably used ask for input. And in gameplay, I used probably the persona pattern. And so you can see how putting things together helps us solve the overall problem. And so when you're going and you're trying to tackle some new complicated prompt that you need to engineer and develop, you want to think about, okay, what are sort of the fundamental pieces to this problem? And do I have existing patterns that I know about that I can use to hopefully tackle all of it? But if I can't tackle all of it, can I use patterns and apply them to as many different pieces as possible so that your unknown piece that you really have to start from scratch and invent something new, that it's as small as possible, that we can start with as many pieces as possible with a roadmap for them, a pattern to apply. And so that's what we're going to be doing. Now, it may start to seem more complicated than it is, but at the end of the day, what we're still doing is we're still building up language, right? We're still writing in natural language. We're still writing sentences. We're still communicating. We're just thinking intentionally about the patterns in our language. And we're thinking about what are the statements in the organization of those statements in order to solve the problem. And so in some ways, combining patterns is really doing a more powerful version of programming. We're starting to take different sort of programs or instructions that we know how to use and put them together in more complex and sophisticated ways in order to have prompts that have more power to them, that have more depth to them. And again, you know, don't feel that this is something you can't do. Everybody can do this. At the end of the day, think about it. You're just describing in words what you want done. You're still describing in language what you're trying to accomplish. And all this is doing is helping us think about what should go into the instructions. If we're going to use this pattern, it's giving us a set of commands, a set of statements that we need to include and sort of an organization for them. If we're going to use this pattern, we're going to have a set of statements that we're going to include. And oftentimes putting things together is simple as just taking the statements from each pattern and making sure they all show up in the prompt. Sometimes it's that simple. Sometimes it's more nuanced, and we may need to make sure, you know, a certain statement ends up in a certain place. Like with the ask for input pattern, we probably always want the ask for input to show up at the end of the prompt, because otherwise it doesn't work nearly as effectively. So although putting patterns together can be a little bit tricky sometimes if you have to figure out where things should go, most of the time it's as simple as putting the statements together. So as we go through the rest of the course, what I would encourage you to do is to notice when I'm using multiple patterns together to solve a problem, and to think about, as you're trying to tackle new tasks with prompt engineering, how to use multiple patterns in conjunction with each other to solve the problem. There's a limit to how big we can go with the large language models. They fundamentally have a limit to the size of the input we can give them, so how big of a prompt we can give them or how long our conversation can be and they can still remember it. And there's just a limitation on how much output they can generate at once. Now, it's inevitable that these language models are going to keep getting bigger and bigger, and we're going to be able to give them more and more input and get more and more output from them. But more than likely, everybody is going to face some limitation on how big we can go. Now, the way that we work around that is we're typically generating pieces. Like we generate a piece of the solution, then we take it. So you can imagine if you're trying to generate a book, you can't just tell ChatGPT at this point, go and generate a book for me. It's not going to do it. It's going to tell you, well, I have to stop my endpoint at some point. And similarly, you can't just give it 50,000 pages at this point and dump it into ChatGPT and ask it to give you an answer, or 100,000 pages or 1,000,000 pages. There's always going to be a limit, probably, on the amount of information. So we need a way to work with it in smaller pieces, but still be able to put all the pieces back together. So one of the ways that we can do that is by building an outline of what we're trying to put together. And we can build the outline out, we can build it to the level of granularity that we want, and then we can start filling in the pieces once we've gotten enough detail into our outline. And then we can go and generate individual pieces, and we can know where they all fit together. So this is an effective way of using it to generate the pieces. Now this is basically putting a plan together. This same approach works for all kinds of things. It could be software, anywhere where we can go and sort of have this outline-like structure, and then if we generate something that fits sort of the outline or the plan at that point, then we can go and work with it. Now we're going to look at a specific pattern that can help us generate the outlines and work with them. This is called the outline expansion pattern. And so the idea is we want to make it really easy to generate outlines and continue to expand them down to the level of granularity that we need in order to build the individual pieces and then be able to put them together. Now, one of the reasons that outlines are a really helpful tool when we're building bigger bodies of work with a tool like ChatGPT is that an outline, we can always take parts of the outline and copy and paste or reintroduce them into the prompt to give the large language model context about what we want. So with ChatGPT, for example, we can generate an outline and then we can copy and paste a portion of the outline into our prompt and say, within this context, here's where you are in the outline. Now fill in the content for this and don't repeat anything that would have come before in the outline. And in fact, you can refer to the other parts of the outline wherever you're going to talk about a topic that was discussed previously. Or maybe we want to have forward references. Well, we can provide it the high-level outline and say, wherever you are going to need to talk about a topic that's going to be discussed later, you can provide a forward reference to where it is in the outline. You can do similar types of things with software or other sort of whatever the bigger thing is that you're building. Now, this works well when we have a structure that's amenable to sort of this outline-based plan. Now, sometimes we have plans or structures or designs where everything crosses over and you can't easily do this. It doesn't work to express it as an outline and express the plan, and in those cases, it just doesn't work. But many problems we can sort of build out in this sort of outline-like fashion, and then we can use cutting and pasting from the outline to provide the appropriate context. So building outlines can be a really powerful thing for us. So we're going to look at and build with the outline expansion pattern. So here's what we say. We're going to say act as an outline expander. And notice I'm starting to introduce multiple patterns here. I'm basically introducing the persona pattern. Generate a bullet point outline based on the input that I give you, and then ask me for the bullet point you should expand on. So we're telling it you're going to generate the outline, and then you're going to expand on anything that I ask you to expand on. Create a new outline for the bullet point that I select. At the end, ask me for what bullet point to expand next. So notice I'm using the tail generation pattern as well, and then I'm using the ask for input pattern. So I'm putting a lot of things together into this prompt. And I say, ask me for what to outline. And so what we see is it says, sure, I'd be happy to help you with that. So I say, let's write an outline for writing effective prompts for ChatGPT. And so what we see is that ChatGPT generates this outline, and it's an interesting outline: introduction to ChatGPT, understanding the importance of prompts, tips for writing effective prompts, yada, yada, yada. So a lot of good things there. And then I decide, okay, let's go and expand on 3 from the outline. So if we look back here, 3 was tips for writing effective prompts. I thought, let's go ahead and expand the outline there and explore this a little more. And so then it picks up from 3 and it expands on tips for writing effective prompts and gives us a new outline. So we built, in using this pattern, we can rapidly fill in an outline, and probably there are going to be tools to support us in this very soon, or plugins to support us in this very soon, to where we don't have to remember all the pieces of the outline. With this, I would probably just manually have a document where, as it was generating the pieces, I would go and look and say, okay, here's the 3. I'll paste 3 in its expansion now, and you can easily fit the parts together. This is one of the nice things about the outline approach, is that it's really obvious how all the pieces fit together. I know that 3.1 goes underneath 3, so it's sort of describing in terms of the assembly. So if I generated a piece of an outline here, I've expanded 3, I know exactly where that goes, how it fits together in the overall whole. Then I go and say, well, you know, this idea of experimenting with different prompt styles, that looks interesting. So maybe I should go and expand that further in the outline. And so I basically say 3.2, and now it goes and expands the outline around 3.2. So you see how we've got a simple pattern, and we now can go and rapidly create an outline and keep expanding it to the level of detail. And because of it's using this outline structure, it's really easy to fit all of the individual pieces back together. And as long as we have limitations on how much input, how big of a prompt we can give, and how much output we can get at once, we're always going to be looking for ways to generate things in pieces and know how they fit together. So we want the pieces to be really obvious on how to assemble them, and we always want to make sure that we have a clear structure or set of guidelines for each individual piece so that we can assemble them. So you can imagine if this part of the outline depends on knowledge of what was covered in a different part of the outline, then we would need to make sure that that was introduced into the prompt. So we just said 3.2, but if we had an idea that maybe the conversation had gotten so long that what was in item 1 had been forgotten, we might want to go and just cut and paste the outline underneath 1 back into the prompt and then say expand 3.2, because we know 3.2 was just previously generated, but that would help give it the knowledge of what had come before and make sure that what it put into 3.2 was consistent with what had been done earlier in the overall structure. Similarly, if it needed to make sure that 3.2 was cohesive with what's going to come later, we would want to put in those pieces. So one of the things we have to think about is even if this outline style, when we do this, it will work, but we always have to think about, you know, does it still have the context to make sure the individual pieces are cohesive, even if they fit into the outline at this point? We want to make sure it doesn't do something that, you know, breaks something somewhere else. And this is a problem, a fundamental challenge that we're always working with in prompt engineering when we're building from pieces. How do we build the pieces so that they're standalone, self-contained, but can be assembled into the overall whole? And so we see this again, we just expand 3.5, which was setting the tone and style. And we get this very rapid expansion and creation of a sophisticated outline now that we can use to write text for a bigger project, to be able to try to write software. There's all kinds of sort of analogies or analogs to the outline, the sort of the master structure, where we start with a certain level of detail, then we pick some piece of it and we expand the level of detail. And then we may pick a piece of that and we may expand the detail. And then we may move back up to another bullet point in the outline and expand the level of detail. And so we can be moving up and down in the outline. We can be going up to the top level, or we can be going down to the really detailed things, and we can expand wherever we want and sort of keep a map of the overall picture that we can use to build individual pieces and make sure that we can assemble them. But also, as we build pieces, that we can make sure that ChatGPT has the relevant information, the sections of the outline, for example, that in the prompt that it needs in order to reason about or generate whatever it's going to produce next. When we're working with computer software, one of the things that's really useful is that programs typically have some menu with a series of actions that we can apply. So if you've ever used word processing software, there'll be like a file menu that allows you to run an action to open a new file or save a file. You may have a menu that allows you to search and replace different pieces of text. So this idea of having a menu and different actions that we can run is a really useful concept. And sometimes when we're working with prompts and prompt engineering, and particularly when we have a long conversation, it can be helpful to sort of develop the equivalent within a prompt. Basically define a set of, essentially a set of actions that we can run in order to work in the conversation without having to repeat these long prompts. Or we want to just sort of codify certain actions that are helpful to people and bake them into a prompt at the very beginning of the conversation. So let me give you an example of this. We're going to look at using the menu actions pattern. This is a pattern that allows us to get the same type of behavior but in prompts. So we're going to develop a menu that is a series of actions that we can run, and actions are basically, essentially a prompt. It's basically a set of instructions that we're going to give the large language model in order to do something at a particular point in the conversation. So here is how this works. We describe what we're going to type in order to trigger the action. So I say, whenever I type write bullet point paragraphs, and let me talk about this in more detail in a minute. So don't worry if this seems just doesn't quite make sense yet. So whenever I type this phrase, write, and then I have in less than, greater than, bullet point, and then paragraphs, these are placeholders. So basically I'm saying I'm going to type in write, and then a placeholder for a bullet point, and then a placeholder for a number of paragraphs. You will write content for the selected bullet point. So basically what I'm saying is I'm going to give you a bullet point that you need to go and write the content for. And then I'm going to tell you how many paragraphs of text to write. And then you're going to go and write the text. So basically I'm developing an action which is, before all I could do was expand my outline. So when I talked about the outline expansion pattern, I talked about being able to rapidly expand the outline. And now what I'm going to say is at some point I'm going to be able to tell you, no, go and turn that into text rather than just outline. So I'm creating a new action. I'm also going to go ahead and keep my original action, which is just expanding the outline. So I say whenever I type and I have a placeholder for bullet point, you will expand that bullet point. So what I'm saying is if I just type in like 3.5.2, which is a bullet point, like a number in my outline, it'll know that it means expand that in the outline. If I instead say write, which is kind of a keyword, and then a bullet point and a number of paragraphs, it knows that that means it's supposed to write the text for it. So I'm defining a menu. I now have two actions. I can either expand my outline or I can write the text for part of my outline. And so now I'm developing more sophisticated capabilities for my outline expander. I'm turning it into a real program now, something that I can interact with. So let me show you an example. Now here's my first action being run. I'm saying write 3.5.3 to. Now what that means is write the content for the bullet point that was labeled 3.5.3, so label 3.5.3, you're going to write the text for it, or for that part of the section in the outline, and you're going to write 2 paragraphs. And so what we see is it takes the bullet point 3.5.3 from the outline, which was experimenting with tone and style variations. It then writes 2 paragraphs of text for that bullet point. So I've created an action, I've defined it, and I've created a menu of actions and I've defined it in my prompt, and now I can run that action and get the text generated. And so then we see it prompts us again, what do we want to do next? So this is actually not part of the text it wrote. So it did write 2 paragraphs, then asked me what I want it to do next. So then now I'm going to go back and I'm going to do exactly what I did before. I'm going to say expand on 3.5.2. So this is what I did before, and now it knows the difference, and it knows that's a different action. And so it goes and expands 3.5.2 and puts the outline for it again. I then go down and I say, okay, give me text for 3.5.2. And notice something kind of interesting. I'm actually making a typo here, but it's kind of being smart and inferring what I'm supposed to do. And this is kind of an interesting thing, is it's a very sort of, it tries to help you out, tries to get things right. And it knows based on the pattern that what I probably meant was write 3.5.2. Instead I wrote text. So it's kind of a smart menu action system. And then it actually goes and it pulls in that bullet point 3.5.2.3. Sorry, I said that wrong. It's 3.5.2.3. And then it writes 1 paragraph of text. And so I've created basically a complex program where I can expand my outline if I want to, or I can have it write the text for a part of the outline, but I don't have to repeat myself. I get to use this simple little format, and I've explained what the format is, and now I can rerun the actions whenever I want to. So one way this is useful to me is like, if you're doing the same task over and over with prompts, it can be helpful to use the menu actions pattern to basically define a set of actions on kind of like on a menu of a prompt that you use all the time. And then whenever you want to iterate really quickly using that content and those set of actions, you can just introduce that menu actions prompt and then go and use those actions over and over on the output that you're getting in order to manipulate it or do something. You've basically built yourself your own program within the conversation. At the same time, sometimes an organization may have a number of people that are doing the same job, and they can share actions with each other to help automate different tasks. And so this could be really useful to help people be more effective with their jobs and to share with each other useful prompts. The other thing is you don't have to worry so much about remembering exactly how you worded it, right? Once you've written the action once and gotten it to work in the menu, then you can reuse it over and over without worrying about, not quite getting it right when you do it. And then that leads into a final thing that's really useful about the menu actions pattern, is that within an organization, you can share a set of common menu actions that everybody should use, and you can codify the best, wording for those prompts and for those actions and what they should do, maybe codify best practices into them, and then share them across the organization. So it allows for knowledge sharing and reuse of different prompts and then easy application of those prompts. You could also imagine baking these into a root prompt for something like a customer service portal where you want to give people certain actions they can run to look up information about their account. They could do it in natural language, but you could also describe, here are some actions you could run, and allow them to get better behavior out of it. So the menu actions pattern is a really powerful pattern that allows us to easily reuse other prompts and actions that we've used to share them with others and develop knowledge bases of them so that we can become more effective prompt engineers. We've heard over and over in the news that these large language models make all kinds of mistakes and can lie to you, and they'll never admit their mistakes in the first place, and they'll keep telling you they're right and produce weird outputs. And of course, this fundamentally kind of misses the point of the tool. These aren't meant to be tools for answering questions necessarily. Now, sometimes they can answer questions and do it very accurately. And sometimes they produce things that look like answers but aren't actually accurate. And so as long as we understand they're really for generating text, and sometimes the text they generate can answer things for us correctly, and sometimes it's going to make mistakes, as long as we realize that, we can use these tools effectively. Now, one thing we can do is we can use prompts to support us in our identification of what are the facts that the tool is putting into its output and which of those facts really matter. And we can go and then follow up on them and check them. Now, one of the things that happens sometimes when we're working with output from these tools is that because the output looks so realistic, so human, so convincing, we assume that it's true. And when it's producing large volumes of text, it can be hard to spot all the different assumptions and facts that are baked into the text that we really need to follow up on and fact check. Anything you get out of one of these models, you need to take ownership of and make sure that you've checked it thoroughly and really believe it. What do we do to support us in this effort of trying to make sure the output is correct and factual? Well, we can use the fact checklist pattern to help us figure out what facts are actually in the output and need to be followed up on. So I'm going to give you an example of this. So I've taken our outline expansion tool. And if you remember, we used a couple of different patterns, including the menu actions pattern. We used the outline expansion pattern. We had several different capabilities. One of the things we could do is we could go and expand the outline. We also added the ability to be able to generate text for any bullet in the outline. And we can generate for a number of items. And we had a whole menu system to be able to do this. Now, one of the things we'd like to be able to do is when we do generate text for part of the outline, I'd like to know what I need to follow up on and fact check at that point in order to make sure that I don't present information that's inaccurate. So if we look at this, the way that we can do this is with the fact checklist pattern. We say, whenever you output text, generate a set of facts that are contained in the output. the set of facts should be inserted at the end of the output. And you could put them wherever you want. I'm just putting them at the end. The set of facts should be fundamental facts that could undermine the veracity of the output if any of them are correct. So I'm setting up a new set of instructions for the large language model that says, anytime you produce text, give me the corresponding set of facts that the text depends on. And that's the way I can go and follow up on them and check them. And so it says it understands. And so now I'm going to use our outline expansion program that we've written. I'm going to tell it to write a paragraph for section 3.5.2.2. So this section is considerations for choosing the appropriate style, and it generates a whole paragraph of text for me. And then what it does is it generates a set of fundamental facts down here that are the facts that are contained within the paragraph. And so the facts are, for example, writing style can range from technical to creative to instructional. There are other things like instructional content may adopt a clear and step-by-step style. Now this paragraph that I chose for it to write, it has a lot of different facts that maybe they're correct, maybe they're not, but it's not something that I have to worry as much about going and extracting and just staring at text, because I now have a list of things to follow up on. At a minimum, I need to look at this list and follow up on these items, or just actually visually check them myself for my own knowledge. That's sort of the minimum level. Now I have a minimum bar. At least these things I need to go and follow up on, and it's sort of flagging to me, here are some things that you need to go and check. The other thing I can do is I can compare this list to the paragraph up here. So any person that's probably using one of these tools can compare, here's the list of facts below, here's the actual text above. Is the list of facts complete? Are there statements in the text above that are missing below? And if there are, those are probably things that I would want to go and follow up on as well. And so by checking and comparing the two lists, one, we can see, is it really fully extracting all of the facts that are important? And that in itself will clue us into and make us think through, what is this really saying and what are the fundamental facts to it? So just the sort of the action of going and comparing the facts to the text it's produced will help us get us into the mode of thinking through the correctness of what it's produced. The next thing I can do is I have a minimum bar. At least I need to go and check up. At the very minimum, I need to go and check the list of facts that it produced and follow up and make sure that they are correct. And if any of them is incorrect, then probably there's an error in the text above. And then if I notice that there's something in the text above through this comparison that's also not present in the facts, I could add that to my list and go check it. So this is a tool that can help us, get into the mode of fact checking the output. It may be correct, but we still don't know for sure until we actually fully follow up on it. And this gives us some tools to help us, one, know that there are things to follow up on, at least follow up on these things, and then two, to help us give us a tool that we can go and compare to what it produced to see, is the minimum list of things that I followed up on good enough, or are there all other things that are in that text that maybe I should think through or follow up on? Now, it doesn't guarantee that we're going to come up with the right answer. We might think that it's still accurate when it's not, even if we follow up on those facts. There may be some hidden assumptions, but it's much better than if we just read a bunch of text with no sort of support or stimulus to think through the fact-checking process. So the fact checklist pattern is something that helps us get us into the mode of checking the output, checking its veracity, and having a format that makes it easier for us to sort of extract and compare the information and the sets of facts with what's really true using other external sources. When we're having a long conversation with a large language model, sometimes we'll run into the challenge that the large language model will forget the rules of the game. It'll forget what we're trying to accomplish. What is the task that we're working on? And so one of the things we need is a way to remind the large language model, what are we doing? And we'd like it to remind itself if possible. And so the way that we can do that is by using what we call the tail generation pattern. And the idea behind this is that we're going to we're going to generate a tail, an end to the output that the large language model produces that will help remind it what we're doing. And so the tail is going to always be generated at the end of its output, and the tail will remind the large language model what the rules of the game are. And we're going to see this in the context of combining the tail pattern with the alternative approaches pattern and with the ask for input pattern. So we're going to put all these things together, and we're going to see how this is a really useful thing. So generating a tail on our conversation using the tail generation pattern is really, really effective in maintaining our conversation longer and maintaining the rules and the knowledge of our rules longer. So I've actually used this several times, and I haven't talked about it, but I'm going to show you what it does. So this is the prompt that I used in the alternative approaches pattern discussion. So I'm asking ChatGPT to generate a set of prompts to solve a particular task. So I'm asking ChatGPT to help us with prompt engineering. I'm going to give it a task, and it's going to generate possible prompts that we could use to perform that task with ChatGPT. Now, if I do this over and over, and I keep saying anytime I ask you for a prompt, you should go back and generate multiple alternatives for it, the problem I'm going to run into is that eventually it's going to forget that it's supposed to generate a bunch of alternatives and that it's supposed to be generating prompts. And so I need a way that keep reintroducing that rule into the conversation to keep it alive longer. And so one way I can help do that is with the tail generation. And so this is the tail that's being generated. I have the prompt and I say, when you are done, ask me for the next prompt to create alternatives for. So I'm adding this on. I'm saying when you're done, at the end of your output, you're going to ask me for the next prompt to create alternatives for. So notice what I'm doing. I'm actually using the ask for input pattern. I'm saying at the end of the input, at the end of the output that you produce, you're going to ask me for the next input. So you're going to ask me for the next task to accomplish. And I'm telling it, you're going to ask me for the next prompt to create alternatives for. So I'm also reintroducing the rules of the game. I'm describing what the purpose of the input is that I'm going to be giving it and what it's supposed to do with it. And I'm making sure that this shows up at the end of my prompt, at the end of the output that the large language model is going to produce. So I've defined the rules and I've said at the end of what you do, you're going to reintroduce this rule by basically asking me for the next input to create alternative prompts for. So let's see what happens. So I add this tail on, and so I'm generating a tail. I'm using the tail generation pattern, and I say, write a prompt for ChatGPT to automatically detect questions in a chain of emails and summarize everyone's opinions on the question as bullet points beneath each question. So I've given it the task. Here's what I want you to write me some possible prompts for. So I would give it the instruction. It's now going to write the prompts, and it generates a bunch of prompts for me, right? So now I've got all these alternative prompts, and then the last thing it does is it generates the tail, just like I said. So it says, please let me know if you have another task for which you would like me to write a prompt and create alternative approaches for. So right here, it's created a tail on its output. It's at the very end, and it says, please let me know if you have another task for which you'd like me to write a prompt and to create alternative approaches for. You notice that its sentence that it's created encompasses a lot of the rules. It encompasses enough of the information about what it's trying to accomplish that we don't have to worry as much that it's going to forget the rules. And so then I go and I give it another task. I say, write a prompt to evaluate different prompts for summarizing the questions. And it goes through and it generates all the prompts, which we saw before. And then at the end, it generates the tail again. Please let me know if you have another task for which you'd like me to write a prompt and create alternative approaches. So we've got it to reintroduce the task again. And so now if we went in and we put in a new prompt, it still will remember what the context is. And if we went in and we had, back and forth without this, at some point it's going to forget the rules of the game. And it's going to say, hey, what am I supposed to do? Or it's going to forget to generate alternatives, or it's going to do something else. But by continually reintroducing the rules, of the game as this tail on the output, then every time we go to send in a new input, just recently we had the rules of the game that give it the context that it needs to accomplish the task. So the tail generation approach is really, really useful when we're going to have a longer conversation, where we're going to try to program something. We're going to give it a bunch of rules up front, and then we're going to have a whole bunch of interactions, and we don't want it to forget the rules or the context. Now, it doesn't have to be rules. It could be anything that we think that needs to be reintroduced over and over into the conversation. And what we do is we just make sure that at the end of the output, we ask it to put in whatever that tail is. It could be asking for the next input. It could be, asking for some other additional information. It could be redescribing the rules. It could be kind of whatever you want it to be, but it's like a little nugget, a little tail that we're going to attach to that output to remind the large language model, here's what we've been talking about, and give yourself a little hint about it at the very end before we go on to the next task. Large language models really excel at working with text and understanding patterns of language. And a lot of times text is something that's really difficult to work with because we tend to have a human go and look at it to do a really good job of analyzing. Well, or we used to need a human to do that. Now we use large language models. But, going through and trying to understand text and manipulate text is one of the real strengths of the large language model. The next pattern is called the semantic filter. So this is basically a filter that can take in text and remove information from it, or only keep information that has certain meaning or has a certain qualities that we specify. And so this can be a really useful pattern for a variety of different cases. Now I'm going to show it in the case of taking text and filtering out or removing certain things that we would like to get rid of from those texts. This might be secret information of some kind. It might be, removing things that aren't public. It could be all kinds of different things, or removing redundant information, whatever you need it for. But this is kind of a useful pattern in taking and manipulating text. So let's look at an example of it. So I'm going to start off with a very simple example of the semantic filter. And I'm going to say, filter this information to remove all dates and rewrite the text as little as possible to fix issues caused by the date removals. And then I've pasted in some information about Vanderbilt University from Wikipedia. And in this information, there's a whole bunch of dates. And so I'm creating a complex filter that's going to basically take in information, it's going to remove all the dates, and it's also going to transform the information a little bit to rewrite it, just in case I'm removing a date and it sort of makes a sentence awkward, or there's obviously something missing. And so I'm going to take in information, I'm going to remove all the dates, and I'm going to slightly rewrite in order to do this. So I've got the Vanderbilt now Wikipedia information, and by using this pattern, which is to clearly say that you're going to serve as a filter, so we're going to say filter this information. So we're clearly indicating by saying filter that we want to preserve but remove. We're not trying to create new, we're trying to take in information and filter out or remove. So the pattern is basically, the semantic filter pattern is, we're going to tell it to filter something, and we're going to give it sort of rules, semantic rules, rules about the meaning and what we're trying to remove, the meaning or the purpose of what we're trying to remove. So then what it does is it goes through and it rewrites all the text, and you notice that it does a pretty good job. It removes all of the explicit dates. Now, one thing I noticed is that I might need to go and rethink my prompt and how to express dates, because it says founded in the 19th century, and that might be too specific for me depending on what my meaning of date is. So I think it took a literal interpretation of it, like if it's a specific date. So if you go back and look, it originally said founded in 1873, so it removed the date 1873 and replaced it by rewriting it with founded in the 19th century. So it's actually kind of removing information, but I asked it to rewrite, so it's transforming it a little bit. But this shows you kind of the power. It's understanding the text, it's understanding what a date is, it's removing it, and in this case, we're also transforming it to rewrite it in some way. Now let's show you a more interesting example, and kind of where semantics and understanding of the meaning of things really gets used. So I'm going to say filter the information below to remove any information that would help someone figure out that the patient has diabetes. First, explain what information you're going to remove and how it might help someone figure out that the patient has diabetes. Then provide the filtered information. So what I've got below is a fictitious medical record that describes a patient, Jane Doe, has a number of symptoms. The patient presents to the clinic with complaints of increased thirst and fatigue for the past 2 weeks, history of present illness right here, past medical history down here, medications down here, allergies, a variety of things. And then I'm going to actually have ChatGPT go into a semantic filter on this information. So now let's take a look at what it's going to remove. So it says, well, the chief complaint of increased thirst and fatigue should be removed because increased thirst, polydipsia, is a common symptom of diabetes. The history of present illness mentions increased thirst and not checked her blood glucose levels, both of which should be removed because they are related to diabetes symptoms and management. The past medical history includes type 2 diabetes mellitus, and I apologize if I'm mispronouncing this, which should be removed because it directly indicates that the patient has diabetes. The medication metformin, 1,000 milligrams twice daily, should be removed because metformin is a medication commonly used to manage diabetes. So this is taking the semantics of, I want things that could give away that this patient has diabetes. I want them filtered out and removed, so I'm giving some semantic rules about what type of information to get rid of. It has to understand to some degree the meaning in the text, or at least know, based on its training data, that these are things that are commonly discussed around diabetes. So one way or the other, it's figuring that out. And then it goes through and rewrites the medical record. And notice it rewrites the chief complaint be to the patient presents to the clinic with complaints of fatigue for the last 2 weeks. The patient reports that she's been feeling more fatigued. She denies any recent weight loss, blurry vision, or infections. Past medical history is rewritten. The medication is rewritten. And so now we have a filtering of what was here before. And so we notice that, like the history, it removed this. The patient reports that she has been experiencing increased thirst for the past 2 weeks. So we can use these large language models to develop sort of powerful semantic filters using the semantic filter pattern. Now, is it perfect? No. As we've seen, there can be, issues with it. And as we've talked about before, they're not always perfectly repeatable. But as a starting point to help maybe support a human process that then looks over it a second time, or to try to help prevent accidental release, it's just one more check in the system. This is a fairly low-cost check to try to remove extra things. Should it be the only check? No. If we're going to filter things out, particularly for privacy or other reasons that are where we have information that we don't want to get out, we should always have other checks in place because this is not going to be a perfect filter. It's going to have some randomness. It's going to not always do exactly what we expect, but as a part of another process, as a component to help, it's a very, very powerful technique that we could potentially employ in parallel or in conjunction with other checks, other types of removals. Thank you, everyone, for taking this course on prompt engineering. I hope that you'll feel inspired by all of the different examples to go out and really try to build interesting application using large language models. The thing I always want to emphasize in these discussions about large language models is the real power of these language models comes out through human creativity. If you have creative ideas, creative ways of using the tools, that's where you get really exciting outputs. A lot of the discussion we've seen is about bad outputs, and I just look at that as a failure in the use of the tool. You want to go and really try to be creative in how you use it. Come up with really great ideas. Find the problems that are really hard to solve using other approaches. And so I hope you'll be inspired like I am to really try to think about this tool. Again, I think of it as a tool for helping to quickly give my thoughts form, to do things faster and in unique ways that I couldn't do before. As an artist in my earlier part of my career, I've always been excited about working in different mediums. You know, I could work in paint, or I could work in ceramics, or I could work with metal. And all of these different mediums have different unique characteristics to them. And I look at ChatGPT as another exciting medium for creativity, for coming up with new ideas and trying to give them shape, to give them form, just like I would in paint, just like I would in sculpture. So I hope you'll be excited to explore this new medium. And as one last final thing, I think it's always important to go back to ChatGPT and get its thoughts on what we should tell you as you leave the course. And so I think it's got some good points here. So I asked ChatGPT to act as the teacher of a course on prompt engineering, to thank students for being in the course and tell them about what they should do for next steps. And it's got some great points here. One, practice, practice, practice. I can't emphasize this enough. Really, a lot of the great things are going to come through you practicing and experimenting with ChatGPT or another large language model and asking the question, can I get it to do this? Wouldn't it be great if I could get it to do this? And a lot of times the answer is yes with some creative prompt engineering. So please practice, practice, practice. Stay up to date with the latest research and developments in prompt engineering. It's a very quickly moving space. If you go to Archive, where we've listed some of the papers on prompt engineering there, you can find all of the latest updates. And I hope that you'll follow with what's going on and keep seeing all of the exciting discoveries that people are making. It's such a new space. Everybody can be at the forefront, riding the wave right now. And so I encourage you to do that. Collaborate with others. This is one of the things that I really enjoy about working with large language models, is there's so many people that are just as excited as I am. And when we get together, we come up with crazy ideas. Well, what if we did this? What would it look like if we had them talking to each other? What if the large language models were talking to each other? What would we do differently? Or how would they, word things differently? There's all kinds of fascinating ideas, and those ideas really come out through collaboration and also from just looking at what different people are doing, how they're sort of approaching prompt engineering. So I encourage you to collaborate with others. And then finally, to keep ethics in mind, there's a lot of the discussion around ethics with these models. And I think it's really important, particularly as the early sort of adopters of this technology, that we use it in an ethical and appropriate way, that we show all of the good things that can be done with it rather than showing bad things. If we keep adding to the negativity around these models, what we're going to do is we're really going to dissuade people, and we're going to have people miss all of the wonderful opportunities to do interesting and creative things. So please, please, obviously keep ethics in mind. So I think this is a great wrap up from ChatGPT. Again, thank you so much for participating in this course. I hope you'll be engaged in the discussion forums. I hope you'll keep sharing prompts and interesting ideas that you have with the community and around this course. And again, I can't wait to see what everyone in this course does with prompt engineering and all the amazing things that you create.
Thanks you for watching my video. Please like and subscribe my channel. Thank you for spending your valuable time with us. Your views and support mean the world to us. We couldn't do it without you. Thank you for being a loyal viewer.